Welcome to the Bash Shell Scripting Guide. In this lesson, we will introduce you the shell and explain the purpose of shell. We will also look at different other types of shell and what is their use. So first, the definition of shell. A shell is a command line utilities which interacts with the kernel on user's behalf. It interprets the message which users enters from the console or terminal. So it's basically kind of a interpreter because a kernel can understand a message in certain format. Kernel has a well-defined interface to interact with it due to security. For example, a kernel cannot understand most of the stuff except for the calls through system call. So which means a user which wants to interact with the kernel has to write a system call, which is not possible all the time. So what a shell does is take the input from the user, massage the input, make it in such a way that the kernel can understand and call the necessary system call on behalf of the user and get the message back from the kernel and present it to the user. So shell is nothing but a command line interpreter. There are different types of shell and we will look into mostly bash shell because it's the most predominantly used one. There are other type of shell like C shell, Corn shell, TCSH, ASH. We will go through each of them. So on the broader way, there are two categories in which all the shell lies. One is C shell categories and one is the Bourne shell. C shell categories, the shell which lies are C shell itself and the TCSH. The name C shell has been given because when it was written in such a way that it understands some of the C type syntax. C type, not exactly, it's not a C language, but C type syntax. Bourne shell is a native shell which was written first, and then there was an extension to that which is a bash, and then there are other shell like Corn shell and PDSH which are kind of similar but not same. In this lecture and video, in the entire video series, we will be learning only bash shell. Most of the things which you learn will be applicable to Corn, PDSH, Bourne, all kinds of shells. They are almost similar, but there are still some differences. But C shell is very different. So whatever you learn will not be applicable to C shell, but for all other shells, it would be almost similar, and probably you can say 80 to 85% of the things matches between all these shells. So what is there are other things which shell can do. For example, shell can interpret the input and present it in a way so that kernel can understand. So what I mean by this statement is like this. So for this exercise, for this entire tutorial, we will be using Ubuntu and I will be doing hands-on on Ubuntu. I'm using Ubuntu as my virtual machine. This is my Ubuntu machine and we will learn everything practical on Ubuntu. It will be same for CentOS or maybe Mint or Kali Linux, whatever you want to use. But Ubuntu is amongst the best in terms of desktop applications, ease of use, so we will go for Ubuntu. So let me tell you what I meant exactly by it interprets users commands. So there is one command called echo, and echo means whatever you write it will just echo back onto the screen. Simple. Something like printf in any other language, printf or println. So I said echo hello world and it just printed hello world. It's just echo. Now if I say echo star, let's see what it gives. You see, when I say echo star, it says desktop. It's not giving me star because there is one folder called desktop here in my present working directory, and that's what it is showing. Now let's suppose if I go to some other directory and I say echo star, what it gives. it lists out all the files and folders present in this directory. Something, if you are familiar with ls, something what ls command does. So it seems like echo star is interpreting what is a star. Now let's suppose if I just want to echo itself, I can have it as a string literal, and then it will echo just the star. There is a difference between double quote and single quote. We will learn through all of these. So now here also the double quotes it will say star, but still there is a difference between these and this in terms of variable expansions. We will go through all of this in some of the later chapters, but what I wanted to show you is about the interpretation. So what is happening exactly is when you say star, star is treated as a wildcard. So wildcard means it will try to grab all the files and folders in the particular folder where you have executed the command, and it tries to see, okay, what are all the things present in that folder. That's the way it does the command substitution, and that's why it is giving. If you just say star, it's a, but if you say echo j some character, it will say j because j doesn't falls under some kind of wildcard. That is exactly what I meant by interpretation. So whatever you type may not be exactly whatever it is presented to the kernel. There is something else which is presented to the kernel. So this shell scripting would be applicable to almost all kind of POSIX compliant OS. By POSIX I mean to say like Mac OS X. If you're using the terminal of Mac OS X, you can use bash shell scripting. You can use in FreeBSD, and of course on Linux. In Linux you can do it in different kinds of flavors like Ubuntu, CentOS, Fedora, Mint, Kali Linux, and whatnot. Whatever flavor, almost all of them has the bash shell. And in Windows 10 nowadays they're coming in with bash shell as well, so you can use Windows 10 also to do some of the exercise, although I cannot comment exactly how complete they are, but you can give it a try. Now what is the shell which you will be using? Now since there are C shell, bash shell, ASH, conn shell, so how do a user know which shell he will be using? That is something which is being set by the administrator when he creates your user account. So when a user account is being created, that account entry goes into a file called etc password, and in that etc password there is the last field. This field signifies what kind of shell you want to use. If instead of bin bash, if I would have said slash bin slash ash, it should have taken ash shell, or maybe sh, which is bourne shell. Bash is born again shell, and the first shell was sh, which is bourne shell. So this way we can change the shell entry. There are other fields which I will explain in details in some other lectures as and when we come across all these things, but this is just a starting and I would like to give you some introduction for this shell. The other easy way is finding out your shell is you go to your terminal and say echo $shell. We will go through the meaning of dollar and how to do variable expansion, what is a variable, everything. So if you say echo $shell, it will tell you the kind of shell it is. Let's suppose if you were in ASH shell or SH, it would have given you something like bin SH or bin KSH for K shell. Now, how does the shell looks like in terms of hardware and kernel? So this is the way it is. So hardware is at the very bottom, and then on top of hardware we have a kernel which controls the hardware and resources. The kernel has entry points. If you want to enter into the kernel, talk to the kernel, you have to go through system calls. System call are absolutely must to interact with the kernel. A kernel cannot understand anything and absolutely anything except for system call. At least this is the way Linux works. And then shell interacts with the kernel using system call. So remember I said like, okay, it's an interpreter. So let's suppose take an example for echo star. So what does the shell does? Shell does says, okay, I want to expand all the names with respect to the files present in the current directory. So what echo might be doing in that terms is take the current directory and recursively tries to find out how many files are present. The way to find out all the files which are present in a particular directory, it must be doing dir entry kind of system call to the Linux kernel, getting all the response back to the shell, and then showing you all the files and folders one at a time. And then of course you can have your own custom applications which can talk to the system call and in terms interact with the kernel and probably can interact with the hardware. And this is the user, you sitting on top of that running applications using system calls, contacting kernel, and same way user using shell script and running. So this is the way shell script works. Now shell script is just an interpreter, so let us also go through what is the kernel. Kernel is the heart of operating system. In case of Ubuntu, Fedora and this kind of OS, it manages the resources like CPU, memory, disk. For Windows also it does the same, but the kernel functionality like in terms of device driver, file system, the way everything is a file in Linux is not the same in Windows. So we will not go into those kind of details, but just an introduction. So kernel is something which manages all your hardware, manages all your hardware resources. And when we say resources, the resources are mostly like CPU, memory, disk, and IO. Now in contrast, shell just interacts with the kernel and give the work to the kernel, and it is the kernel which does all the work and gives the output back. So if you look at the diagram, how does the shell and different kinds of utilities in the system looks like, it would be like this. So hardware is at the very core of the kernel, means it's not a part of a kernel, but in this diagram it is at the very core, at the heart. On top of that is a kernel. Kernel protects the hardware, which means kernel is the one which would be using the hardware. It will not allow a user applications to interact with the hardware directly. And on top of that, there are different kinds of applications or utilities, or maybe there is a shell. Here it is sh, which is a bourne shell. It could have been bash shell. And then there can be other applications which can be directly contacting to the kernel through system call, or these applications might interact through the bash shell and in turns goes to the kernel. When I say directly, right now it is possible, but the way typical applications run, all the applications you open a terminal and run in a terminal. Now when you open a terminal, it's a bash shell. So that's why these other applications goes through the shell only. It cannot go directly, but it is even though possible that without any terminal you can run it, but it might not be that interesting. We will learn all these concepts in the upcoming videos, and I will also tell you what all the different kinds of commands, utilities, and the scripting we will be doing in my next video. Thank you for watching. Welcome to the Bash Shell Scripting Guide. In this lesson, we will introduce you the shell and explain the purpose of shell. We will also look at different other types of shell and what is their use. So first, the definition of shell. A shell is a command line utilities which interacts with the kernel on user's behalf. It interprets the message which users enters from the console or terminal. So it's basically kind of a interpreter, because a kernel can understand a message in certain format. Kernel has a well-defined interface to interact with it due to security. For example, a kernel cannot understand most of the stuff except for the calls through system call. So which means a user which wants to interact with the kernel has to write a system call, which is not possible all the time. So what a shell does is take the input from the user, massage the input, make it in such a way that the kernel can understand and call the necessary system call on behalf of the user and get the message back from the kernel and present it to the user. So shell is nothing but a command line interpreter. There are different types of shell, and we will look into mostly bash shell because it's the most predominantly used one. There are other type of shell like C shell, Corn shell, TCSH, ASH. We will go through each of them. So on the broader way, there are two categories in which all the shell lies. One is C shell categories and one is the Bourne shell. C shell categories, the shell which lies are C shell itself and the TCSH. The name C shell has been given because when it was written in such a way that it understands some of the C type syntax. C type, not exactly, it's not a C language, but C type syntax. Bourne shell is a native shell which was written first, and then there was an extension to that which is a bash, and then there are other shell like Corn shell and PDSH which are kind of similar but not same. In this lecture and video, in the entire video series, we will be learning only bash shell. Most of the things which you learn will be applicable to Corn, PDSH, Bourne, all kinds of cells. They are almost similar, but there are still some differences. But C shell is very different. So whatever you learn will not be applicable to C shell, but for all other cells, it would be almost similar, and probably you can say 80 to 85% of the things matches between all these shells. So what is, there are other things which shell can do. For example, shell can interpret the input and present it in a way so that kernel can understand. So what I mean by this statement is like this. So for this exercise, for this entire tutorial, we will be using Ubuntu, and I will be doing hands-on on Ubuntu. I am using Ubuntu as my virtual machine. This is my Ubuntu machine, and we will learn everything practical on Ubuntu. It will be same for CentOS or maybe Mint or Kali Linux, whatever you want to use, but Ubuntu is amongst the best in terms of desktop applications, ease of use, so we will go for Ubuntu. So let me tell you what I meant exactly by it interprets users commands. So there is one command called echo, and echo means whatever you write, it will just echo back onto the screen. Simple. Something like printf in any other language, printf or println. So I said echo hello world, and it just printed hello world. It's just echo. Now if I say echo star, let's see what it gives. You see, when I say echo star, it says desktop. It's not giving me star because there is one folder called desktop here in my present working directory, and that's what it is showing. Now let's suppose if I go to some other directory and I say echo star, what it gives, it lists out all the files and folders present in this directory. Something, if you are familiar with ls, something what ls command does. So it seems like echo star is interpreting what is a star. Now let's suppose if I just want to echo itself, I can have it as a string literal, and then it will echo just the star. There is a difference between double quote and single quote. We will learn through all of these. So now here also the double quotes, it will say star, but still there is a difference between these and this in terms of variable expansions. We will go through all of this in some of the later chapters, but what I wanted to show you is about the interpretation. So what is happening exactly is when you say star, star is treated as a wildcard. So wildcard means it will try to grab all the files and folders in the particular folder where you have executed the command, and it tries to see, okay, what are all the things present in that folder. That's the way it does the command substitution, and that's why it is giving. If you just say star, it's a, but if you say echo j some character, it will say j because j doesn't falls under some kind of wildcard. That is exactly what I meant by interpretation. So whatever you type may not be exactly whatever it is presented to the kernel. There is something else which is presented to the kernel. So this shell scripting would be applicable to almost all kind of POSIX compliant OS. By POSIX I mean to say like Mac OS X. If you're using the terminal of Mac OS X, you can use bash shell scripting. You can use in FreeBSD, and of course on Linux. In Linux you can do it in different kinds of flavors like Ubuntu, CentOS, Fedora, Mint, Kali Linux, and whatnot. Whatever flavor, almost all of them has the bash shell. And in Windows 10 nowadays they're coming in with bash shell as well, so you can use Windows 10 also to do some of the exercise, although I cannot comment exactly how complete they are, but you can give it a try. Now what is the shell which you will be using? Now since there are C shell, bash shell, ASH, con shell, so how do a user know which shell he will be using? That is something which is being set by the administrator when he creates your user account. So when a user account is being created, that account entry goes into a file called etc password, and in that etc password there is the last field. This field signifies what kind of shell you want to use. If instead of bin bash, if I would have said slash bin slash ash, it should have taken ash shell, or maybe sh, which is bourne shell. Bash is born again shell, and the first shell was sh, which is bourne shell. So this way we can change the shell entry. There are other fields which I will explain in details in some other lectures as and when we come across all these things, but this is just a starting and I would like to give you some introduction for this shell. The other easy way is finding out your shell is you go to your terminal and say echo dollar shell. We will go through the meaning of dollar and how to do variable expansion, what is a variable, everything. So if you say echo dollar shell, it will tell you the kind of shell it is. Let's suppose if you were in ASH shell or SH, it would have given you something like bin SH or bin KSH for K shell. Now, how does the shell looks like in terms of hardware and kernel? So this is the way it is. So hardware is at the very bottom, and then on top of hardware we have a kernel which controls the hardware and resources. The kernel has entry points. If you want to enter into the kernel, talk to the kernel, you have to go through system calls. System calls are absolutely must to interact with the kernel. A kernel cannot understand anything and absolutely anything except for system call. At least this is the way Linux works. And then shell interacts with the kernel using system call. So remember I said like, okay, it's an interpreter. So let's suppose take an example for echo star. So what does the shell does? Shell does says, okay, I want to expand all the names with respect to the files present in the current directory. So what echo might be doing in that terms is take the current directory and recursively tries to find out how many files are present. The way to find out all the files which are present in a particular directory, it must be doing dir entry kind of system call to the Linux kernel, getting all the response back to the shell, and then showing you all the files and folders one at a time. And then of course you can have your own custom applications which can talk to the system call and in terms interact with the kernel and probably can interact with the hardware. And this is the user, you sitting on top of that running applications using system calls, contacting kernel, and same way user using shell script and running. So this is the way shell script works. Now shell script is just an interpreter, so let us also go through what is the kernel. Kernel is the heart of operating system. In case of Ubuntu, Fedora, and this kind of OS, it manages the resources like CPU, memory, disk. For Windows also it does the same, but the kernel functionality like in terms of device driver, file system, the way everything is a file in Linux is not the same in Windows. So we will not go into those kind of details, but just an introduction. So kernel is something which manages all your hardware, manages all your hardware resources. And when we say resources, The resources are mostly like CPU, memory, disk, and IO. Now, in contrast, shell just interacts with the kernel and give the work to the kernel, and it is the kernel which does all the work and gives the output back. So if you look at the diagram, how does the shell and different kinds of utilities in the system looks like? It would be like this. So hardware is at the very core of the kernel, means it's not a part of a kernel, but in this diagram it is at the very core, at the heart. On top of that is a kernel protects the hardware, which means kernel is the one which would be using the hardware. It will not allow a user applications to interact with the hardware directly. And on top of that, there are different kinds of applications or utilities, or maybe there is a shell. Here it is sh, which is a bourne shell. It could have been bash shell. And then there can be other applications which can be directly contacting to the kernel through system call, or these applications might interact through the bash shell and in turns goes to the kernel. When I say directly, right now it is possible, but the way typical applications run, all the applications, you open a terminal and run in a terminal. Now when you open a terminal, it's a bash shell. So that's why these other applications goes through the shell only. It cannot go directly, but it is even though possible that without any terminal you can run it, but it might not be that interesting. We will learn all these concepts in the upcoming videos, and I will also tell you what all the different kinds of commands, utilities, and the scripting we will be doing in my next video. Thank you for watching.
Hello and welcome friend. In this tutorial we will try to look at how to run a bash shell script in Mac. So by default in Mac OS X you will always get a terminal, and if you guys are aware of that, Mac OS X is based out of FreeBSD kernel and some parts out of BSD kernel, so they are more like a Unix and Linux rather than Windows. So they have taken the kernel from FreeBSD. On top of that they have put a UI layer and they have created this entire operating system. So that's why Mac OS X was POSIX compliant long before Windows. So the way to run a bash shell scripting any bash is you go to the launchpad, and by default you will get this icon terminal. You will not have this item, we will come to this later on, but you will get the terminal and you can open the terminal and start typing. This is giving you the shell, and when you go to the terminal you have different options of selecting the profile, like you can select whatever theme you want to choose, and if you want to make something as permanent as default, you can go to the terminal and preferences, choose whatever you want to use and set it as default, and next time when you open the terminal that default one will open up for you. So I have chosen this. Now this is my default. That's the way it works. Now let's quickly run through some of the commands. So if we are wanted to be familiar that okay, this is actually working, so let's see. If I say echo $shell, you see it will tell me the bash bin bash, and if you go and do it similarly on the Linux, so I have another machine as Ubuntu machine. This is my Linux, and if I say echo $shell, it will tell me exactly the same thing. So that means by default the terminal which you fire up in Mac OS and the terminal in Linux, they both run bash. So they are both supporting bash, both operating systems are supporting bash, and in the terminal the shell which is running by default is a bash shell. So all the scripts and everything in bash will work exactly like same. Now where the difference would come? The difference would come with respect to some of the commands which I will list you right now. Now before going any further, and I wanted to show you a side to side picture between Linux and Windows, so I wanted to suggest you something more than this. So terminal is good, this terminal is good for many of the work, but I find it little hard in terms of splitting the screen. Like if you say Control D or Apple Command and D, it will split it horizontally rather than vertically. That's what I want, and at least I don't find any features to split vertically. and then copy and paste is not so good as compared to item. So there is another project, Mac OS project, which in which you can download item 2. Now I feel that item 2 is much better, advanced, more customizable than the default terminal which it comes. So you might give it a try. You can download and just install this. So I already have it installed in my system here, and I will use this. And don't worry about black and white. You can choose any theme by going to the item preferences, and you can go appearance, windows, whatever arrangements. You can choose any of the themes, keys, advanced options. So you can do many of the customizations here. So it has lot of customizations. You can choose color and customize here, color presets, whatever you want to do. I don't want to change it now, but if you want, you can do something like this. So this looks better for me with light background, so let's keep it like this, and I will increase the font for now. Okay, so now this is my terminal, and on this machine, this is my Mac. I am also running a virtual machine for Linux, and if I wanted to show you, it's here. So I have two virtual machines, and one is this Linux, and Windows we don't care for now, so let's not talk about that. And this is my, so what I will do is I will open one more terminal. I split it by Apple and D, so which is Apple command and D, and I increase this. In this terminal, I will, on the right hand side, I will remote login SSH. We will come and look into these commands later on. So on the right hand side, I did a SSH to my Linux Ubuntu machine, and on the left hand side, this is my machine, which is Mac. Now if I run the command uname -a on my Linux machine, which is a Ubuntu machine, you see this is a i686 386 machine. It's basically a 32-bit Linux machine, Ubuntu. And on the left hand side, if I run on the Mac, you see that it says the kernel as Darwin. So Mac OS kernel, they named it as Darwin, which is a derivative of FreeBSD, and you have some of the versions and everything else. But if you run the same uname command on Ubuntu or any other Linux based distributions, you will see it as Linux rather than Darwin. So those are the small differences you will see, some little bit, but in terms of general bash syntax like for loop, if loop, conditional statements and case statements, everything will remain the same. So whatever is dictated by POSIX is a set of compliant standard for this kind of things. So both bash from the Mac OS X and Linux and maybe some other Unix, whatever is POSIX compliant, they will all follow the same standard. Now someone might try to add extra feature which is apart from POSIX, but at least the basic POSIX part, if you're using the POSIX part of bash shell script, it will work irrespective of Mac OS X or Linux. Now let's try to run a small test script on both Linux and Mac just for demo. Let's see this. Oh, there is already something here, but let me just clean it up. I will not go for this advanced topic, so I'll just write one small for loop. So I'll say while true, this means always true, then do, we will go through all this syntax later on, and I say echo hello, and I don't want to have a very tight loop, so I will say sleep and done. And let me run this script. Now if I run this script, and first let me copy the same script to my Ubuntu also, so that I can run the same script exactly at both the places. So we test.sh, chmod. With chmod I am giving all the permissions, so chmod will change the permissions. So I say sudo, okay, and I run this script. So every 1 second it will print hello. This is Linux on the right hand side, and then same thing I have to run on Mac OS. I don't have the mode set, so I could either say bash./test.sh, or I can say chmod 777 or u+x, and I would say test.sh. And now if I run /test.sh in my current path, they both run. So you see the same script is running on left hand side, which is my Mac, and on the right hand side, which is on Linux. So basically you can say this comes as very handy that you don't have to do anything extra to run a bash shell scripting in Mac. Everything comes already installed, all the utilities and everything. Now let's look at some of the smaller differences. Now mind it, the differences which I am mentioning is not with respect to bash, but it might be helpful for you to understand when you are coding some scripts which require some commands. So let me tell you one example. Let's see, there is a command called hostname which will give you the host name of the system, basically a name, not the IP address. Fine, it works on Mac. Let's try to run on Linux. It works on Linux. Very good. Now if you go and set the man hostname on Linux, if you see there is an option called -i which will give you all IP address. Okay, so this will list out the IP address. Let's try to do this on Linux. You see, it give me the IP address. If I want to get the IP address, I could have done ifconfig also, and it would have given me the exact same IP address. But with hostname also, you can get IP address on Linux. Now, having understand that, let's try to do the hostname -i on Mac. What? It says I is an illegal options. So you have to see some of these commands between Linux and Mac. They might have a different options or no options, or the command might behave differently. So it's about command. It's not exactly about bash. Bash is command plus the bash script and the bash looping conditional statements, everything clubbed together. So you have to be careful about this. You could also say man hostname. If the man page is already there, you can see what are the options they have. So they don't have much options in Mac. Maybe it's not needed. Okay, so that's one example. Now let's suppose I wanted to see how many disks I have in my system. So let's go to the Finder and see. I have only one extra disk, which is my Samsung. Of course I have the default Mac disk that's there, but this is my extra disk which I have put in my system. So there is this command called diskutil. So if you say diskutil and run just that, you will see a lot of options. You have to choose one of the options. There are a lot of options. Be careful not to run options like resize, partition, or zero disk. Some of them might corrupt your disk. So you have to be careful what you are doing, or you understand what you are doing. So let's suppose with diskutil, if I say list, it will list me. Let me make it a little smaller so that it's easy to visualize in one single screen. Okay, clear will clear the current screen so that we can go to the top and look freshly. So I say diskutil and list. Now you see here, maybe I wanted to make it a little more smaller. Sorry, let's make it a little more smaller and this screen bigger. Okay, so if you see here diskutils, it will tell me that I have basically 3 disks. Now let's look through that and what does it say. So dev disk 0, one internal disk. That's mean I cannot pull it out directly without opening my MacBook chassis, MacBook backside. And then this is 500 GB size, and this is a good partition. And you see that it says that out of this disk 0, 2 partitions are created. One is 314 MB and the other is 500 GB. So the way partition is created in Mac is dev disk 0 and then S1 S2. So disk 0 S1 S2, this is part of this. Now if you see the another one, disk 1 synthesized, this says that I have 500 GB disk 1, and then I have some pre-installed Mac, pre-boot, recovery, and all those things. So what happens is exactly they have created a disk 1 out of the existing disk 0, and they have put a pre-installed Mac OS. And the way to understand this is, let's suppose in Linux, if you are trying to format a disk, you will format the disk, and when you want to install, you have to install freshly from the ISO or someplace on the DVD, CD, whatever. You can do a PXE boot in Linux also, but to do the PXE boot, you have to set up the PXE boot. In Mac, over the network. It's not exactly Pixie Boot. When you want to reinstall your operating system over the network, you can reinstall because you have already some pre-image stored into the device. So they have some of the pre-image recovery, everything already created by default. So let's not worry much about that. Then the second, this is the interesting part. This is my external drive. This is my Samsung drive which I have created and put. It's a USB device, and this is again 500 GB disk, and out of that disk 2 it has created partition disk S1. Now this is disk util. Now let's suppose I wanted to run the same command in Linux. Will it work? Disk util? There is no disk util. So how do I run in Linux? So in Linux there is this command called fdisk, and in fdisk it will tell you dev sda. You can say fda -l. So I'll have to run with a sudo, of course. Sudo means with the super user permissions. By default you don't have the permissions to access and look for those kind of devices, and it again depends. In here Mac, it showed me the information, but if I would like to modify something, it might ask me for sudo here also. Okay, now if you see here in Linux, I said fdisk dev sda -l, and it tells me that I have a 200 GB disk. And then if I go and look for SDB, so the way devices are named in Linux for disk is dev SDA, SDB, SDC, like that. In Mac you see it's dev disk 0, disk 1, disk 2. That's the way. So there is a difference there. Now let's suppose I wanted to see like how many total devices I have. So in Linux, at least there is no one single command which will tell you everything all together. So you have to run a couple of commands together, clubbed together, to get the understanding of your disk. So there is the command like sfdisk, and then there are some gdisk, parted. There are so many commands. You have to go through all of this and you have to see. So it says you are not a super user. I'll cancel it because you have to run it as super user, and you could say list, and you can run some of the commands here and see okay what all the things you have. You can say print, and it will print you like this. So what is your volume and what is the partitions and everything. So this command makes little bit difference between Mac and Linux, but apart from that it's exactly the same. So happy coding. Start coding in bash shell scripting. It will work. If it doesn't work or you find some difficulties, just drop me a message in a forum or send me personalized email or message, and I will respond to your queries. Thank you all for watching this video, and you have a nice time. Bye.
Hello friends, welcome to the bash shell scripting tutorial. So in this video we will try to go through some of the default directory which are present in a system, in typical system of Linux or Unix. So I have listed some of those directories which are present. Now not all these directories might be present in all the systems. For example, Unix, even though is a POSIX compliant system, but it has many things which are different compared to Linux. So for example, /sys file system might not be present in Unix, or maybe /proc file system might not be present in Unix or Solaris, but it is present in Linux. So most of my tutorials are targeting Linux with respect to Ubuntu operating system, but many of those materials will apply to any other kind of operating system which are POSIX compliant. So let's try to look the first file system, which is /bin. Slash is typically called as root. The top level is the root, the top level, and inside that all other folders are either mounted or present. So we'll go through the concepts of mounting and everything in later videos. So as of now we will just see what is it. So /bin. So root is the top level directory. So let me show you another diagram so that it makes this diagram clear. So root would be the topmost folder, and inside the root there will be a bin folder which is /bin, which means it belongs to the root. So that's the relations between root and bin. So /bin contains the system binaries, home directory contains the user's home directory, so it should be slash home, and inside the home it should be a user like John or a Tom or something else. Dev contains the block device and character device like dev SDA for hard disk or dev SDB for hard drive, or maybe SSD drives, dev SDB. And etc contains system wide configuration file. /lib contains shared libraries and Linux kernel modules like lib/lib/libc.so, that is the shared library. Same thing with lib64, but it is containing 64-bit versions of the shared library. /var contains data which varies over time like var lib MySQL. So MySQL database might be present in /var partitions, or maybe log files are present in var log messages, those kind of things. Sbin contains binary utilities for which only root file system or administrator has access. Mnt is mount point for the file system. Typically Mnt might be empty, but it might also be mounted for some servers. If you log into some servers, and Mnt might not be empty, which means someone has mounted some file system into this particular directory. Temp is for storing temporary data and files. /proc is with respect to Linux kernel data structures which are mounted as read-only file system. We will go through this proc in some of the later videos. /boot contains the init ramfs and the Linux kernel image to boot. And /sys again is a kernel data structure very similar to proc, but it's a different kernel data structure, and both are part of a Linux, but sys is more modern and proc is old, but it used to be having a different purpose with respect to like mounting and seeing the PID of a running process or open file descriptors, memory map. And sys is more with respect to what are the different kinds of hardwares are there, what is the hardware UID is there, what is the different kinds of ACPI and those kind of things. So if you look this hierarchy, it is like this. This is my root file system. Inside that there will be folder called USR, and inside the folder USR there might be an include folder, and inside the include folder there might be one typical file which is always present in all kinds of Unix and Linux kind of operating system, which is unistd. There might be stdlib.h or maybe some other kinds of header files. /bin contains some utilities, so inside the /bin, and there might be other files. I have not shown all the diagrams and all the combinations here. This layout is just to give you some idea how does a typical file system looks like, and that does not mean that okay /bin will not have anything. It might have, and it has many things, but just for clarity purpose I am showing just a part of the tree. Similarly for /home there might be two users like Tom and John, but there might be a number of users. And /lib has shared library and /etc. Now let's try to look into a command. There is a command called tree. In case if you don't have this command in your Linux system, you can install by saying apt-get install apt-get install tree. So it is pretty straightforward. So if you go to any folder, like right now I am in /home in my home directory, and if I list, there is a folder called desktop. So if I run tree and with the folder desktop, it would list out okay what all the files it looks like, how it looks like the entire directory hierarchy. If I go to the /root and I say root, or maybe you don't need to go to root also, you can run from any place, but I just went there, and tree / so it will list out in a tree structure how it looks like. So let's try to do a small demo. I make a directory mkdir John, and I go inside the cd John. Don't worry if you don't know all these commands, we will go through these commands in later videos. So there is called Tom, and then there is called Kelly, and inside the Tom there is a file called vi-test.sh, and I will say echo hi there. Now if I come out of this and you say pwd and you say tree, and then you see, so it shows like this. So the John has a folder called Kelly, and Tom has a file called sh test.sh. So this tree command shows the tree structure. It's a very useful command. just for understanding, this command may not be very useful when writing the shell script, because the output like this might not be good to process. You might have to take a ASCII format, remove all those formatting lines like this pipe characters, it formats and presents it. You have to remove all those things. But this is nevertheless a good command to understand for the beginners. So that's all for this video, and we will post more videos, more utilities, more tools. So thanks for watching. Welcome to the Bash Shell scripting guide. In this video we will look at some of the concepts of operating system. These concepts are similar in terms of Linux and all other modern operating system. So we'll look specifically with respect to Linux. So even though the course is for Linux and Bash, but this applies to an operating system such as Mac OS X or FreeBSD as well. So the first concept is multitasking. What is multitasking? Multitasking means that there are many processes running simultaneously in the system without interfering with each other, and each process would run for a short amount of time, and then it goes to the end of the queue, and then some other process gets scheduled. So this happens so frequently that it gives the notion that all of the processes are running in parallel, but in fact what's happening behind is at a time only certain instruction sets. In fact, on one processor core only one instructions can run at a time. So which means that one process is running and it has executed some n number of instructions, and then the CPU scheduler, the kernel scheduler comes into picture, and it preempts that process, and some other process is scheduled to run on the processor, on that same core of the processor. And this switching back and forth happens so frequently, probably in terms of nanoseconds, that with our bare eyes we could not make out whether this process is running continuously or it is pausing and running. So this is how multitask is scheduled. So it's the main role is CPU scheduler. CPU schedules on many different algorithms like round robin or FIFO or maybe some other algorithms, and that is beyond the scope of this course, but that's how it works. The other concept is multi-user. What it means is that multiple users can log into the system simultaneously, and they can run same kind of commands without interfering with each other again in the same way. So let's suppose one user Tom has logged in through Telnet, and the other user John has logged in through SSH, and they are both running ls command into the top level slash root folder. They both can see simultaneously same file, but they have different context. Each user, when they run a program, a separate executable gets spawned, and it is in his context. It runs in the context of that particular user ID. So that way the operating system can minimize the clash between different users. In fact, there is no clash between different users, and each user will have a different set of disk quota, how much disk you can use. One user cannot monopolize or maybe use like 1 TB or entire disk space, so we can also give disk quota. By default disk quota is not enabled, but if needed we can put disk quota for each user. The last concept is multiple cores. What is multiple cores? It means that all the modern processors, they have more than one core. Even though they have physical one socket, they can have multiple cores or hyperthread. So there might be one socket and then four hypercores, which we call it as quad core. And same thing with respect to 8 cores or 4 cores or core 2 duo like 2 cores. So when there are multiple cores, then multiple cores can run some of the instructions in parallel. And of course, like let's suppose there is one program running, and with respect to that programs, if there are multiple instructions which are running on different cores, then there has to be some kind of synchronizations method with respect to operating systems. Those synchronizations are mostly spin locks, which happens across different cores, or maybe within the same cores it could be mutexes or semaphores. So that way we can utilize multiple cores also by using spin locks in the operating system in the kernel, so that multiple cores are running the instructions in parallel. Note, spin locks is a kernel data structures, and those who are working with kernel or kernel programming or maybe in C, they need to understand that fully. I have told spin locks just for the purpose of giving some introduction and know-how, but spin locks is not a part of bash or shell programming. Thank you for watching my video.
Hello and welcome, friend. Let's try to look at some of the nitty-gritties of environment variable. So before we start, let me confirm that on my right hand side I have my machine as Linux. As you can see with the uname command will give you the name of a kernel operating system. If you say uname -a, it will tell you everything: the name of a kernel, the machine name, the kernel version, is it a symmetric multiprocessing, it's i686 or x86, or maybe like 64-bit, and everything else. Same thing on my left hand side, I have Mac OS X, and if I say uname, it will just say Darwin, and if I say uname -a, it will give me all the details. So just to confirm, I have the environment set up correctly. And mind it, I'm working on Mac, but this machine here is my virtual machine hosted in VMware Workstation inside my Mac. So that's the way I'm able to access. I could have used SSH to some remote machines also. Not necessarily I need to have a virtual machine. I could have SSH to a virtual machine on some other host, or maybe to some other physical appliance. Okay. Now let's try to look at environment variables. So what are environment variables? Environment variables are set of variables which are already defined in your system for some of the things which are logical or which are always needed, like let's suppose path, the path from where the binary needs to be picked up. So let's quickly run this command first to see what it shows exactly. So if you see here in environment variable, you will see the path, and what exactly the path dictates that when you are running some binary, what is the path where it will start looking at. So let's suppose you executed a command called abc, just randomly abc, and if it's not able to find out abc, what it will do is it will try to look in this path first, or if abc exists. If it exists, it will execute from this directory and done. If it's not find here, then it will go to the next directory in the path, and then next, and then this. If it's find anywhere, whichever first it finds, it will execute and it's done. If it doesn't find in any of these, then it will say command not found, file not found, whatever, blah blah blah. So this defines the environment variable. Now if you see here, the difference between Mac and Linux in terms of environment is the directory, the way directory is created. In Mac, if you see, most of the binary whichever you use is in library or is it in application part, but here the same thing in Linux would be not applications. There is no slash library in Linux. In fact, if you see here, there's no slash library. So Linux follows the typical Unix way of user local bin, user bin, /bin, /sbin, those kind of things. Mac also follows, but they have some additional path. So these are some of the small things. Now if you see current working directory, here my home directory is home shekil, and here user /user. So usually in Mac they say /users, not /home, but that's again convention. This can be changed in Linux. So but what I am saying is by default what comes. Okay, now these are the variables. So also one way to visualize environment is, if you guys are aware of Java and has worked in the Java in the path with respect to class path. So you set a class path, you set an environment variable name, and then followed by list of directories separated by semicolon in Windows or maybe colon in Linux, and then you say okay, find my Java files in this folder. So it's the same thing, so it will help you in understanding. Now here if you see here, I don't have a variable called hello. So let's try to do one quick experiment. I have this last script and I would say echo hello, and what we'll do, so this hello variable is not defined anywhere. So what will happen if I run this script? You see, I run hello and there's no output because it's not defined anywhere. Now what I do is I say env, and then in the env I will say a variable name equals to some value world, and if I run env I should be able to see this world also somewhere. It should be listing somewhere. I'll have to just search. So okay, let me see env once, env python grep hello. So it is there. I'm not able to see quickly here somehow, but if I grep it, so it's there. So echo hello has a value called world. So what it means is there is an environment variable called hello which has been set by running this command, and the value assigned value is world for that. Now let's run the test script which I ran earlier. You see, the value is still not there. So why it's not there? Because when you're setting the environment variable, and if you want another shell to be exported, what you have to do is you have to prepend with the command called export. Now if you run the export command and you run the shell script, you will get world hello. So if you see my script here, I don't have a hello anywhere defined, but still if I run this, I will get the hello. Now in this, if I want to unset that, how will I do that? So the way to unset a variable is you say env minus u and you unset hello. Now it will also display everything, but at the same time it will unset. Now since it unsets, let's try to run this. What will happen now? You might assume that it will not work because you have unset the variable. Now see, it is still working. The reason, because it has been removed from the environment variables, but the variable has been exported. So you have to remove from the environment variable as well as you have to do unset. Now if you unset a particular variable hello, that means it's gone. So the shell also doesn't have this variable. Now if I run this, you will see that it doesn't have that value and there is no hello. So that's why it just gives me a blank empty thing. So you have to remember, unset means it will unset the value from the current terminal also. Env will just remove from the environment variable. So when exactly, so then you might be confused when environment will be used, when the current shell would be used. Let's suppose you are writing a shell script, not exactly shell script, maybe C++, and you pass an environment variable. In that case, the environment variable environment would be useful. When you are running a bash shell, most of the time you are also getting your whatever is there as part of your current bash console or bash terminal. Those variables also get exported if you have exported with the keyword export. So things would be little bit more clear as we advance in the course and we see different examples. But if you don't understand some part, don't worry, you will understand later on. Also, I would like to point out that there is one special path. By default, when we say path, we refer to $path, but there is something called LD library path, and which I felt is useful to know, because if you want to run particular library from some predefined path, you have to set this LD library path. The way to set is you can say export LD library path equals to some path. Now let's suppose I will say /lib64, and if I say echo $LD underscore library underscore path, so it will say lib64. So what this means is that when a particular library, let's suppose someone is searching for libc, and if the libc is not there in LD preload or in the etc LD preload, it will try to look in LD library path. So there is set of path in which the library gets loaded. Again, that is, some of them are platform dependent. It works differently on Mac OS X and it works slightly different in Linux. but the way to set a LD library path is same. So you see here, if I set the LD library path, it will tell me, okay, this is the path I wanted to use for library path. Now what this means is that there might be some data. Right now I don't have any data, but what it means, I just have a current directory. Dot means current directory. So if I have some data in the past, and if I want to set it, it will override and it will set just with this. What if I want to retain the existing value and add something to that? So that's why it's always advisable that if you are setting up an environment variable, you don't set like that. What you have to do is you have to set always with whatever the current value is. So you preserve the current value. So you preserve the current value and then you add something new. Now let's suppose this time I say /bin. So I will take a value of LD library path and separated by this colon. So it will add. Now this time if I say echo $LD library path, so you see it was using whatever was there in the previous run and then followed by /bin, and same thing will happen on Linux also. So this is the way to set the LD library path. Same thing you will use for setting your path variable also. So all these paths, they are separated by colon. So that means this is one directory, this entire thing is one directory and separated by semicolon, then another directory. So if you quickly want to set some path, so you can say export. And mind it, if you set a path just with the path variable, it will not be exported to another shell. If you really want to be exported to all the new shell which you spawn, you would have to see that. So you say export path equals to $path colon, suppose MySQL, something like this. Whatever, it has to be valid path. Now if you say echo $path, you will see MySQL. Okay, so let me show you something quickly. Now when I say export, let's suppose you don't say export and you say MySQL12, let's suppose, and if you say echo $path, so you will see that MySQL12 is there. Now if I want to spawn a new shell, I can just say bash. Bash will trigger a new shell and it went to a new shell. So if you might have not seen any difference because it's just the same terminal, same shell, but actually the shell got changed. What if I do echo $path now? What will happen now? You see there is no SHA-2. Okay, so if you look at my TTY, the terminal type, you see it's a Dev TTY S001. The way TTY is there in Linux, just to mention the difference between Mac and Linux, the way TTY is represented in Linux and Mac is slightly different. So you'll see like this. So you see the TTY number is TTY S001. If I come out of that and with Control D, so I press Control D, then only it exited. You could have said exit also. And then you see S001 TTY is still there. Now in this terminal, if I say echo $path, you see SHA-2 is there. So when I spawn a new shell by bash command and I went to that shell, I don't see SHA-2 variable, SHA-12 variable, but in the shell where I have executed, I was able to see. Why? The reason is when you set a path like this, what will happen is it will set for the current shell only. So if you want a new shell which gets spawned and in that shell you need this variable, you have to say export path. And that way it will work. If you're spawning a shell, running a script, there it will work for you. So that's the reason for the keyword export. So thank you all for watching this video and I hope to see you in my next video. You have a nice day. Bye.
Guide. In this tutorial, we will try to look at some of the commands which Linux has to offer. Most of these commands also applies to Unix and Unix-like operating system like Mac, OS X or FreeBSD. The first command which we would try to look is ls, which is for listing the files and folders. So by default, if you issue the command ls, it will list out all the files and folders which are present in the current directory. If you want to list out the files and folders into some other path, maybe /root, which is the root folder of the entire Linux system, it will list out like that. ls command has couple of options which respect to what all the ways it can display stuff. So if I want to list out the detailed list of ls, I have to give the option ls. So the options in Unix are mostly prefixed with the hyphen letter and then followed by some options. So in this case, the options for ls is -l, which is a long listing of the files and folders. So let's try to go at some of the fields which ls-l has to offer as part of listing of the files and folders. So if you look at the first row, this is the file name which I am looking at, and when there is a hyphen in the front, which means it's a file. When there is a D in the front, it means it's a directory, but then this is a file, so it's a hyphen. And then this field is for the permissions. It's a read, write and execute. We will go through in more details in some other video, but for this is the read, write and execute permissions for the user. Then the next three fields are read, the write is blank, which means it doesn't have write permissions, and execute, so it has read and execute permissions for the group. And then this field is for other, so other also has the read and execute permissions, it doesn't have write permissions. So this three field is for user, and the user has read, write, execute permission. This is for user. Group has read and execute permissions, and other also have read and execute permission but no write permission. Then the next thing what we have is a link. Basically this tells me how many files and folders are present inside this. So basically how many links it has, not exactly files, but it has how many links. Since it's a file, it doesn't have any other file containing inside. A file is just a standalone entity, it doesn't have anything inside that. So by default for file, the link would be 1. Then this is the user name who has created this file. This is the group which file belongs to. Then this is the size of the file, and then this is the day, month and time. Sometime this is time, this is the day, and this is the month, and this is the file name. Now let's try to look at this link thing. What is this link? So this link basically tells how many files and folders are there in that particular directory. So let's go to the folder called desktop, or maybe some other folders, and try to look how many files and folders. So if I go here, this has only one directory, and then each folder has two directories by default, which is called as dot and dot dot. So there is a folder called dot, and then there is a folder called dot dot. These two are special files and folders basically, which is present in all the directories. So by default it's hidden. The way to look at it is -a options, -a ls -la. L is long listing, and you can combine the option a, which shows hidden files and folders. It will tell you this. So if I look into this directory, I have four directories. One is this dot, the other is dot dot, and then this is the third one. So this directory contains 3 directories. So that's the reason if I go here and look at my desktop says a link of 3 because it has 3 folders inside it: dot 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 and maybe some other Shahid underscore project. Similar way, if I go into this folder John, it says a link of 4. If I go to the John, it has 2 directories. One is Tom, one is Kelly, but then 2 of them are hidden, which is dot and dot dot. I can see the hidden files and folders with the option A. So this is what it explains, and then this is the size of the files and folders. Now for file, the size is straightforward. It says 785. So this means this size, whatever file I have, that has a size of 788 bytes. So let me go and open that file. This is just some test file I was just looking at. So if you look into this entire file size, this is 785 bytes. But in case of directory which is represented by the letter D, the size is 4096, and you will see that if you create any new directory, the size will come as 4096. So let me make a directory called tutorial, and if I look at the directory ls-l, you see the size is 4096. So by default, what happens whenever a directory is created, there is a space allocation which is in terms of blocks, and that block size is 4096, which means to store the metadata inside that directory. So what is the metadata? The metadata is the directory says how many directories inside it is there and how many link files are there, those kind of things. So by like we have seen that each directory contains a dot and dot dot, so basically those are stored as a metadata. So this is the space allocations. By default it's 4096 chunk. The next thing we will look as is inode, the concept of inode. If you look into the Unix operating system, in Unix or Linux, all the files which are stored in the system, they're stored in some particular physical blocks. Now those blocks might not be ordered in the right way. Some of the blocks might be deleted, and then some other data can come and fill up those blocks. So the way they arrange the file system is they prepare a list of inode, and the inode will look like this. You can see the inode with an options I, so li, and you can combine that. You can say lia, which is list out all the files and folders, which is a, list me the inode, and long listing, and it will show like this. If you want to remove the long listing, it will just say you inode like this. So let's go through the long listing inode. So what this tells me is, so if you have seen that earlier my data was starting from here when I was displaying the files and folders, it was displaying like this, but now there is another field called I. The inode field is displayed first, so which means it says that wherever this data leaves, this data for the file a.out leave, that belongs to block. So in the system, entire hard drive is segregated or made up of many such blocks depending upon the file system hierarchy layout, and this particular file a.out lives in this block. So whenever someone wants to access this file, the operating system knows to go and fetch the data from this particular blocks. Similarly, for this particular XML file, it will go and fetch the data from this particular inode. So inodes are data structures in the kernel, particularly mostly with respect to file system, where it knows which block has the data. So inode entry has all the known values to fetch the block data, and it can go and look for that data. It's basically a linked list. So that's about ls. Now the other useful command which we have is cd. Cd means change directory. If I want to go from one directory to another, it's a cd. So right now if you look, typically I have customized my bash rc script to display me my current working folder, which is my home directory, home/shakil. But we will look into all this kind of customizations later on. So if you look at the typical first time installations of Ubuntu or any, you will not see like this. For me it's like this because I have customized to show my past current working directory, present working directory. So if I want to go to some particular folder, I will say cd. Cd means change directory. So I will go to the /root. Now if I say pwd, it will tell me which is present working directory. It will say /root, and ls-l will say me different things. You remember I am no more having the Dropbox and those kind of folders or a.out, because I am in the root folder of my operating system. This root folder is denoted by /. So mind it, there is /root, which is the home directory for the root user, and then there is a root file system which is denoted like this. So both are different. This is the home directory /root, and the root file system is denoted by /. So this / tells me that okay, I can go to this cd / which is here, and I can stay at any folder and go into any path. So let's suppose I want to go to my home directory. So from my root folder itself, which is the root file system, I can go to my home directory and mind it. In Linux there is a shell command completion. So if you press the tab and if you have the right types of files and folders already present, it will complete your command, so you don't need to type entire thing. If I have just sh and I press the tab and it completes for me, and then inside Shakil, if you want to go into some particular, it will list out all the options. So if I say DE, so it will list out. If I just say D and then tab, it will give me two options because with D there is only two folders which is there, which is desktop and Dropbox, and it doesn't know which one I'm planning to go. So I have to give one more later to make it a right judgment that okay, I wanted to go to the desktop. Now inside the desktop again you will show all the files and folders where it can go or it can read or do something. So this is about cd command. So we have looked at ls, various options with ls. We have looked at the cd command. Okay, now in ls, suppose if I want to list out the files and folders in a long list, which is fine. If I want to reverse that order and maybe I will sort out by time, then I have to give the options LRT, which is a very important command. Many times you will use it in live scenarios wherein you want to list out all the files in some sorted way based on the time and maybe in a reverse order or non-reverse. So if you look here, this is in the reverse order in the sense like ascending order. So this file was created, this directory. So mind it, in Linux directories and files are almost similar. The data structures, they are both same, just that directory can contains further directories. A file cannot have any more files or folders or directories inside it. That is the only difference. But in terms of data structures, representations and everything in Linux and Unix, the file and directory are exactly similar. Exactly similar. The difference is only because files cannot have any more files inside it. It can just have the data in that file. So now here if you see that okay, so John was created on December 18th, then this was mloss underscore expr on December 23rd, and like this was created just now, I have created on December 31st. So this is the way we can say, if we don't give the minus r options, which means that it will be now in the descending order rather than ascending order, so we can use the reverse order. And this T is for time. If I don't give the time, then it will just list out in some ASCII order, in the sense the way it appears. Small a first, then small d, capital D after that, H, something like that. Now there are a lot of options with respect to ls. Like if I have a file which is very huge and I don't want to see in terms of bytes, I don't want to calculate oh how many bytes are there, so there is options called LH. L is again long listing, but you can just use separately also, like this you can use like this. So which means that it will give me in human readable format, and what it means is instead of bytes or kilobytes, it will, like in terms of numbers, it will give me the prefix k or h or m, that okay it's a kilobyte or a megabyte or gigabyte. So here I have a very small file, so it's not giving me that option, but if I wish to, I could create a large file any point of time. Like let me just quickly create one file which is very big in size. There is some junk data, and then I will say hello.txt and done. So I'll have to do, I forgot to give the do, so while true, then say do and say echo some data into some file and hello.txt and whatever, and do done. Now if you see here, it will very quickly just create a file size which is this large, 23486 bytes. Now if I give the options ls minus lh, it will tell me in terms of see hello.txt 230 kb. So this is 230 kb. I can combine the options r and t, which means give me a human readable format with reverse order, which is ascending order, and then based on the time. Now if you see here, I can see out, I can list out the files and folders, and I can see oh this is 230k, instead of like going and calculating okay how much bytes, it's a KB or it's a MB or whatnot, GB. So that's the advantage of H, the options H. Then there are a lot of options in ls command itself, probably 50 or hundreds of options. We will not go through each of them because that doesn't make sense, and most of the people don't use all the options. But as and when needed, you can look in the man page. So what is man page? In Linux and Unix, a man page is a manual for a particular commands or maybe some APIs. So here ls is a command. If you type man ls, it will list out all the different options which you can see with respect to ls. Like we were looking for a, which is minus minus all, which will show all the files and folders. So in Unix, anything which starts with dot as a file name or a directory name, that's a hidden file, which means normally it will not show. But if you give an options minus a, it will try to show those hidden files and folders. So if you see here, there are a lot of options with respect to everything, so you can read through that. And then for the man page itself, you want to find out some details about the man page. Then there is a man for a man, so you can do a manual for the man page itself and navigate and look for the options with respect to different commands. But most of the time, if you know the name of the command, you can go for man ls and look for that. Sometimes you can always get the help with minus h options, but here minus h for ls doesn't apply because minus h is like a human readable format, but for many commands it will help. So let me see if that has. So it doesn't have h, but in many of the commands you will see the minus h option as a help option, so they will have like that. Now if I want to exit this terminal, there is a command called exit. Once you type exit, it will exit the terminal, and you can open another console. So let me open another console and look at my settings. I am using a zoom profile so that it looks better. So like that. The other options you want to exit the terminal is control D. When you say control D, that's the end of the input, and it will also terminate your console. So in this I'm using in Ubuntu, and the console I'm using is called as console. By default it comes with xterm, but I'm using this console. If you look in the normal Ubuntu, there is the xterm, so you can install console with the command apt-get -y install console, and you have to prepend the command with sudo. So once you do that, you will see console, and you can open the console from here. You can type console and it will start. So right now I have already installed, so it's there, but once you installed, and you can also go and find the console. So thank you all for this video, and we'll see you in the next video. Hello friend, what's up? In this lecture we will try to look at some of the Linux commands which is used for creating a file or deleting a file. So the first command which you will try to look is a cat. Cat is again another very versatile command and one of the most useful command after ls. So cat is also used for checking what is there in the file, as well as you can create a file with the cat command. You can create a file with the vi command as well. So let's try to directly look into some of the examples. Let's suppose I want to create a file abc.txt. So the way you can do is you can say cat and greater than sign abc.txt. Don't worry about the redirection now, we will cover this redirection, but what you can think of now is what we can do is whatever we are typing as part of this redirections, it's getting redirected to this file. So whatever we are typing, it's being taken as an input for the cat command, and which gets redirected or appended to the file abc.txt. That's all. So which means we will create a file abc.txt. Now here you can start writing some text. Hi, this is a text file, and you can continue doing typing as long as you wish to, and when you're done you have to press Ctrl D. So Ctrl D is a end of input in Linux. In Windows it's Ctrl Z. Just for the knowledge I'm telling you guys, but Ctrl D is the end of input for Linux. So you can open the file and or maybe you can just do a cat. So when you say cat without any redirection, see, when you say redirection, that means you're creating a file abc.txt. When you don't give this redirection, which means no greater than sign, which means you are listing out the contents of the file. If the file is not present, suppose I will say, it will say no such file or directory, it's an error. But when the file is present, it will tell you whatever is the content of a file. This is the content which we have typed here. Hi, this is a text file and some garbage data. This is what we typed and this is what is there. We can confirm this by opening in one of the editors, which is vi or something. If you have vi, and you can see. So cat command is used for listing the files as well as creating the files. Now let's suppose I have two files. So I have already abc.txt and then I have another file abc1.txt, and this is has some more data, hello world suppose. So if I want to concatenate two files, I could say okay, cat abc.txt and then abc1.txt, and we can create something greater than, or maybe here we can just with one greater than, which is a redirection, which we will look again. We could say new underscore file.txt. So what happens, cat will list out the content of this file and then cat will list out the content of this file, and together both of them will go and sit in this new file called new file.txt. So if I look now, new file.txt, it will have the contents from the file number 1, which was, and this is the content from file 2, and they got concatenated. If the file has a multi-line content, suppose, what I mean to say by that is, if the file is very big file, suppose new file is big, I will add some texture. So maybe some hundreds of lines, a lot of lines. So if I say cat new excuse me, it has a lot of lines, so I can pipe it. So again, pipe and redirections we will cover very soon, but cat command is something which is very basic. Before we go ahead with the pipe, we have to learn cat, so that's why I am displaying. But nevertheless, think pipe as some kind of piping output from one command to the other. And when I say more or less, that means it says display one screenshot at a time. More means keep pressing, and if I say press space bar or enter, it will display me the list of the contents one page at a time. So that's about more command, so we'll go through that, but I was trying to demo the cat command in this. So we have seen how to create a file. Now since this file is created, if I want to delete this file, the command is rm. Rm is remove. So if you say rm abc.txt, and I mind it, I'm giving tab for all the command completion, so I don't need to type that much. So rm will remove the file. If I say ls minus la, again there is no file called abc1.txt. If you look here, there is no file abc1.txt, that has been deleted. So I'm sorry, I removed the file abc.txt, not abc.1. So there is no file abc.txt here, but abc.1 is here. So I have deleted this file. If I want to remove this guy also, I will say abc rm minus fr abc. Maybe I'll just use rm command. Fr I will introduce you very soon. So it has removed this file. Now if I say ls minus l, there is no file called abc1.txt. So rm will remove a file or a folder. So when I say file or a folder, so we have deleted the file. If you mind it, I said that file is denoted by hyphen like this, and folder is by d. D means directory, so this is a directory. Let's suppose we want to try to delete this with rm command, and what it does, it says cannot remove is a directory. So I said you that rm can remove files and folders. So what happens, the condition is when rm command runs and it wants to delete a directory, the directory itself has to be empty. So if I go inside this directory and I see they have no content, so this directory is not there, so rm cannot delete this. So it still thinks that okay, there are some content. So what you have to do is you have to say rm minus fr, which means a recursive. So F is stands for force and R stands for recursive. So you can go ahead and recursively delete this directory, and now it will be done. RMTUT. Now let's suppose if I create a directory again and say RM, and I showed you that RM doesn't work for this because RM is a directory, so I can do a recursive directory, then it can delete. But if I just have a directory and I want to remove, then I can issue the command called rmdir, and rmdir will not complain. Rmdir will delete a directory. Rmdir will not say okay is a directory. So rmdir is for deleting a directory. RM is used for deleting a directory, file, recursively, everything. So RM is more generic in terms of deleting. The only thing is when you want to delete a directory with RM, you have to give the option RF. So the option for deleting is RF. Mind it, whenever you use this command, you know what you are doing. It will delete and the file is deleted permanently. Although you can recover the data, but as a new user you will not be able to recover the data, so you know what you are doing. F means force and R means recursively, and the way recursive works is inside the directory there are some more folders, files. It will delete everything recursively. So that's rmdir and rm-fr. Now let's demonstrate again. So there is this folder called tester. I want to delete it with rmdir. Now let's see what happens. That says it cannot directory is not empty. So rmdir needs the directory to be empty which it is deleting, which doesn't make sense. You are deleting, so why it needs to be empty? But the command is like that. So if I had have used rm-fr tester, it would have worked. It would have just deleted everything. So that's why I said rm is much better than rmdir. Now let's suppose if I want to use rmdir to delete this directory, what I have to do is I have to go inside the tester folder, and then inside the tester folder there is another directory. You delete that, and maybe if there is something else inside that, you have to delete that. So you have to keep deleting everything which is inside this and then come back. So now there is empty. So till this level there is nothing after this level. So I come back and I say rmdir for this, and then I will delete this, and it is done. There is no folder called SIDA, SDS. Now I come back and I see here the tester folder ls-l, and then I say rmdir tester. Now since this directory is empty, this directory doesn't have any child directory inside it, so rmdir will work for me. So that's why you cannot, like, sometimes you just want to just drop a note, delete everything inside a folder, you don't care what is there. So this rmdir is not so useful. So best thing is you always use it rm-rf, and whatever the name of the directory or files or folders you have, mind it, it will forcefully delete everything and it will delete recursively, so you know what you are doing. Okay, so we have seen the command mkdir. Mkdir is for making a directory. So mkdir tester, if I say, so just to recap, mkdir is for creating a directory, cat is for creating a file or reading a file, and mkdir for making a directory. Now all these commands which we are doing, and if we want to reference back, so in Linux there is always this history command. There's a command called history, and it lists out all the histories which you are doing. So sometimes you have to close the terminal to know the history, but you can see what all the commands we are running. And there's a shortcut also. If you want to just refer to the previous command, you can say not h. So not h will also list out the history. This might not be available in all distros, but it is there in Ubuntu. I'm using Ubuntu 16.10 and 16.04 for making this tutorial. So this is a history command. If you want to delete the contents of the history, this history is stored in your home directory. My home directory is home Shakil, and then there is a file called bash_history .bash_history. Mind it, this dot means it's a hidden file, we have seen in the first tutorial. So you have all the contents here. Right now it doesn't show because when the system loads up, it loads from the memory all the history. So if I exit this first, let me show it. If I exit this and try to load this history, I have this profile zoom, and now if I look into the history, bash history, it will show me all the commands which we have run. So it has loaded in the history file because it was keeping it into memory accumulating, and then at the certain intervals or at the end of the session it will load up into bash history. So this is a bash history file. If I want to delete this, I will just delete everything, save it, come back, Control A, and then again open the terminal, and then I will see that okay, there is nothing in my history. If I say history now, only the last few commands which we ran as part of VA is there. All other commands are gone, so history is not there. So history is one quick way of referring what all the commands you have run in the past. Also, history has some limitations in terms of how many commands it saves. It doesn't save all the files or folders infinitely. There is an environment variable for history size, and based on the size it will truncate the file, so it will like remove the previous contents if the file size grows too large. Also, if you want to run in the same session, if you want to run what all the previous command you ran, you can use the up arrow, and then you can see what all the previous commands. Here we have run very few commands, so I'm not able to see now because I have deleted all the history, but I can run couple of the commands and let's see. So tester cat test.cpp file is there, and then ls-l, and then I go to hello, and now if I do up and down arrow, for me I can see all the commands which we have running, which I'm running now. So guys, this is all about mkdir, rmdir, rm, cat, and I will see you in the next video. Thank you very much for watching. Hello friend, in this video we will try to look at some of the Linux commands like cp, move, and clear. So the first command which we will look is cp, which is used for copying a file, and cp can be used for copying a file as well as directory, and it can be used to copy things in a recursive way. So let's try to look at the basic commands first. So here in this folder, in my folder, I have a file called test.cpp. So I would like to take a backup or a copy of this file. So the command is like this: copy, and then the source file followed by the destination file. I would say test_dst.cpp. So test.cpp contents will go and copy into test_destination.cpp. If I look here, ls-l test_destination, it has exactly the same size as whatever test.cpp has, 785 bytes. So it got copied to a destination which is test_destination. Now let's suppose I want to see whether it really got copied or it was just referring to this file. So we can again use the ls-li command. I is for inode, and we can look for the inode. So the inode for test.cpp is this guys, 306030.169, and the inode for test_destination is 603530. So if you see the contents are same, the inode got changed, which means the file gets copied and really written to some other blocks into hard drive, and then that some other block is a different inode, different space in the hard drive. That's the way copy works. It takes something and just duplicates and writes over the contents from one particular block to some other block. So this is for a simple file. Now let's suppose if I have a file and a folder inside that, like a typical way, a folder containing files and folders and subfolders and files. So how do we copy that? So let's try to create something like that. So I will create a directory called mkdir abc. Inside the abc directory, I go inside the abc directory and create one more directory, create hello. Inside the hello, I will create a file touch 123. In the 123 I write something, some data, and then I save it and come back. Now in the abc folder, I will go to the top of abc folder, and I'll go inside the abc folder, create one more directory, mkdir, and then there's a directory called hello1. Now let's suppose if I want to copy entire thing, I say copy ABC to maybe ABC underscore destination. It will not work because it doesn't know that it's a file or it's a directory and how to copy it. So the way you can do a copy of a directory by taking everything like its sub contents, sub directories and everything, you have to do a recursive copy, and the recursive is -r. And also you can say F option. Sometimes the destination folder already exists and you would like to overwrite, then you will say -r F, which is force. And once you do that, now if you go ahead and see, the destination will have the exact same hierarchy as ABC. So if you look at, there's a command called tree and it shows the hierarchy. If you don't have it, you can do sudo apt-get install tree in Ubuntu. So if I run tree command abc, it shows the tree structure. So abc is a directory. Inside that directory there is a directory called hello, which has a file 123, and then abc directory has another file called hello1. And if I run the same command with abc underscore dest, I will see the exact same picture. This and this are the same. And if we want to verify manually, I can go inside the abc underscore dest and I can see exactly same thing. If I go inside hello1, then this hello1 has nothing, and if I go to hello, and it should have a file called 123, and if I look at the contents of 123, it has some data. So this is the way cp command works. So if I want to just copy a file, so the command is copy source and then destination. If I want to copy folders and files and directories to some other folders and files, then I have to say cp space -rf. R is for recursive, F is for forcefully, just for security, that if there is some contents already and we would like to overwrite, you can say -f and then followed by the destination folder, source and destination folder. So cp -rf source directory and destination directory. So source has to exist, destination, if it doesn't exist, it doesn't matter. Now the next command which we will look is move. Move is used for moving a file from one location to another, and it's also used for renaming a file. So let's look for first example. Let's suppose I want to rename this file to maybe some better name like butter.cpp. So I would say move and then whatever the file name I have, and I would say butter.cpp. If I look now, I will see butter.cpp. It has been renamed, and mind it, when we renamed it, the inode remains the same. So let's do it once again. The inode for butter.cpp is 6035382, and if I rename it, which is basically moving butter.cpp to caramel.cpp, and if I say ls -li caramel.cpp, the inode what was there earlier remains the same, which means this data exists in some block in hard drive, and once you rename it, the metadata gets changed. The actual contents doesn't move. It is not like it is taken away and rewritten to some other locations or moved. The data doesn't get physically moved, just the file name gets removed, the old file name got removed and new file name gets written. That's the way move command works. Same thing happens with the directory. Let's suppose if I want to rename this directory abc underscore dst to something abc underscore new underscore dst, it just moves. So it just renames the top level directory with all the links and everything pointing inside it remaining the same. So if I want to look at the ls-li options for this directory for looking at the inode value, so it will remain the same. If you don't know what is an inode, please go through my previous video, and I have explained the concept of inode. And inodes are basically a address or a block of data which is being referenced by some number. So when a data is stored at some particular blocks, that particular block number is referred as inode number, and it has some other details like the metadata and how many links the directory has and what all the files it has. By default, the size allocation for an inode value is 4096. So those kind of things are there, so you can read about the inode. So this is about move command. So we have seen the move. The basic syntax for both the commands are same, and move also has the options -i, which is interactive. Suppose if you already have a files or folders existing at some place and you want to move it some other file. So suppose I have a file this and I want to move this, override this file. So I would say move. I could have done with the copy command, but not copy takes the data and copies it, but move actually moves the data in the sense it changes the name, it renames the block. So now if I say move hello.txt to caramel.cpp, but let me do one more example for you before I do that. Let's look at the inode number for hello.txt and the inode number for caramel.cpp before I do any move operation. So you see these two different data at two different blocks with two different inode. Now let's suppose if I say move, move hello.txt to caramel.cpp. This is done. Now there is no more caramel.cpp file here. If I say ls-li caramel.cpp, I'm sorry, there's no more hello.txt because hello.txt has been moved to caramel.cpp. So caramel.cpp is there, but hello.txt is no more there. So there's no more hello.txt. Now if I look for ls-li for hello.txt, there is nothing. And then if I look for caramel.cpp, I have this. So now what you can see this, the inode for caramel.cpp is 291, ending in 291, and previously the inode for hello.txt was 291. So which means that the file hello.txt has been simply renamed to caramel.cpp, and whatever was there in the caramel.cpp, this block is still lying there somewhere, but it has been dereferenced. So that means you cannot recover the data through a normal means for caramel.cpp. It has been removed. So this move and cp commands mostly work with the inode perspective. Inode is the one through which we can manipulate. So cp command is the one in which you actually copy the data, and in move you just move the inode number. You change the inode number with the right name, and that's the way it works. Now after doing all these operations, you want to clear your screen. There's a command called clear, and it will just make your screen looks good again, and all the commands will be clear. In terminal you can always scroll up and to see what is there. You can take a history, you can look inside the history. We have already shown you how to run the history command, so you can look like this and check for all the previous commands which we have done. So move and cp is a very important command. Now please try to learn and understand more about it. There are different options with respect to that, so you can run man pages for rm, move, those kind of things. So try to look into the options, particularly options like -i. So if there is already a file or folder lying, so it will ask for interactive mode. If the interactive mode is turned on, it will prompt you to say whether you want to override the file which is already existing, because you want to override some other file with some name which is already existing in the system. So that's about move. Similarly, you can go through some of the options with respect to cp. So man page should be your friend. There are a lot of things in the man, so try to go through the man page as much as possible. In case if there is no man page installed, then you can search in for Ubuntu how to install man page. There are a lot of links to install man pages. Thank you very much and have a nice day. Hello friends, in this tutorial we will try to look at some of the Unix command like who am I, which, locate and pwd. So the first command which we will look is who. So who is used for finding out which all users are logged in the system currently. So I have the terminal open and I have logged in with my user ID Shakil, and if I issue the command who, it will tell me okay, there is a user called Shakil logged in into the system. So this command was useful when university student used to log into through different kinds of terminals to some systems, and the teacher or professor wanted to know how many users has logged in into the system. It is still useful not that useful from the shell script perspective, but it is good to know about the system, that who all the system users are logged in the system. The other command which we have is a variant of who, which is known as who am I. It basically tells you what user I am. So it will tell me that I am the user Shakil. Now let's suppose there is another user called John in this system, and if I don't log in with the John, but I just change my user, there is a command called su. Su is a change user, which is basically super user, but with super user I will give the name of the user. So now I will become John. So even though I started login as user Shakil, I change myself as John. Now all my credentials and everything is with respect to user John. I am John now. Now let's suppose if I say who, you see that it doesn't says John, it still says Shakil, because John has not logged into the system through some terminal or SSH. But if I say who am I, it will tell me John because I am user John. But it doesn't says that in terms of logged in users, who John, because John has not logged in. Now let me open one more terminal and increase the font here, and let me check the IP address. There is a command called ifconfig. With ifconfig you can look the IP address of the system. So this is my system IP address, and I will log in as a user John. So it's a local login, even though I'm not logging remotely. I could have done from my Mac, but let me try to log into this system again as a local user John through SSH, and see what happens. Now if you see here, if I go back, maybe even I can do it here. If I say who, it will tell a John user. So John user is logged in through a terminal PTS7. So whenever a user logs in with anything, the terminal window whichever it opens, it is called as TTY. So if you type the command TTY, it will tell you which terminal you are in. So John is logged in with terminal PTS TTY. It tells you the time and from which IP address he has logged in. So this is the way. Now this is through SSH, so that's why you see the IP address from where it has logged in. But if it is non-SSH, it will be just directly log into the system. You will not see from which IP address it has logged in. If I log in from my Mac, let me quickly do it through my Mac, and I will show you. This is my Mac, John at the rate of 172.16.237.160, and I give the password. Now this is my Mac, even though I'm logged into Unix or Linux. You see, it tells me that John is logged in, one terminal is logged in through .1 and the other is through .160. So this 160 was through SSH on the terminal, this terminal itself, and then when I issued the SSH command through Mac, this is the one which login. This is PTS18, which is my TTY. So this is the way you can check which user has logged in and who is my current user. Now if I say who am I here, it will tell me John, no more Shakil. If I say who am I here again, it will say me John because I'm still logged in as a John even though I change SU. If I come out by saying Control D, which means exit out of that, so I fall back to my user Shakil, and if I say who am I again, it will tell me Shakil. And if I look who, then this two John logged in. One is from this terminal, which is a tab in my console window, and then one is from my MacBook. So this is the who command. So we have looked at who commands and we have looked at TTY tells me the basically terminal type. So what is this terminal type and what is the name? So this is TTY PTS10 is one of the terminal, PTS15, PTS17, whatever it is. And if you logged in through some remote SSH, then also you will get a terminal type. Now let's suppose if I have wanted to see where is this command is lying, where is this who command or TTY command. So this is another command called which, and it tells you the path of the command. So if I say which TTY, which means it tells that TTY is coming in the system from the user bin TTY. So in the path user bin, there is a file called TTY executable file, which is in the path, and when we execute tty it gets executed. So this is the file which gets executed. So the equivalent is, if I, instead of tty, if I could just say like this, it will give me the same thing, but we don't want to type so long, so we'll just say tty because it's in the path. So that's the command. Which, there is another non-standard command nowadays which is called as locate, which maintains the list of database. So it's similar to Mac and Windows database creation. It's not part of POSIX or original Linux or Unix, but nowadays it's there. So now let's suppose if I say which, it will list out all the files and folders which has which. So if you say here, it has the keyword which, it has the keyword which. This might not be very useful when you have a lot of stuffs like that, but let's suppose if I locate files and folders with the name John. Now you see it tells me rightly, because there are very limited things in my system with the name John, and it tells me the right thing. But if you have a lot of contents which has something like which, and you are trying to look for that, it might be overwhelming and you might not get the right result. You might not be able to see the data which you are trying to look in so much output. So you might have to write some more customized script to look for that, but nevertheless it is also one of the command. So let's try to look at which command more. If I say cd, which is a change directory cd, now you see here for cd which didn't return anything. So all the commands which is there in shell belongs to two categories. One is internal, one is external. External are those for which there is a external binary which is put in place, as in the case of which and which, or ls, which means this, there is an external binary which I am using to get the command which. But cd, there is no such command. Cd is a shell inbuilt. So whenever you get a bash shell, it has some inbuilt command, and cd is one of them. Now the other thing which you can look is which echo. So echo is part of bin echo. Then you can say which ls. Ls is part of user bin ls. Ls is found at this location. Now let's see which mkdir. It's a bin mkdir. Which move, it's a bin move. So all the internal commands, whichever you are there, which you are not able to find out with which command, you can say for sure that it's a shell inbuilt internal commands rather than some external binary. The other command which I would like to you guys to know is pwd, which is a present working directory. So there are so many files and folders, and you can navigate to any place in the system, and you wanted to know where exactly you are. So for me, I have put an alias for my pwd in my bash rc script, which I will cover in some later video. So but you can use the command pwd to know where exactly you are right now. So right now I'm in my home directory. If I move to the root folder, which is like coming out of Shakil, so if I say Shakil, let's go to my home directory again. So this is my home directory with the pwd command. If I say cd dot dot, I come out one directory which is in home now. So if I say pwd, I am in /home. Now if I do again cd dot dot, and then if I say pwd, I am in root folder. And if I say cd enter, so whenever you type the command cd and enter without giving any directory name, it always take you back to the home directory. So if you are at any place and if you want to go at anywhere, you can just give the path where exactly you want to go. So if I want to go to /, I can use the command cd and I will say pwd, and it will tell me where exactly. Now if I want to go to user and bin, I can say pwd, I can list out all the contents here, whatever we have, and pwd will tell me where exactly I am right now. So that's all for this video, and I'll see you in next video. Thank you very much for watching this tutorial. We will try to look at some of the command with respect to calendar and date. So in Linux there is a command called cal, which displays the calendar. So mind it, the command is not calendar but cal, because in Unix or Linux, most of the time whenever we use a command, we use a shorthand notation for being typing fast. So we use the word cal for calendar, not the entire word calendar. So by default, when you issue the command calendar, it will show you the present month of the year. Now if you say cal 2017, it will show you the calendar of all the months when you give a year. So cal 2017 will give you all the months. If you want to have any particular month, not the current month, then you can say suppose cal 03 1978, and if someone wants to know which day you were born, you can find out, okay, I was born in this day and it was Monday, something like that. So cal 03 means March of 1978. Pretty simple. It doesn't have much use, but it is just for the fun. The other command which we will look now is date. Date is again one of the very important command wherein it will be used in your shell script to determine whether particular file has been modified, and when it was modified with respect to date, what is the current date, and things like that. And the other problem with date is there are lot of options with date, and it is really confusing which date command you should use because of so many options. And one more point of confusion with respect to date command is date is a command which is used to set the system date, as well as it is used to set the system time, as well as it is used to show the system date. So it will be used for setting the system date as well as showing the system date. So let's quickly jump into some of the date command. So by default the command is date, which is pretty simple. If you type the date, it will tell you the current date. Don't look at this date because it says August 2nd and I'm making this video in January 2017 because I just played with my date, so I forwarded my date. So this is the current date. Now if I want to see, so this date is in PDT time zone. If I want to see the date in universal time formatted, which is a time somewhere in London, so the current time in London with respect to whatever date I have would be August 2nd 22:54:11 UTC. So universal coordinated time is a Greenwich Mean Time, which is approximately equals to the time in London. So date minus u will give you the date in UTC format. Now if you see here, date command gives you both the month, day, year, everything, and the current time also. So date command gives you the time and date both. There is no time command for setting or getting a time. There is a time command, but that is meant for a different purpose, for getting the runtime of a user system, those kind of things from the time. But date is the command which is used for setting the date and time both. Now it has some options. We'll quickly go through some of the options. One option is %t. If you want to see only the time, not the date, you can say %t. Again, this can be used in your shell script if you want to gauge sometime what is the current time and you don't bother about date or something, you can use like this. Then the other not so important option is %b. It displays the full month like August. It might be needed, I'm not sure, but it's there, so I just wanted to show you. Then if you say %d, it will display the day of the month like 02, which is the second day. So if you see here day August 2nd, so this is 02, so day of the month. And B is in a full format display the month, entire name. It will not say AUG like here, it will tell you the entire name August. Now if you say date plus %d, so it will, this is probably an important command, you can make a note of this to display in the right format. Usually this is the format in which we display the date, so which is a month and day and a year, 2 digit for the year, and this %d doesn't shows you the time, so you have to remember that. Then the next command is %f, and which displays in the year, month and day format separated by hyphen. So again, this also you can use it. Probably this command %f is better than %d because it has 4 letters for the year, which is good. So these are some of the options. Now it is really confusing that which one we should use. So for that I have made a small PPT to show you guys which command we should really use. You can use any of these, or you can go through the man of the date page and look for all the options. You see all these options are there: percentage a, percentage b, which we were seeing as the full month name, and things like that. So it has lot and options. Probably it's a very confusing command, but as and when needed you can refer the man page or maybe Google and try to fit in according to your need. I have prepared one slide and which I try to make it as generic as possible for some of this. So let's go through this. So now if you want to show the date in this format, like date in the month, day and year format, so capital Y is 4-digit year format. So this is a 2-digit for month, 2-digit for the day, and 4-digit for the year. If I run this command, my date will display like this, so which is good. So that is one command to remember. The other command is time, which we have already seen. This displays only the time. Then this command is probably very important, and why it is important I will go later on, but first what it will display. So if you give in this format, it will be M is for 2-digit month, day is for 2-digit day, and H is for 2-digit hour, M is for 2-digit minute. So this is a capital M for minute, a small m for month, and Y is 4-digit for year, and there is a dot here followed by percentage S, which is a two digit second. Now if I run this command, the output would be like this, which is 05, which is 2-digit for month, and then 2-digit for hour, sorry, day, and then 2-digit for hour, 2-digit for minute, and then 4-digit for year followed by second. So let's quickly run this command, and why I want to run this command I will get back to you very soon. So first my date is like this, and then I will run this particular command, percentage m, percentage d, percentage capital H, percentage capital M, percentage capital Y, dot percentage S. Now see, so this is exactly the same as this. Of course the time will run like some second has been moved, so ignore about that part, because here it was 25 seconds, here it is 45 seconds. Okay, now so this is August 2nd, which is here, if you see here, August 2nd, and then we have the time is 15:59, which is in the afternoon, 3:59, and then the year 2017, and the number of seconds. So this 25 is 45, because by the time I have typed, 20 seconds already elapsed. Now this particular command can be used to set the date also. How? If you take this and just copy this, now instead of August, which is 08, I can say September. Now it has set. Why it is not? Because you have to run through sudo, of course, because you need a special privilege, because you're setting the time of the system. So I ran it and I will give my password. Done. Now if I run the command date, you see it has changed to September 2nd. It is no more August like this. So this command is very useful. So that's why I was saying that when the date is in this format, you can display the date as like this, and if you want to change some date, you can change in this numeric value and just run the date command as in the next slide like this. So if you want to run with some date, so you say the date, this is small d, mind it, and then 08, which is August, 02, which is day, second day, then this is time 15:36 2017, and then this is second. So this will set the date as August 2nd 15:36:37, and whatever the default time zone is there, it will take the default time zone. There is a way to set the time zone also with percentage G options. You can refer the man page. So this is about date. Now date and time we have seen. Now there is a command called time, but it is not in the usual sense we use this. This time command is for altogether different purpose. and that different purpose I can show you. So let's suppose I have a shell script which I will create now. I will go through all these concepts later on once all the commands complete, but just now I wanted to display something, so I will show it to you. So I have a script bin bash, and inside that I will say echo hello, and then I will sleep for maybe 2 seconds, and that's all. Now I say chmod 777, that is it. Now if I run this command with time this, so any command you can run, or any script or any binary you can run and prefix the time command. So what this will do is it will run for 2 seconds, which we have seen because we have a sleep for 2 seconds. So now if you see here, this in script execution took me 2 seconds, so 2.08, so 8 milliseconds. So 2 seconds and 8 milliseconds. Now there's two more field, one is a user and one is a system. What is user and what the system means? User means the time it has taken for the user base applications to execute. So here it is very short script, it didn't took anything because it's not so precise. There are other ways to get more precise time from hardware clock, which is beyond the scope of this tutorial, and you can also get it from the GIFs in the kernel. If you want, you can look in my YouTube video for GIFs, so we can get more precise time for this kind of small script. But for big script which runs for considerable amount of time, you will see some time here, at least some millisecond. So there is 0 seconds spent for user space applications, and system, which mostly means in terms of kernel and low level things, that also spends 0 seconds for this. If this is a very CPU intensive task, probably these two might have different, but this real time is always you look for how much time this script takes. This real time is a sum of user space plus application space plus everything, so it's a summation of all the time which this script has taken to execute. So this is altogether a different concept, even though it sounds like time, but it's not exactly system time or something like that. It's the time for running, how much time a script or a binary took to execute. Now when we were going for date and time, which we were setting up locally, mind it, you will be able to set up only when in Ubuntu at least, and in other things if you have these settings turned to manually. If you try to say automatically whatever time and date you set, it will get revert back almost immediately or maybe after some time. So only when you set it to manually, it will set the time whatever commands we were running with respect to date. Otherwise it will just revert and you will be confused, oh I am setting, why it's not allowing me. So now I will automatically revert back to internet, and now if I run my date command, so it's today January 2nd. So you see I set my date earlier to September something, September 2nd 1559. Now it's January 2nd 5 in the morning, and my time zone is PST 2017. This is the time when I'm recording this video, and time command is for a different purpose. So thank you all for watching this video, and I'll see you in the next video. Hello and welcome friend. In this tutorial we will try to look at some of the options with respect to VI editor. So the first thing I would suggest is go ahead and install VI in your system if it's not already been installed. The command to get it installed is, you could say sudo apt-get -y installed vim as shown on the screen. This command is only for Ubuntu. If you are working on some other distributions like Fedora or Red Hat, you will have to use yum or rpm if you have already downloaded. With yum you could say something like yum space what provides vim, and it will give you a list of options and which package has a vim, and you can go ahead and install those package. Now once you're done, since I have already done so, there's no point in doing it again, and it says it's already done. So we will directly open the VI editor and do some text manipulation. So we can take this text itself and do some manipulation. This I will treat it as a text and do some manipulation. Now what is vim, and when we were saying VI, then what is vim?
VI is the basic which editor which used to come since 1976 or something when it was first written, probably older than that. And Vim is an enhancement, and then there is a GVim which is a GUI Vim, but the underlying commands and everything works on VI, but there are some enhancements in Vim. Now there are two competing editors in the Linux field. One is Emac and the Vim. I personally like Vim because VI is very small. It is found even in the embedded system, very small system. Emacs are little heavy. Emacs probably has more customization feature compared to VI, but it is not found at all the places. So if you know VI, then you are sure that whichever server you logged in or whichever machine you logged in, if there is at least one editor in that system, that has to be VI. So that's the reason I prefer VI over Emac, but it's up to your personal choice. Now, the way you create a file in VI is you say the command VI, and even though you installed Vim, there is an alias created for VI, so you use VI. You might use Vim also. So you say VI and maybe my file.txt. So what it will do is it will create this file. This is an empty file now, and you can go ahead and write. There are two modes, basic modes in VI. One is a insert mode and the other is a command mode. There is a third mode people say, but it's actually the command mode itself. It's an extension of the command mode. So what does insert mode means? That when you start typing something, you have to be in insert mode. The other is command. So commands controls like deletion of a line and those kind of things. So we will go through it shortly, but first I will paste whatever I have so that I can show it to you. Now let's see, I want to delete this line. So the command to delete a line in VI is dd. Now if I say dd, what it will do is it will delete. So far so good. Now let's suppose I am in insert mode. That means I am typing something. I will tell you how you go to the insert mode. So I am typing something. If I want to delete this line, so I said you just now to delete you say dd. But what happens when you type dd, it's actually writing onto a line, it's not deleting. So how does VI knows whether dd is meant to write the word or letter dd into a line, or dd means you want to delete a line? How does VI know? That's the reason we distinguish between different modes. So when in the insert mode, that means in a writing mode, insert mode is equivalent to writing or editing mode. So when you're writing something and if you press dd, that means you are writing dd, the word dd, the letter dd. But if you want to go into a different mode, you have to press escape. Escape is not visible, so I pressed already. Now I already pressed escape, so I am in a command mode. When I am in command mode and if I press dd now, this line is gone, so the line is deleted. So insert mode, you can go to the insert mode by pressing I, the letter I. If you press I, this is the insert mode. So if you are already in insert mode and if you press I, it will just keep on writing I like this. But if you press escape, then that means you are in command mode. Now if you press I, the I is not there. So see, it has toggled to the insert mode. It will tell me that I have gone to the insert mode. Now if I press I, it will write I. So there is a small indicator here which will tell you in which mode you are. Remember, this insert mode indicator might not happen in older VI also. So their VI also has gone through many different revisions, and not all VI has the similar kind of options. Although they all follow the same options, in the sense the same basic options, but some enhanced features or look and feel or maybe things like that displaying insert mode or displaying might not be available in all type of VI editors. So good. So we have seen two things. One is insert mode. So if you are saying insert, so you have to press I, then you go to the insert mode like this, it will display you insert, and then you can say I will write insert. You have to achieve by pressing I. And the other mode, command mode, you have to go by pressing
escape. So I will say escape. So as soon as I press escape, I got. Okay. So that is about those two different modes. Now, suppose I am in this line and I want to open a line after this. So, of course, the command is O, escape O. Because if I just press O, that will write for me here because I'm already there in the escape mode. So if suppose if I am in the insert mode already, means writing mode, and I press O, it will write O for me. How does it knows? It opens a line below this. So no. So what you have to do is you have to go to escape mode because you are issuing a command and then press O. It will open a line below this line. Now, if you want to delete this word, like the package word, so you have to go to the escape mode. So you press escape and probably go to the cursor where you want to delete and say DW. It will delete one word. Let's suppose we are in this line, suppose line which says 9, and I want to delete 3 words. So already the new test. So I would say escape 3 DW. So whatever I have done is like this, escape 3 DW. So first you press escape keyword and then 3W. So it will delete that. Let's suppose I want to delete one character at a time. So you go to the escape mode again and press X, the letter X from your keyboard, X like an X-ray, and it will keep on deleting one letter at a time. Now let's suppose I want to copy this line, building dependency tree. So the copy command is called as yank and the short form is YY. So it's called as yank YY. So what you have to do is escape YY. So that means you already copied. Now wherever you want to paste, you come here and say escape P. So you paste it. So you see line number 7 and line number 14 are identical because I copied and pasted. Now let's suppose I want to delete everything after line 9. So maybe or I want to delete 5 lines. So I would say escape then 5 DD. 5 lines would be deleted. I want to revert whatever I deleted just now. I would say escape U. It's in revert mode. I want to type something. I want to write program. Then I will say escape and then I went to the insert mode. Now I keep on writing. So as long as I'm insert mode, I can continue to write. Only from insert mode, when you press the escape keyword, it goes back to the command mode. So now I am in insert mode. So I would say hash include stdio.h blah 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 int main, and I could say something like hello world. I can write my programs like this. Continue, no problem, as long as you wish to. The moment I press escape, now I already press escape. Now if I press enter or something, it comes down. I cannot write the command because it will treat it as insert mode. I already press I, so that's why it went back to the insert mode. So that's the way it works. See about this. Now the other thing which I wanted to show you is like line number. If you want to display the line number like this, you have to say escape. So since it's already being displayed, I want to undo that. So I would go to the escape mode, and after escape I have to press colon. So when after pressing escape and you type this special keyword colon, it will show at the bottom of this screen, but actually it's not part of editor. So it's just in a command mode, but it's in a special command mode. That's why some people call it as a third mode, but it's a command mode only, a special case. So escape colon, and I would write set no. So no means not number, so don't display the number. So once you say set no, so see this set no has not been written anywhere inside the editor. It's just a way to say the command to the editor. It's in the same screen. You can do different kind of things based on the different mode you go. Now if you press here, so see there is set menu. There is nothing called as set no anywhere. Now if I want to display the line numbers again, I would say escape colon set nu. This will display the line number. Let's suppose I want to search certain keyword. So I would say escape then / and the name of the keyword. I would search for packages. Now I'm searching for the keyword packages. Now you see here it is matching here because I already have a setting in my VI which does the case insensitive. If I turn off the case insensitive like case set no IC and see package is not found, so I would say escape where WERE. If I try to search this, it says where not found, but where is there. But if I search for WERE, it will say okay, where is found, and if I press N, it will take me to the next search. So how do I make case insensitive search? So I would say escape colon set IC. IC means case insensitive. Now if I search for escape /WERE, so it will give me where. It will take me to the character of the matching word, first character of the matching word. Okay, now let's suppose I am at this point and I want to join this line, the line re1 with this brace, closing brace. So how do I join this? I would say escape and then press shift J. Each time, so I will write here, each time I press shift J, it moves one line from the bottom to up like this. So this is the way I can do that. Now there is a line called reading and I want to replace certain characters. So maybe D I want to replace with capital D. So I would say escape, then I would say shift R, which is in a replacing mode, and I would say then D. So it will replace the letter D there. Now if I want to go to the end of this line, I would say escape shift A, the letter A for apple. So it goes to the end of a line. I would go to the starting of so I would like to go to the beginning of line, escape shift pipeline. Pipeline is the letter pipeline like this, escape shift pipeline. So this one, of course you have to, like when you are in this mode, like how escape shift A, which means that you have to press escape. If you just say shift A, how does it knows that it has to write the capital letter A or it has to go to the end of a line? So you, whenever you do some kind of operations with respect to command, like going to the end of a line, displaying a new line, showing a number, you have to be in escape mode. Only while writing you should be in insert mode. When you are insert mode, what it means is whatever you are typing, that is just going literally typing on the screen. That's not a command. That is the main important thing which you have to remember. Now we have seen DD, DW, replace, escape, search, shift J. So the thing is, in VI you really have to do a lot of practice, and the more you practice the better you will be at it. And after a few minutes or maybe after a few hours of practice, I'm pretty sure you will be very comfortable and you will like it. It will be a most powerful editor. Now let's suppose I would show you something like how powerful it is. So this is line number 10, and line number 10 escape YY, I copied it, and escape 100p. Now if you see here, see I have copied it 100 times in one single shot. Even if you use Notepad++ or any good editor, Sublime, without proper macro or something, I think it would be very hard to do this kind of operations so quickly. Now let's suppose I want to go to line number 55. I would say escape colon 55. The moment I say, it takes me to the line number 55. Now if I want to go to the bottom of this file, escape shift G. Shift G will take me to the end of a file. That will be the last line. If I want to go to the starting of file, escape colon 1, because you remember colon and 10 will take me to the line number 10. So if I go and say escape colon 1, of course it will take me to the beginning of the file. Line 1 is the beginning of a file. So you can do like that. And let's suppose if I want to delete arbitrarily from 4 till the end of a file, and I don't care it's 100 line, 1000 line, I would just escape 1000 DD or one. I have not pressed, I think, the entire number correctly. So I say escape 1000 DD. Done. Everything is cleared. The entire file is blank except for 2. If I would have done it here, it would have been blank for everything. So I would say escape 1000 dd, the file is blank. So I don't think you can achieve this much speed in any other editor, and except for Emacs. Emacs is equally good, but it is heavy and not found at all the places. So I hope you enjoy this video. Try to practice as much as possible, and only with the help of practice probably you would love VI. Otherwise you would be struggling with cheap editors like Pico, ED, those kind of editors, which really a good shell scripting guy or a good programming guy in Unix will not like it. A good person only likes either VI or Emacs. Those are the only two good editors for programming. And if you're using anything else, I'm pretty sure you will never be counted as a geek or as a Linux guy. So it's your choice. Thank you all for watching this video, and you have a nice day. Bye bye. Hello and welcome, friend. In this tutorial we will try to look at some more commands from the VI perspective. So in the last command we have seen how to open a file and do some manipulations inside the file, like yanking or copying a line and pasting it, going to certain line numbers. Now after doing all those operations, how do we save the file? So that's the thing. So either you open a blank file or create a new file. So let's suppose I have this file text1.txt. So I will open this file. So this file is already has some contents. It's been saved in the past. Now let's suppose I add some contents here and I say, hi, this is Shakil. Now if I change my mind and I don't want to save this and I want to quit without saving this line, the last line which I have added. So the command for that is, you say escape, which you will be in command mode, I mean to say, escape :q, and then not. This not means you forcefully exit even though I have the changes. So if you don't press not and if you have the changes, it will say no, you have a changes, you cannot quit. When I say not, it means yes, I have a changes here and I want to discard that. So you just exit, it will exit. Now if I open it again, my change is gone because it has quit without savings. Now let's suppose if I want to write and save, so I write something, hi, this is new line, and I want to save it. So for saving you have to say escape :wq, and not is again forcefully that you save it. If you don't give not, then also it is fine, but I generally practice like this, escape :wq not, and then this will force. If I open it again, you see this is still maintained, this line has been saved. So far so good. Now this is file 1. Now how about doing multiple file operations within the same VI editor, the way you open multiple tabs? You can do very much similar in Notepad with tabs, so you can do it in VI also. So right now the file, if you see here, is file text1. If you see the file name, you want to see the file name, you say escape :e, it will display you the file name, or you can say escape :f, it will show you the file name. Now I want to open another file. So what you do is escape :e, and then you say another file. I have another file here, test1. So here, see, this is file 1. It says when I open another file, this is called as, this is file 2. So I have another file. Now if I want to go back, so I will do some manipulation here. I have changes in file 2 and I can save it. So if you just want to save without quitting the VI editor, you can say W, but if you want to save and quit, you have to say WQ. So that's the only difference. Only save is like W and save and quit is WQ. So that's the way you do it. Now this is file 2. I saved this contents in the file 2, but I don't want to quit. Now I want to go back to my other file, which was file 1. So going back to the file 1, there is a command called escape :bn. So n means next file. So you keep on pressing next file. So now this is file 1. So we were in file 2. When we press B1, we came to file 1. Again you press and then it will go to file 2 again. Again escape :bn. So bn means next file. If you have n number of files, you keep on iterating and it will overlap and then come back to the first file again. There are individual commands like bf, escape :bf, go to the first file, bl, go to the last file, but you don't need to remember everything, because most of the time we do iterations over 5-6 files, and it's very easy to do bn, and anyway it will wrap over, and when it reaches the end of the file, the last file, and if you press bn, it will go and pick the first file again. So you don't need to remember everything, just the bn. So escape colon bn is the next file. Now sometimes you might need to split your terminal into two halves and see, compare some files. So for splitting, there's a command called escape sp. Sorry, I was not in escape mode. So escape colon VSP. So there is a SP and VSP. I would go for VSP because VSP is vertical split and SP is horizontal split. So I don't like horizontal split, but you can try. So V is VSP and SP split. So if you see here now, when you split, they will have the same content, right? Because it's the same file you see. So if you want to open another file in another window, you can just go. So first you have to cycle between this window and this window. So to cycle between those windows, okay, now if you want to move back and forth between those two uh, tabs, you say control W, so it will move to this tab. Then again you say control W, it will come back to this tab, control W. Okay, so that way you can do a changes. Now in this, like right now both the tab is having the same file, test2. In this tab, suppose you want to open a file test1, so escape colon E, and then you say test1.txt. so this is test1, then this is control W. You can go here, and this is test2, and you can do some sort of modifications or whatever changes. Also note that in some of the older VI, the left and right arrow for going in a file like this or up and down will not work. So there is this keyword J and K. So if you want to go move down, you have to press J from the keyboard, and of course you have to be in escape mode, and K is up. So I'm pressing J and K now. J means down, K means up. K is up. And H and L. H is move left and L is right. So you just remember H and L, they are in positions left and right, and J and K is down and up. So this is J down, K is up. So this is the way you can manipulate files, and there are a lot of commands with respect to VI, so you will really have to practice. Now one more thing, if I want to undo certain changes, like this change was done, so I would say escape U, it will do undo, and I will press as long as I wish to before saving, because I have already saved it, so it will not undo that. But if I write something like, let's suppose I write this, and I want to undo, escape U, I will press, it will undo that. So that's the way you can do. And then there is the redo command and control R, you can do those kind of things. So in fact there are lot of options, but you don't need everything, you just need some limited set. But the main thing is you have to practice. So thank you all for watching this video, and I hope to see you in the next video. Thank you. Hello and welcome, friend. In this lecture we will try to look at some of the Linux and Unix file system permissions. So there are two basic commands for changing the ownership and permissions, and we will try to look one of them, which is chmod, change mode. So change mode basically alters the permissions of a file. There is a change owner, which we will cover in subsequent videos. Change mode, as we know, is for changing the file permissions. Typically when you create any file, and if you look the file permissions with the help of command like ls-la or ls-l, which is a long listing in ls, and you will see the permissions like this. What this means is that this bit is read, this bit is write, and this bit is execute. So that's what I have mentioned here. R is for read, W is for write, which is a modification permission is granted, a user or a group or other, if they have the W permissions, which means that they have the permissions to modify the contents of a file, or they can delete the file. X means execute permissions, which means that they can run that binary or a program or a script file, so they have sufficient privilege to run. Now, if we look more closely here, I have separated by a space. Typically, this is not separated by space, but I just separated by space for clarification. So if you look here, first three bits, so this is first bit, second bit, third bit. So this first three bits are for permissions for user, and mind it, this permissions denotes it's a file. If there is a D here, which means it's a directory. So we will not cover this just signifies whether this is a file or a directory. So when we say first bit, we really means from here, not from here. So first third three bits are for users, then the subsequent three bits are for the group. So this three bit, if you see here, group has only read access, they don't have write or execute access. And the last one is for others. Other means anyone apart from user and group. So there is a concept called user and group. User is a user, as we all know, a user present in the system, and there are set of groups. A group means a set of people with some responsibility, like administrator can be one group, printer pool or a printer admin can be another group, things like that. So typically whenever we create a user, we create a corresponding group also. So if I create a user John, I will create a group called John. So anyone who belongs to group John, so there might be a user called Mike, he might also belongs to the group John, and John is also a user, John is a group, and Mike is a different user but he belongs to the user group. So whatever permission is there in group John, Mike will also have those permissions as part of the group. So if you belong to a group, whatever permissions belong to that group, you will by default get that permissions. So that's what group means. And other means this field last three bit is for other, which means that you don't belong to the user, you don't belong to the group, so you are none of them. So that permission denotes whatever permissions you have. Now if we look here more closely, it is like this. So first three bits are for user, and within that first bit is read, then the next subsequent bit is write, and then third bit is execute. Then here fourth bit is again write for the group, fifth bit is read for the group, fourth bit is read for the group, fifth bit is write for the group, and sixth is again execute for the group, and then seventh is for read for the others, eight is for write for the others, and ninth is the execute bit for the others. If we look at the numerical value, the value of r here, whatever the r we have seen here, the numerical value of r is 4. So let me go back, and the numerical value of w is 2, and the numerical value of execute bit is 1. So if you sum up 4 plus 2 plus 1 is equals to 7. So any user or group or others, they can have a max permission of 7. That's the numerical donations. Now if you look here, we have full permission in this particular case. I am just giving you an hypothetical case. So it's read, write, execute, and so this is 4 plus 2 6 plus 1 7. So this is 7, and again this read, write, execute. So this is 4 plus 2 plus 1, which is 7. 4 plus 2 plus 1 7 7 7 7. Here I am demonstrating the same thing again, just a little bit more clarity. So in this particular file, it has only write permissions. I am sorry, it has only read permissions. So R is for read, and then two blanks means no permission, so the equivalent is 0. So read, as we know, has a value of 4. If we can look in our previous slide, read has a value of 4. So this is 400 400 400. So which means the effective permissions, if we want to modify by a numerical system, it would be 444. Now if I give read but no write permissions and execute, so which is 4, and there is no write, so it is 0, and then execute bit is 1. Again execute bit is value is 1. Then again this is only read 400. If we look the permissions here, so this has on one bit as 4 and the last bit as 1 for user, so this becomes 5. So you can add this 5, and then 400 is 4 and 40, so the effective permissions would be 544. Here it is 4 plus 2 plus 1, which is 7, and then no permissions for users or group others, sorry, no permissions for group and others. This is 00. So let's try to look at some of the examples with respect to the users and permissions. So we will create a file, default file, and we will try to run through some of our examples. So let me touch a file. Touch is one command which you can create a empty file, a blank file. So I will say file1.txt, or I could have given any name. Now if I look with ls-l, this file, the default permissions is rw. So rw is r is 4, write is 2, and execute bit is not set for user. So this is user. Then for group, only read permissions is there, so which is 400, and then again for others it's 400. So if we sum up, the effective permissions would be this 4 plus 2 is 6, and then this is 6, and this is 4, this is 4, so 644 would be the effective permissions. So if I want to change the permissions by numerical systems, I could say 644, which is ineffective. I am doing the same thing, same permissions, no change, but just I want to demonstrate. Now let's suppose if I change the permissions to something else like 777, I give all the permissions to all the users, group and others. And now if I look with ls-l, you see rwx, everything is populated, which means it has got all the permissions. Now if I want to go back to the previous permissions, so we know previously the permissions were 644. So if I just say 644, it will take me back to the previous permissions. So I can now again see 644 is this. So 777 means all permissions to users, group and others. Now 777 looks good many times, that if you want in a hurry and you want to give some execute permissions, you don't want to calculate, you just end up giving 777. But that might be a security hole, that might be causing security problems. So make sure you know when you give more permissions than needed. So make sure you know what you are doing. Now this numerical way of assigning and giving the permissions is very good, but at the same time there are other commands which you would like to quickly see. So now you see here others doesn't have permissions except for read. So let's suppose for others, which is denoted by O, I want to give a write and execute permission. So I will say O wx file1.txt. Now if I look for the file 1 now, I will see that for others, write and execute permission is granted. Earlier it was only read permissions were there, but write and execute was not there. But now with this command, other plus write and execute, I can give. I can, in the similar way, I can take away the permissions with the minus denotations. Minus means you just take away the write permissions, which is modifications and permissions, and execute permissions. Now if I look at the file here again it has been taken off. So this is with others. Same thing we can do with user, same thing we can do with group. So let's try to do with group. So group, we have removed the permissions of write and execute. If I look the file at now, file 1, this has been, so this we have removed. So user, group, so group, there were no permissions. Earlier there were only read permissions which we can read, and we have removed the permissions with respect to write and execute, which was not there. So something which is not there and you remove it doesn't make sense, it doesn't matter, it will remain the same. Let's suppose there is a permissions here, so we will add the permissions first and then we will remove. Let's suppose for group we will add the permissions write and execute. Now if I look here, so for group it is write and execute permissions are both granted, and if I want to remove it, I can say minus, and if I look here, so I will see that the permission is gone. These permissions were there which I have granted, and then it is gone. So this is just when you add it or subtract it. Now if you want to have effective permissions, you don't care what permissions was there earlier, I just want to give read and execute permissions. So you can say group equals to read and execute, and what it will do is it will just set up the group permissions as read and execute. So see, read and execute, write permissions are not there. If I give g equals to wrx, so it will set the write permissions. So this is the way you can set users permissions and for group and others. So there are a couple of other things with respect to sticky bit and set UID and UMask, which I will cover in the subsequent video. So thank you all for watching this video, and you have a nice day. Hello and welcome, friend. In this lecture we will try to look at some of the chmod command which we have left in the previous session. So we will continue that, and then we will look into change of ownership, which is chown command, and there is another command for changing the group, which is chgroup. So we'll try to look at some of this command. So we have already gone through change mode to change the different type of permissions with respect to user, group and others for read, write and execute permissions. So let's look at a typical file, and we see that here in this particular file, if we see here, we have all the permissions: read, write and execute for users, and then for groups read, write, execute, and again for others read, write and execute. So far so good. Now if we look here, there is a directory here. For a file it is okay, but for directory, suppose if we want to change the permissions of that directory as well as all the subsequent contents inside that. So if you look at this test directory, it is a directory which means D, and then it has read, write, execute permissions for user. For group it's only read and execute, no write permissions. So let's suppose for group I want to give the write permissions, as well as for group I want to give for as well as for others I want to give the write permissions. I can do it on the top level directory. If I go inside this directory, there are other contents, there are sub contents folders that will not be allowed to get the permissions if I give the top level folder. So let's try this by giving the top level folder 777 to this test. Now let's look at the permissions, ls-l for test, and if you want to see just the contents, the directory permissions, you can say ls-ld. Now you see ls-ld test directory, we can see that it is read, write, execute, all the permissions has been granted for the test directory. But test directory, inside the test directory there is a directory 1 2 3, and then there is some file. Those permissions are not changed, those permissions are still same. To double sure and verify, we can go inside the directory and see. You see, this is still not have the right permissions for this. So if you want to do that, there is a command called recursive permissions, and the way recursive permissions work is -r. So if you apply that on the top level folder, it keeps on going recursively till whatever nested level you have all the files and folders. So once we give this, and we of course test folder will be having the right permissions. If you see here, test folder, it got the right permissions, and let's get inside this and see everything get all the permissions. So the command is chmod -r777, and even inside one folder 1, if you go, there will be another subsequent folders, those permissions are applied to those folders also. So -r means recursive. Now if we look into the permissions here for any files or folder, you see there are two fields. So this is a permissions field, and then this we have already seen that how many links are there, which we have seen in some of the previous video. Now this is user, and then this is a group. Now if I want to change the group, or maybe I have a special privilege, some kind of administrative task group, so I want to make this particular file a part of some group, I can change that. So there is a command called change group. With change group you have to specify, and I have a group called Mike. So mind it, this belongs to user Shakil, but there is a user Mike as well as group Mike. So I want to change the group Mike for this particular file called file3, and since Mike is a different user, different group, I cannot just assign the group to Mike, so I have to say sudo. Now if I run this command here, ls minus l, you see this was belonging to Shakil, user Shakil, group Shakil. Now it is user Shakil, but group belongs to Mike. So this belongs to my group. So whatever permissions my group has, this file will automatically inherit those permissions. This is another way to change the group ownership, and with that you can change group and the user both. So let's suppose I have another user called John in my system. So the command is like this: chown, and then you have to say user John, and then you want to change the group also change. So from Mike I will change to John, from Shakil also I will change to John. So both user and group will change, and this is for file 3. And I have to give sudo because John is a different user, and right now I'm logged in with user Shakil, so I need a special privilege. Now let's look at the permissions. This is belonging to John and John. So earlier we started with Shakil and Shakil. Shakil is a user and then Shakil is a group. Here John is a user and John is a group, and we could have it differently, maybe John Mike or Mike John. We could do it in either way. So let's suppose we'll do it. We can change it to Mike and John, and now if I look here, it will be Mike and John, two different things. So we can change the group ownership like this. If we want to do it recursively, there is an option called -r, similar to chmod recursive option. So it will apply for all the files and folders. So let's suppose if I try to apply the same thing into a top level folder called test here, and if I apply test, and let's suppose if I go here inside the test, you see everything got changed. But okay, I think I didn't apply the -r options. Let me do it again, I'm sorry. So let's apply the -r options, which is recursively. Let's go inside the test folder, and you see everything belongs to Mike and John. Everything was Shakil and Shakil except for one which we have changed. Now everything belongs to Mike and John. So if you want to change the ownership recursively, you have to apply -r option. Change group options, if you need to change groups, chgrp with some group name for the files or folder name, you can do that. And of course you have to do sudo because you have to be a super user to run this command. And but you can live with change ownership. So change ownership is more than sufficient. If you want to look in the system what all the users and groups are present, there is a command called get ent, and if you want to see the user, you have to type password and it will list out all the password. So if you see one more thing, and some of you who are aware that this is nothing but the contents of etc password, so you can directly open in the vi and etc password and you can look inside the contents. So this is exactly the same content. So get ent password will tell you all the users present in the system by fetching the data from etc password, and get ent group will get all the groups in the system, and this is again similar to etc group. So there is a etc password which is for all the users and etc group which is for all the users, for all the groups. So this is the same command which fetches the data from the etc group. So these are the two commands which you might need to look at some of the groups and users in the system. So thank you all for watching this video, and I'll see you in the next video. Hello friend, what's up? We will try to look into some of the concepts like no hang up, background jobs, foreground jobs, and killing a job in this video. So I have a small shell script. Don't worry, we will go into this kind of scripts later on in much more details. But as of now, I wanted to show you this. So there is a variable called count, which is set to 0, initialized to 0. And then here, if you see, it's a hash not. It's a standard way of saying hash not bin bash. So this is my shell which I want to execute. If I want to execute in some other shell, instead of bin bash, I would have said C shell csh or sh, which is a bourne shell, or ksh, which is a conch shell. But we will be doing on bash shell. Now there is a while loop, which is an infinite while loop. It doesn't have any condition to exit out, and it will just increment a count, echo that count to a file, so we will not take it to a file for the time being. We will just show it onto a screen, and it will sleep for 1 second and then do it continuously. So let's try to run this command. Now once I run this command, you see that every 1 second it prints a number starting from 0, so it's increments to 1 and prints it, and it keeps on doing continuously. Now if I press enter, I'm pressing enter now, you see I'm not getting my prompt back, my shell prompt like $sign back. This is because my job is running in a foreground. It has occupied the terminal. I cannot type another command until this finishes, and this will never finish because it's an infinite loop. So you will come across a situation wherein you are doing a download of a file using wget or maybe using scp, and you are blocked with a terminal and you are not able to, and maybe you don't want to open another terminal. So what to do? So this is a command called control Z. I will write here control plus Z. So control Z, don't type the keyword plus, it's a control and Z like this. So you press control and Z. What it will do is it will push your job to a background and stop it. So what it means is it is no more running, it's in a stopped state. The operating system takes its state wherever it is running. It has last printed at 48 or 49 whatever, and it will keep it like it's in a frozen state, and when it resumes from there it will start back from 49 or 50 or whatever it was interrupted at, and it will not start from the beginning. So once you do that, once you press Ctrl Z, you will get your shell back. You can run another command, right? So now what you can do is you can run whatever you wish to, and you can push your command in the background. So when you push your command in the background, what this effectively means is you can get your prompt back. So let's do it with example. And with BG you have to give an argument which is a job number, and this is %1. So you can run the command jobs. So it will tell you what is the job. There can be n number of jobs, like we have run test. There can be so many other things we could have run simultaneously. So it will be job 1, 2, 3, 4, so on and so forth. So when you run like this, you can push it to a background by saying bg %1. If you don't give any argument, by default it will be 1, which is only one job. But if there are multiple jobs, then you will have a problem. So we will have the right habit of giving the job number. Now you see here it starts outputting from 49, so it was interrupted at 48 here, and then it started from 49, 50, 51. And if I press enter, I get my shell prompt back. I can still run some command. I can run ls-l. Don't worry if for the screen getting garbled, because on the steady out your ls command output is also coming, and at the same time whatever the count is increasing, that is also giving. But you can run another command. So one good thing is you got it unblocked. But if you don't want this behavior that the screen gets garbled, in your shell script you could have redirected to a file. Here we are just redirecting onto a steady out to demonstrate. And if I say jobs, so it's one job's running. If I want to kill this job, I could say kill %1, and it would terminate that job. So now you see there's no more coming onto a screen. So there is a kill command, then there is a foreground job, FG brings to a front. So if something is in a background, it will bring it to a front. So right now the jobs are stopped, there is no jobs. Let's run it again. So if I run it again, test.sh, it is coming, Control Z, it is pushed and stopped. So remember, when it is pushed to the background and stopped, it is not running. Only if you make it to the background, it will run. But this is stopped plus pushed to a background. Now if I say FG %1, which is job number, then it is coming to a forefront. I cannot get my prompt back. See, again it is the same situation. So again I press Ctrl Z. But if I want to run it without blocking my prompt, without blocking my terminal ability to type another command, I can say bg %1. So which means it's running in the background, but it is not blocking my terminal. I can still type another command. So now here I can type another command, ls-l. I know this is a little bit confusing, but once you practice, you will get to know about all this foreground, background. So I will just kill this job now. So this one more thing, if you want to run any command in the background, in a sense without blocking you, you could say ampersand. So if I run like this, you see I get my prompt back even though things are coming to a steady out, but the jobs are running. If you want to kill it, you can say kill %1. Or when you are writing like this and it's an annoyance, you could redirect to some file. So your script should be redirected to a file called logger.txt. Now if you run here, you see it is running. You're not getting the prompt back and nothing comes on the screen. The reason, everything is going to a file. So I stopped this. So stop, in a sense I terminated it. Now let's run it into a background with ampersand sign. Now this is running. If you look with the process ID, ps-ef is used to look into a particular process whether it's running or not. We will cover this in subsequent chapters, so don't worry about this, but for the time being I am trying to demonstrate that it is running. So if you can see, there is a process ID associated with this test.sh, so it is running. Even if you look into a log file where it is outputting its data, see it is continuously coming out and it's running. So it's outputting the contents to this file. And if I go with the jobs, the job is running. If I say kill %1, which is this job, it is terminated. And if I run jobs again, there is no job. And if I try to look into this logger file, it is no more progressing. It's just hang there because there's no more contents coming into it. The job got terminated. So thank you all for watching this video, and I will see you in the next video. We will try to look into some of the wildcard and regex. Thanks. Hello and welcome, friend. In this tutorial we will look at two commands which are called as sort, and the other command is unique. So sort command is used for sorting a file based on certain conditions. So there are different options which you can pass to sort, and we will look at some of the options which we frequently encounter. So I have a file called fruit list in which I have written the name of some of the fruit. So this is just a apple with a capital A and apple with a small a, then orange, banana, lemon, and lemon is duplicate here, watermelon, grapes. Now I want to sort this file. By default, sorting happens based on ASCII, or you can say based on dictionary type of sorting, that A comes before B and B comes before C, those kind of things. So it's a ASCII, or you can say dictionary format sorting. Now let's try to sort this file. So we have seen, if I do a cat for this file, this is the listing, and default with no options. If you do a sort, it's a dictionary sorting, it would look like this. So if you see here, it is apple, capital A was first, but here small a comes before capital A, and then banana, grapes, lemon, orange. Now if you see here, lemon is a duplicate. So in sorting I can pass an option which is -u, and it will remove a duplicate. So if I sort it again, you see this time lemon appears only one. So there are other number of options in sort. You can go through the man pages of the sort, and if you have something like human readable or case insensitive, like human numeric sort, or maybe case insensitive kind of things, ignore case, you could pass those options. So you can refer to whenever it's needed, but this is very generic one which we use many times to remove the duplicate, maybe sort. Now this is with respect to a file which is having some text. What if we want to do some numerical sorting? So I have a file called file number, and the content is like this. So it is again randomized, so there is no order in this. Now if I want to sort this file, so let's see how it goes. So let me just do a cat for this file so that we can refer into the screen. So my cat is this. Now if I do a normal sort, and you will see that it will do a ASCII sorting, which is not what I want. If I want in ascending or descending order, so ASCII sorting will not work for me. So if you see, I do a sorting which is ASCII sorting, so 0, which is okay, but 10, and after that -100, so this is not right. So if I want to do numeric sorting, so I have to say sort minus n. Minus n is for numeric sorting, and you say minus number. Now if you see here, it is sorted in ascending order. So minus 500 is the lowest, followed by minus 100, 0, 10, 20, 30, 40, and so on. Now what if I want to do a descending order, so which is a reverse sort? So I can do a reverse sort and see it is just the reverse. So starting with the highest, keeps on lowering and going to the lowest. Now let's suppose I have two files and I want to sort. So this is file number, and I have one more file called as file number 1. So let me show the contents of file number 1 to you guys. And sorry, it's a file number 2. Now this is another file which is having some decimal points, and this is also not sorted. What if I want to sort file number and file number 2 together? So the syntax for this is, you can say sort, and you can say n, which is numeric, and you can give multiple files, so you can say u, and then followed by numeric file 1, number 1 and number 2. So what it will do is it will concatenate both the files together and it will sort in the ascending order. If you want in a descending order, you could have given R, which is reverse, so it will do a reverse sort. So this is about sorting. Now the other command which I have told you is unique. Unique is to give a unique number. So let's suppose in the fruit list I have this lemon appearing twice. We have removed this with sort with minus u, right? So that is okay. If I could say just sort minus u, we removed it, that's appearing once. But what if I don't want to do a sort, but I just do a unique? So there is a command called unique, and that command is like this: pipe to uniq. So mind it, it's not unique, it's uniq. If you cat a file and pass unique, what it will do is it will take the subsequent characters. So if lemon appears twice, it will make it unique. Now here is the catch. What if in this the lemon appears somewhere else also? Suppose the lemon appears at 3 places. Now what if you will do? Now what you see here is those two lemons which were appearing together, unique has made it unique. But the one which was standing single, unique has not made it unique. So in those kind of things, what you might want to do is first sort and then pipe to unique if needed. So let's suppose I could have done fruit list, so which is a sorting, so which will arrange like 3 lemons, and then I can pass it to sort. So I pipe to sort, in the sense we can, so I'm sorry, pipe to unique, because we are already doing a sort. So pipe to unique, it will make the lemon unique. So here when we do a sort, and then there were 3 lemons, and then after sorting I said unique, and it makes 1 lemon. So unique is a command which make things unique, but it has to be appear adjacent to each other. If it is not adjacent to each other, unique will not work. So in that case, what you do is first sort, so that related things are together, and then you apply unique. So that's all for this video, and I hope to see you in the next video. Thank you very much for watching. Hello and welcome, friend. In this tutorial we will try to look at two commands. One is stop and the other is ps, process status, and these two commands will come handy while debugging a shell script. Maybe sometimes your script is written in some bad ways, it consumes too much CPU, or maybe something is consuming more CPU and you want to debug your system. So that comes very handy. So there is this command top. So by default, when you run the top command, it will not return you the prompt back, and it keeps on continuously running. It's like Windows Task Manager. If you want to come out of this top command, if you press enter, it will not come out. So what you have to press is Q. Q means come out, quit. So let's run it again. If you look at the top command, the first few lines, 4-5 lines, it will give you some system details, and then it will give you the individual process details. So it will say you uptime, for how many days and hours the system is up, how many users are there, and then there is the concept of load average. Load average is average calculated over a period of time and says how much your system is busy. and then how many tasks are running, sleeping, stop, zombie. You might have to read some of those concepts. Then here is interesting field called percentage CPU. Right now it's like 3.8, 5.8. It's less. Suppose this percentage CPU goes to 70%, 80%, and the system becomes consistently very busy and it will be low in performance. Then this is a memory. I have approximately 3 GB of memory, and this is a swap space. So this is my swap space, like approximately 4 GB, and how much is the free, how much I am using, and how much is the available. Now the next sections in this top command will give you PID. PID is process identifier. Each process which runs in the system will have a unique identifier. It's like to identify the process uniquely. You can refer from the kernel perspective, from the user's perspective. You can kill. It's kind of a name, but not exactly name. Name is binded to the process ID, but process ID is a unique identifier. Now you see here, this is a PID. Then who is running those processes? Users. Then there is a priority field, then virtual memory, couple of other fields, how much shared memory, resident memory, and then for individual process like console process is consuming 1.7% CPU, it is taking like 2.1 percentage of memory, which is this memory, and time and commands. So this is the way you run it. Now sometimes what happens is you are debugging something, you want to get a trace log, and you want to get the output of top in your script, or maybe from your script you run top. But if you run from your script the top command, it will just hang there. So top has an option called batch mode in -b, and you can give how many iterations you want to do. So top keeps on running, so you can give the iteration. One means only run only once, two means run two times and gives the output, and batch mode means it will not hang the way we were seeing it, that it will not block the console, it will just relieve it. So now if you run here, you see I got my prompt back, which means top command ran, executed, and prompt. So this way I can take it output to some file.txt, and I can see the output later on. So you can use top in this way to get an output to a script for debugging. The other command is called ps process status, another very interesting and very important command. So by default when you run ps, there's an option called ef, which means that you show all the process in the system. And let's pipe it to more. I want to see one page at a time because there are many more options, many pages to display. So in the process, the first field is UID, which is a user identification, which means which user is running these processes, and this is root. So if you keep on going down, there might be other users which is running this process. So let's go back again. And then for this process, what is the PID? This is my init process, which will always have the PID 1. This is my parent process ID, TTY, time, and what is the exact command it is running. Now if you see here, this field is limited, it can go up to this much width. So sometimes the command is very big and it might not show all the options. So in ps there is an options called as ps aux www. You have to remember this, and if you run this, it will show you more details and exact command line options which you use to run this particular command. So ps will be very handy. So by default, if you see here, ps has those three fields: PID. So, and mind it, for each ps options, your heading and everything will change. So there's a lot of formatting options which you can use with ps. You can go through the man page for ps. It's not possible to show you all the details because ps has probably more options, much more options than all the combined commands put together in Windows. It has that many options. So let's see, if ps you run it with -ef, you will see that UID, PID, and PPID, those are the three fields. If you run ps with -elf, E and L caps, this L means you show all the threads. Then you will see that there is that UID, PID, PPID, and then there is the LWP, which is a lightweight process. In Linux, threads are called as lightweight process. So it will tell you the thread identifier also. So that way you can run PS. So you have to practice PS and top. And if you have some doubts, probably do Google, search in the forum, look into the man page. But I'm pretty sure those two commands, if you are making a career in Unix or Linux, top and PS will help you a lot for debugging, knowing where the problem in the system is, and those kind of things. So thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye. What's up, friend? In this tutorial we will try to look at the concept of redirection and pipe in Linux and Unix. So the first thing is, what is a file descriptor? So you will come across this concept and terminology many times. So file descriptors are integer numbers in Linux and most of the Unix distributions, which represent a kernel data structure to associate a unique file with a corresponding integer numbers. So what it means is, by default the system will assign one integer number to each of the file you open, and with that integer number you can do any kind of operation. So if any one of you have done some system programming or C programming, they will know what is the return value of the open system call, OPEN. So when we do the shell script is also basically nothing but a wrapper on top of all the system calls. So shell script also uses system call, so which means they use the similar terminology. So that is the file descriptor, and we will look how we can use this. Now, as I said, that file descriptors are associated with the open file. So by default, the system creates three global file descriptors. One is 0, which is steady in, standard input. So if you type some input from the keyboard, like let's suppose your program asks for some input, enter how many vegetables or how many quantity of fruits you need. So you enter some number, and when you're typing those on terminal, so there is a file descriptor associated with that. That terminal input goes to the variable you are using, read or some variable, it will go into that, excuse me. So similarly, there is a steady out. When you say echo hello and you see on the terminal the keyword hello getting printed, so how it gets printed, how does it knows that it has to be printed on this terminal and not maybe on some other terminal? So it associates a steady out descriptor for that terminal. And the last is stderr. So just to differentiate between std out and stderr, sometimes there are a lot of std out like logs files might be outputting onto a terminal, and then simultaneously there are some errors that also gets output onto a terminal. You will not be able to distinguish between std out and std error only if they have a different file descriptor. So that's why we have a different file descriptor for stderr. Now apart from these three, you can create your own file descriptor, but these are the three standards. So if you open a file, you will not get a file descriptor as 0. You will get only starting from 3, because 0, 1 and 3 are always reserved for any process. So those three, std out, std in, stderr, are always reserved. Now let's see some of the redirection thing. So if you look redirection greater than sign, it means that redirect to a file or std out. Now std out is also treated as a file because it has a file descriptor associated. So we will say it's redirect to file or std out. Similarly, when it's a less than, which means you input from a file. Input means user input some data by hand by manually typing onto the keyboard. And when we have less than, which means that you append rather than overwrite. And similarly for greater than, which means whatever output is there in a file, you are outputting to a file, so you don't each time override with the new content. What you do is you just keep on appending at the end of the file. So in terms of numerical values, whatever we have shown, like greater than sign, so when we say 1 greater than file name, now we know that 1 is associated with std out. So remember, 0 is std in, 1 is std out 2 is std error. So when we say 1 greater than file name, which means redirects std out to a file name, and then this is the same thing but it's a append, so which means you keep on adding at the bottom of a file or std out. Even though for std out it doesn't make sense, because once you have thrown an output to a screen, it doesn't make sense because that will still be visible whether you append or you just overwrite. But for a file it does make sense, because suppose you have outputted hello world into a file, and the next time you are outputting as here redirection maybe hi there, so hi there will overwrite hello world. So when you open the file you will see hi there, hello world is gone. But if you use greater than, which is an append, so if you open the file you will see hello world, and then on below line you will have hi there, so which means it's an append mode. Same thing here with 2. So 2 is stderr file descriptor, and so 2 greater than file name means redirect stderr to a file name. And when we have this special symbol called ampersand greater than file name, it means redirect both the stderr std out to a file name. So everything whatever is there, just redirect to some file name. Then there are another important concept called as dev null. So dev null is a special character device which is default created in the system, and the useful of this dev null is like it's like a black hole. Any data which goes to a dev null is lost. So why do we need it? Sometimes you want to discard some data, like for example you want to kill a process, but it might happen many times that process is already being killed or doesn't exist. So when a process doesn't exist and you want to kill it, it will throw some error, and you don't want to show those error messages. In those kind of places, what you do is you redirect the kill value, kill -9 or minus int, with some process ID and redirect to dev null, which means even if the process doesn't exist, it will not throw you the ugly message that process does not exist or PID doesn't exist. So now let's go through some of the examples which we have discussed now. So let me do the first thing. So let's do a basic command ls-l, which we all know gives you the listing of a file or directory. So I have this listing. Now if I want to take it into a file, so as I said, by default this goes into std out, because you are able to see which is standard out, it's coming to a terminal. So it shows on terminal. If I want to take it into a file, so I will say file name.txt, any file name.txt. Now you see, imagine after this there is no output onto a screen, everything went into a file. So if I open this file with the vi, and you will see that I have this contents listed. So everything whatever was thrown onto the std out goes to a file. So far so good. Now let's suppose I want to create an empty file. So this is when some output is going to a file. If I want to create an empty file, I can say file name or maybe something file name 1, because file name already exists, so I say greater than. Now if I look into this, there will be a file name 1 which is empty file, 0 size. So there is this shorthand notations. If you want to get rid of all the contents from a file, you can just say greater than file name and it will create. If you want to do for this file, it will just remove the content. If the file doesn't exist, it will create a new file like this. So this is about file name. Now let's suppose we already have this file name, so let's open this file name again which we have created with the listing, and the end line if you see has a file called test9. Now let's suppose what we do is we echo something, echo hello maybe, and then we say greater than, which means append. So what append means is whatever is content is there in the file name, don't overwrite, just on the new line write one more hello, and by default echo prints into a new line. So if you do like this and try to open a file, what it will do is it will say hello with all the other contents remaining as it is. Now what would happen if you just say with a single write and maybe hello 1 2 3. Now if you open the file, you will see that only this is there. So this is no more in append mode. So single greater than is just write whatever is there onto this file, so it will overwrite everything. Double greater than means it's an append, so whatever is there just preserve and write at the bottom of the file. So that's the difference between append. Now let's suppose when we were doing this command ls-l, it was printing into the std out, and then we used to take it into file. Suppose we don't need this information, we might be doing some operations and we don't need to see this because you're running it as a shell script. So you might say redirect to dev null, so it just goes to a dev null and it vanishes. And mind it, if you look into a dev null, it's not a regular file, but it's a character device. So a C in the beginning means it's a system character device. It doesn't have size, it has a minor number and a major number for device operation. So what it means is this cannot be getting full. So don't expect that, oh, if you put so too much contents into dev null, it might get filled or something like that. No, it will never get filled, and you can dump the data as fast as possible, maybe tons and tons and GBs of data per second. It will never get filled. So just for knowing, you will never be filling up those much data, but I just wanted to point out that this data will never get filled. So you can put or push as much data into dev null and it will always be discarded. The other thing is, let's suppose I wanted to do something like this, ls minus l, and I want to check if a file 1 2 3 4 5 exists or not. So you see this file doesn't exist and ls tells me, oh, no such file or directory. So what this effectively means is this message which gets printed on the screen is coming to stderr, not std out. So even though it is outputting onto a terminal on your console on your xterm, that doesn't means this message is coming to std out. So this message is coming to stderr. Now let's suppose if I try to take this message into a new file, file 123.txt suppose, and you see it has not gone to the file, but it is still coming onto the screen. But previously when we tried to take ls, it all went to a file. So why it is not going to a file and it's coming to a screen? The reason, when you redirect like this, that means only std out goes to a file, but this message is printing on stderr. So a stderr is not redirected to a file. So you can do these redirections by saying, okay, so redirect to a file. So ls minus l test, and then you can say 2 greater than ampersand 1. So what 2 greater than ampersand 1 means? 2 is stderr. So what you're saying, okay, put everything to a file, but you also put stderr to 1. So stderr to std out. So first you redirect from stderr to std out, which is your current terminal, and then output everything to this. So remember, ls gives the output to std out, but only when there is an error it sends to stdr. Now if you do like this, you see there's no error shown onto the screen, but if you open the file, you can see this error message. So this is the way you can tap. And how do I know that this is an error message? Okay, so let's look at the error message command. So after every execution of a command, there is a success or failure message which a shell prints for you, provided the command supports it. In this particular case, you can see this error message by echo $? Now you see, whenever the file doesn't exist or is there is any error, it will give you a number which is non-zero. Anything apart from 0 is a error message. So here it gives you a non-zero message 2, which means this is an error, and this throws to stderr. Now if I say just ls minus l, which means it's a generic ls minus l, it prints out everything in that particular current directory. And if I do echo $? After that, it zeros, which means it's a success. So that's why all these messages which it prints as part of listing of the file, it's printing on std out terminal. So remember, there is a std out and stderr, both prints onto a terminal, and then there is std in, which takes the input from the terminal. So we will look for more of these concepts in our next part. So thanks for watching this video, and you have a nice time. What's up, friend? We have saw some of the redirections in our last tutorial, and in this we will try to look at some of the redirections in more details. So the first command which we will run is exec. Now exec is a shell inbuilt command, in the sense it's not an extra binary or utility which supplements the shell functionality, but it's part of the actual core source code of the shell. So exec spawns a new process. It's similar to fork, if some of you are aware of system calls fork in C, but exec differs slightly, which we will not go into the details. So as of now, the only thing you can consider about exec is exec spawns a new shell or spawns a new process if it needs to run some command by default. But if you don't give any command, and if you give a number, integer number, so what it does is it does a redirection of the entire shell. So you have opened one terminal and there is a shell associated with terminal bin bash, and when you say exec like this, so what it means is it opens a file descriptor 3 and it redirects all the contents to that file name. So which means anything which writes to file descriptor 3 goes to a file. So we have seen std in, which is 0, std out 1, stdr 2. But where is this 3 coming from? 3 is users. So 0, 1, 2 is created by system. 3, 4, 5, 6, as many numbers as you wish to. There are some limits, so we will not go into that limit. But you can create all those other file descriptors you wish. So let's go and run a quick example what I mean by that. So this is my terminal, and then of course there is a shell associated, because whenever you open a terminal there is a bash running inside that, because terminals are associated with a bash. Okay, so now let me run one quick command, and I will say exec 3 and less than greater than, and I will say mylog.txt. So I will say now echo hello. Now if you see hello is coming to a screen. It's not going to a log file. Had it been going to a log file, it would have not printed on the screen. Why it's not going to a log file? Because we are redirecting 3. When by default when you say echo hello goes to std out. But we are not redirecting std out to a log file. We are redirecting file descriptor 3, which doesn't have any name, because only 0, 1, 2 has a specific name. Now let's suppose I write the same command echo hello and I say greater than ampersand 3. What this means is whatever I am typing here, it should be redirected to file descriptor 3. Now when it is going to file descriptor 3, we have already set up our redirection that whatever comes to file descriptor 3, put it to a log file. Now when we run this command, you see there is nothing coming onto output onto a screen. And if I see my log file, the log file has the word hello. Now if I say again another keyword hello world, again it's not coming to a screen. And if I say here, so if you see here, it gets appended. So even though we are saying redirect to a 3, once it goes to a file, so everything when it goes to a file, and even though we are pushing in this file here, when it opens, everything when it goes to a file, it's in a append mode. So even though the symbol here is greater than, but it keeps on appending, writing. Now if I want to turn off this behavior, because I have already set up the redirection, so I can do exec 3 greater than ampersand hyphen. So what it means is whatever redirection is there with respect to file descriptor 3, we will cancel that. Now once I cancel that, and if I run this command again, it will give me an error, bad file descriptor, because this file descriptor is not being redirected. So when I'm writing to 3, it's a bad file descriptor, and of course it will not go to a log file. Whatever was there previously, only those contents will be there. The new contents hello world will not be typed. So to make sure it's a new, we will just try it like this, and see there is no hello world new. So this is the way you can redirect any specific file descriptor. So you exec 3, you can have 3, 4, 5 and followed by less than, greater than, and file name. To close that, you see exec 3 greater than ampersand hyphen, so it will close the file descriptor 3. So once you close that, if you put a message like this, it will not go through, it will give a bad file descriptor. So we have already seen, so the generic form is n less than ampersand hyphen, which we have seen like 3 less than ampersand hyphen. So instead of 3, it can be 4, 5, 6, whatever. It closes the input file descriptor. So when it's a less than, it's a input. When it's greater than, it's the output file descriptor. So here less than is the input file descriptor. Now when you say 0, where 0 is std in and then it's a less than. So you can use either this form or this form. So by default, if in less than, if you don't give any number in front, which is counted as 0, so you can either use 0 less than ampersand hyphen, or you can say less than ampersand hyphen. Both closes the std in. If you say n greater than ampersand hyphen, n replaced by some numbers, so which means greater than is std out or output file descriptor, so you can say 3 greater than ampersand hyphen, which closes the particular output file descriptor. And here 1 greater than ampersand 1, which means 1 is std out, so close the std out. When you have a greater than sign and then there is no number, by default it takes as 1. Now there is another command, or you can say concept, which is pipes. So pipes are used to pass the output of one command to another. So what I mean by that is, we will look by some example. So one of the example we have is ls minus lr. So in ls minus lr, r means recursively go and fetch all the content. So if I run here, it will just try to get lot and lots of data for me, which would be too much and I would not be able to see. So if I want to see one screenshot at a time, so I can pass it to another command called pipe and less. So this pipe means pass the output of ls minus lr to less command, and whatever less does, it's up to less, whatever way it processes the data. Here the less command, what it does is it prints one page at a time, and when I press the space bar, it prints another page, then I can see what the data is. Even though there are a lot of data, I will not be able to see all of them, but it can process the data at a time. So pipe means you output the commands of the output of one command goes to the as an input to another command. So this is the first command, the output of whatever content shows on the screen goes as an input to less. And then there is another command, like let's suppose you want to show 10 files into a folder. So if you say ls minus lt, and then you can say pipe head minus 10, it will say only 10 outputs, and this 10 output includes this. So this is 1 2 3 4 5 6 7 8 9, and then this one line 10. So which means 10 line needs to be printed, and this is just a metadata. So you don't, this is not the actual file, but this is a metadata. After metadata, it prints out the contents. Then similarly, if I want to in my system to find all the file of type f is a regular file, and count it, so we can do that. So I cannot go inside my entire system, it will take a lot of time, but we can run here. So I have some of the files folders and some directory hierarchy. There's one directory and some concepts of files. So I can say find dot, and then I can could say type f. I wanted to have type f, so minus type f, and by default if I do this, it will list out all the files. And if I pass it to word count, it will tell me word count is wc, it's a feature. It will say how many lines, characters, and lines, characters and words are present. So each line is word here, so that's why word and line are same, because each line is counted as one. If there would have been some space between these file names, a file name which has some space in between, then it would have counted as two words, but usually I don't create file like that, so that's why line, word and counts are there. If I want to just see the line, it will say minus l options, which will give you 41. So word count is one of the features through which, like, whatever the output of the command find is there, I am piping it, I am giving it to word count. So this is another important features which we will be doing. And then similarly we can do, like, we have this etc password, so I can just do a word count etc password. So here is another interesting thing. Let's suppose we say word count for slash etc slash password, so it will give me the word count. That's good. Now let's suppose I want to take this to a file. So usually what to take this to a file, because this is coming to std out, so I can say okay, file 1234.txt, and it goes to a file. I am not able to see onto a screen. But what if I want to see onto the screen and put it to a file? So I can pipe to another command called t, and t is a special command wherein whatever you pass it to that particular command, or I'm sorry, whatever you pass as the output of that particular command to T, it will push it to a file as well as show onto the screen. Now if I say here, see, you are seeing it on the screen, but simultaneously this file 1234 has it also there. Now if I just put it again, maybe another file, or maybe in this same file again another time, if you see here, it's just overriding. So there is an append mode also in the T. Some of the binary you can do that, but the bottom line is there is a command called T, using which you can show onto the std out as well as pass it to a file. You can redirect to a file for reading on later and see. So this is useful when suppose you are doing a make and your make takes a lot of project files and it takes some time. So sometimes you want to push the output of make onto a screen, and at the same time if there is some error message you want to go and refer into a log file, so you cannot issue the make file again. So what you do is you pipe it to a T make, pipe to T, and then some log file. So what will happen is you can see onto the screen, and then if you need to refer back, go and look for some syntax error or something, you can go and look into the log file. So that's the advantage of T. So those are the two commands, and I will try to cover some of the other concepts like wildcard in our next session. So hope to see you soon there. Thank you very much for watching my video. Hello friend, what's up? In this tutorial we will try to look at the concept called wildcard and regex. So first we will cover wildcard, and in the subsequent chapter and lectures we will try to cover regex. So what is a wildcard? Wildcard are a way in which multiple things can be selected, or a rule can be generated in which a shell can expand and select multiple items based on certain characteristics. So this might not make much sense to you, but let's go through some of the examples and we will see what is it exactly. So we will take all our examples with respect to ls because it's one of the most simplest of the commands and the most useful command. So let's see, if you say ls, it will list all the files and folders in that directory without long listing. With long listing you have to say l, so we will just say ls. Now let's suppose if it's saying all the files, I want to find a file which is of single character name. So what you have to say is there is one file called one. So there is a question mark. Question mark denotes one single character. So there is, if I say ls question mark, it gives me just one file. There's no other file which is of one character length. Now if you see here, there is this file which is 4 character, 5 and 3, 8 characters. If I want to represent 8 characters, I have to say 8 times 1 2 3 4 5 6 7 8. So it matches exact 8 characters. And see, there are some files which are of 8 characters, this file, this file, this file and this file. So as many question mark is there, it matches that many characters. Now if I say 2 question mark, there's no such file with the name 2, two-letter name. If I create a file with a two-letter name called as AB, and now if I run this, it will tell me AB. So question mark denotes one or more character, but it has to be at least one. When it says one, means it has to denote exactly one. It cannot be 0. Now there is a character called star. So this star represents everything. So it could be a 0 or more than 0 match. So what it means is it will match everything. So if you say ls star, it shows you just everything. Where it will be useful, suppose I want to match a file with extension .txt. So what I could say is, okay, match anything which is a star and then followed by .txt. So it will list out all the files which are having extension .txt. So this wildcard star will be used in those places wherein you have to match n number of characters. This n can be anything, and then followed by some more text which you want to find out. Similarly, if I want to find all the PDF, I could have said ls star.pdf. It could give me PDF file. So we have seen dot, we have seen star, two wildcard. Now There is a bracket which can also be used for selections, and it represents a range. So let's suppose I want to find a file which starts with M, and inside that the letter could be from A to D and ends at N. So the representation bracket will be used for that kind of range representation. So the file starts with M, ends with N, and then it could have any representations from A to D. If I run this, so I have a file called mbn. It starts with N, M ends with N, and then the letter B falls between A and D. So this is the bracket representations which denotes range. You could have also given 0 to 9, and it can tell you the file if it belongs to, or if it is there. If nothing is there, it will not show you anything. So 0 to 9, there is one file called 1. If I want to have multiple matches 0 to 9, then I could have given star, and it could have list out like this. So all the files which is having some new numeric digits, it will list out like this, starting with numeric digit. If I want to represent files like which starts with text and then there is numeric digits, I could have given a star here, and then you could have listed all the files which has some kind of numeric digits 0 to 9 inside it. So those are the ways we can do. Then there is a curly brace match. The curly brace is like this. Inside the curly brace you can give some wildcard. That wildcard is star.doc, means search anything which a doc, followed by comma and star.pdf. What it effectively means is search for me a doc file and pdf file. So there is one doc file and then there is one pdf file. If I could have said star.txt, it would have matched that as well. So there is a comma here, so it has matched doc file, it has matched pdf file, and then it has matched the text file. Now let's suppose if I give something which is not present, star.exe, so you see whatever matches it will throw on the screen, but for something which it doesn't matches, it will give me a std error also, that cannot access star.exe because there is no such file star.exe. Now let's suppose I want to do a matching of all the files which does not have 9. So which does not have 9, you match all the files. So if you say ls test underscore, so I have like test files are there, like test1, test2, test3, so many files are there. I could have said not conditions, which is don't match 9, and then you give like this. So you see it will tell you all the files which doesn't have 9. It has 19, that is okay, but it doesn't have 9, so it will ignore the line 5. So if I see everything listing, so there is a test 9, and then 1 2 3 4 5, so it will show everything, but it will ignore the number 9 files. Which file is this test underscore 9? See, it ignored 9, but it is displayed everything. So not will be used for ignoring anything. So you have to use the right combination of star, bracket, and things like that. Now there is this backslash, the concept of backslash. Backslash is used to escape any characters. So let's suppose I want to create a file creation I can do with vi cat, or maybe just a touch will create an empty file. So I would say backslash. Now if I say backslash, it has given me a secondary prompt which is called as ps2 prompt. So it is not creating a file, it's just giving an error, missing operand. It has not created a backslash file. So backslash is not by default not allowed in the file name. So if I want to still create a file name with a backslash, I have to give one more backslash. So the backslash has a special meaning that when you put a backslash, it will use as escape characters, which means that you use a string literal. So one backslash is for escape, which means it tells the shell, okay, I'm giving this as a special character by denoting it as a backslash, and you use it for whatever reasons. Now if you see here, there's a file backslash getting created. Similar thing, we can want to create backslash dollar, and then if you create a file, there will be special. So that means it's telling a shell, okay, use this as a literal. The other example is, let's suppose you want to create a file with a space name. Suppose hello there, this is my file name. So there is a space here. So if you want to create a file like this, you could say backslash hello there. Now if you look here, there is a file this hello there. So you have to escape special characters. So backslash is used for escaping. So it tells, okay, use this space as a literal because I have put it as a backslash. And if you want to put backslash itself as a special character, then you have to do escape for the backslash. So that means it treats backslash as a special character. Now if you see here, there is two files getting generated. The reason, because you have not done escape. So this first escape is for this backslash, but then this space you have not backslash, so we will say another escape. Now if you run here, and you will see, okay, hello backslash space there. So backslash is used for escaping any special characters which will not be otherwise interpreted by the shell. You can use it to use it as a string literal. Okay, use this as my file name or listing or whatever. So that's all for this video, and I hope to see you with in the next sessions with respect to regex, and we will delve much more details in regex and try to work out on some of the problems and look for grep, those kind of commands which supports regular expressions. Thank you. Hello and welcome, friend. In this tutorial we will try to look at some of the find syntax. So find command is used for finding any files and folders in some directory hierarchy. So it's a very useful command, again another useful commands, because sometimes if you want to see how old a file is or who has modified a particular file in the last 10 days or maybe in the last 10 hours, you can do that. So let's start with very basic. The basic syntax is find and followed by any path name, and when you don't give any other options, it will list you all the files and folders present in some particular path. So let's suppose if I say dot, which is my current working directory, it's a special notations for current working directory is dot, and dot dot is for previous working directory, which is a parent. So let's say find dot. So what it will do is it will try to list out all the files and folders in the current directory. The current directory is home Shakil. I could also go to one of the folders which I have created. This is called as BSSG, which is my own folder which I written for bash shell scripting. Now if I say find dot here, it will give me all those files and folders. Now if I say the same thing with the path options, it would give me the same thing. So this is a very simple syntax. Now suppose instead of finding all files and folders, I want to find some particular file with the name abc.txt. So I have many files in this folder called bssg, which is in my home directory, so home Shakil, and then there is a folder called bssg. Now if I want to see if I have a file called abc.txt, so the command for that is find followed by any path. You could have given just dot, but let me give a path for some of the examples, and then later examples will just leave with the dot or path. Now if I see here, you see it has given me 3 files. One is this home b41729, then this file, and then this is the third file. So it has listed me 3 files with the name abc. I could have given the exact same command with dot because I don't want to search everywhere, and it has given me the same thing. Now if you see here, if you give the complete path, it will show you the files and folders in the complete path only. If you give the relative path, which is dot, so it will show you from that path only. That is the only difference, but in terms of contents of the find command, it will remain the same. Now this find name will find out all the files with the name abc.txt. What if I'm not sure whether A was capital or small, or maybe B was caps? So if you want to find in a case insensitive way, you have to say I. I means case insensitive. So you could have find any file with the letter A, small or capital, and in any order. So any order in the sense in any order of capitalized. So if you see here, there is this file abc.txt. This was not found in the previous find, because we were just looking with the name. Now this time we are looking with case insensitive. So what it means is that small capital C would also be listed as a file. So I'll see this as a case insensitive. Also by default in find there is this option find dot, and you could say print. Now print is more like a historical thing because the find which we use is from GNU. So GNU find by default just prints everything, so you don't need to give the print option. But earlier command when we used to execute in old days of AIX and Solaris, you used to give print. So but now it's not needed, so but I just thought of mentioning. Now let's suppose I want to find all the files which are of type CPP, which means extension.cpp is there. So wildcard is also supported. Wildcard and regex, regular expressions, are supported in find command. So I could have given star.cpp. So it will find out all the files which are of type CPP. So let me show the command again. Find dot minus iname. I'm giving case insensitive, anything. So most of the time I use minus iname. You could use name, iname, depending upon your habit and choice and what kind of options you use most of the time. And within the code you have to see star. So anything, it starts with anything, but it has extension CPP. So I have these are files, my CPP files. Now these are files in all the folders and subdirectories and subdirectories. It will find out recursively. So from BSSG, after that bforce, virtualizations, ZenMaterial, ZenStore, everything it will say like that. What if I don't want to descend to this level? Maybe I want just one level. So this is current directory is one level, then this another level is a directory called bforce, and maybe one more level. So I want just two level or three levels. So in that case the option is max depth. So I could have said max depth, which means don't keep on descending to all the levels. You can just descend till two levels. And if you see here, the files are much lesser because most of the files are in longer directory, bforce, virtualization material, ZenMaterial, and then I have a C file. So this is dot is level 1, level 2, level 3, level 4. So this is 4 level. But here I am saying, okay, give me just two levels. So it will just give me one current directory, one CPP file, and then inside my test folder there is a hello.cpp. So you could specify depth. You could say maybe 5 or 3. You could give 3, then you get some more files, maybe this one. See, this is at depth 3. So first was my current directory, that is level 1, then this bforce directory level 2, then new IDC is my level 3. So at depth 3, max to max it can go depth 3. So it will find the files at depth 1, depth 2, and then depth 3. So this is the way you can say depth. Now let's suppose I want to find all the files whose name does not have CPP. So that means give me all files and folders which are not CPP file. So I can give that too. So I can say minus not name star.cpp. So what I'm saying is find all the files, go to max depth of 3, and whose name is not a CPP file. So then you see it will give me all the files except CPP. In the previous example we were trying to find CPP. Here we are trying to find CPP. But in this example we are saying don't give me CPP, everything apart from CPP. So if you see here, it has given me all the files. So this way we can tweak different options in find, and we can get the way we want everything. So I hope you enjoyed this video, and I will have a couple of more videos with respect to find. So please go ahead and read all of them. Thank you for watching this video. You have a nice day. Bye. Hello and welcome friend. In this tutorial we will try to look at some of the more options with respect to find command. In the last video we have seen that how to file any particular type of file, like let's suppose CPP file. So we have already seen that. Now let's suppose I want to find a file which is CPP and also all the files which are of header type, header file.h. So in C and C++ you will have the header file.h and the extension can be cpp. So I want to find all files with -i name and which has the extension star.cpp. In this case iname is not necessary because iname means case insensitive, so all the file will have cpp, but even if something is like this it will find out, so it's not necessary, but still I am giving. And iname star.h. so what it will do is find all files which have extension .cpp, and -o means or the file name has .h extension, so -iname, this is minus. So you'll see it has given me all the files which are of type header file. This is my header file.h or cpp file, so it has listed all those files. Now let's suppose I want to say, okay, don't go, like there are multiple levels. One is the current folder, then the folder befores, then kernel programming and blah blah blah. I don't want to go till this much level, so I could have given the options minus max depth and I could have restricted this to 2. So I would have said, okay, just go till 2 levels and give me all the files and folders. So if I go to level 2, which means just look at the current folder and max to max one more folder under the current folder. Don't go after that. If there is something nested level of directory, it will not go till level more than 2. Now if I say level 3, still I see that there are 3 cpp files, one is cpp, one cpp, one cpp, but there are no header files because till level 3 there are no header files. If I go for depth 4, I might see some more cpp file and some header file. So this is at depth 4. So this way you can find out. So we have seen this -o option is OR. Similarly we have an option called and that and is -a. So we could have given that -iname find all files with cpp, and I want my file name to be having the keyword thread. So I could have given like star thread star. So in my program there are so many programs which I have written with respect to stack size, kernel, CPU and everything. Let's suppose I want to see all the thread programs which I have written which is in cpp file. So I would say find dot, which is in the current working directory, iname case insensitive, find all the cpp file, and -a means and the options are star thread. So the file name has the keyword thread somewhere. Now if I see here, so I don't see any file with the keyword thread which I have written. Now let's suppose I want to go in some other folder and try to see that. So this is not giving because I have to put it in double quotes. Now you see here that it has given me the thread function, thread file. So this is a pthread functions class .cpp. So these are the files, it will show it to me. So like this. Now let's suppose I have a requirement that I need to find all the file which has a name abc and it's not a PHP file. So for finding a PHP file, that's very easy. I could say star.php, but what I am saying is, okay, find the file with name has abc. So it could be abc star, so I could say just abc star, and I would say not minus name or iname double quotes star.php. So what it will do is it will give me a file which has the name abc, and this is not of type PHP, so this is a not. So if you see, this has a name abc in the file name, this has the name abc in the file name .txt, then this file name abc.wrap, abc.txt, and then this is again abc, then this is the assembly. So this is the way we can find out. Now let's suppose by default when I find a file, so if you must be aware that in Unix everything is a file. When we say everything is a file, our directory is also a file itself is a file. So a directory is a file which contains other files and folders and directories. So folders and directories are same. We will use one way or the other, but it means the same. So a directory is a container which contains files and directories. A file is a regular file. It has just the content. So that's the way. So normal file we will distinguish by using the keyword regular. Regular file, when we say, it means a file which has some contents written inside the notepad and that holds that contents in a notepad or a VI, and we save it, that is a file. Okay, now let's suppose if I say find a file which has a type F. When we say F, which means it's a regular file, so I would say ABC and star. So what this command will do, find in the current directory a file of type F, which means find a regular file and whose name has ABC, starts with ABC, and then it could have any characters, any letters, with star is signifying the wildcard. So if you see here, I can find this kind of files here, abc.txt, abc.hla, this is my assembly program, those things. Now let's suppose if we want to find a file with same ABC but of type directory. If you see here, this is a directory. I could have seen this directory by ls-ld. It will show me the property of the top level and it says that this is a directory. I could also go there just to verify that it is indeed a directory. Whatever I found here is indeed a directory. You see, and this is the directory. So ABC was a directory. So to find a file of type directory, we will say type D. A regular file would be type F. Okay. Now if I want to find something in two folders, suppose my root, so I would say find. So first let me not give sudo, first say find / I want to find everything in root, and at the same time I am giving one folder called Shakil, and this Shakil is mounted in a different partitions. It doesn't belongs to the root, it's not in home root, suppose something like that. And if I say type F and minus name ABC star, so what this guy will do is find in root and then home Shakil. This could be two paths. So the first, all the examples which we are seeing having one path, which is here dot. Dot means current directory. We could have given any path in that, but here we are giving two paths. So find in this path and find in this path. A file of type F and whose name has a letter ABC and then followed by any other letters, characters or anything. Now since I am using a normal user and if I try to find anything in the root, I need to have a permission. So I will give us sudo word. So if I say sudo, it will try to find out it will try to ask me the password, and then it will try to find all the files and folders which has the name ABC in /and/home. So it will try to do that. Now let's suppose if I try to find a hidden file, so how will I do that? So for hidden files, if you know, any file with starts with the name starts with the letter dot in Unix or Linux, it's a hidden file. So usually hidden files are shown by the ls-la command. So you can find with type F. Suppose you have a hidden file type F, which is a regular file, and you say minus name dot star. So you will find this as a hidden file. So if you see here, this is a dot directory, is a file, and then dot cmd, and then dot cmd, dot cmd. So all these are hidden files. How is it hidden? We can go to one of the folders and verify also. And if you see here ls-l, it will show me all these files. It doesn't show me any of those .a file. So ls-la, if I say here, you see there is a .proc, .hello. So any file name which starts with dot becomes hidden in Linux. ls command will not show by default. However, if you say ls-la, it will show you everything. A means show all, everything. But if you just say ls-l, it will not show. So same way you can use the find command and then you can say dot star. So a file name which starts with dot and after that followed by any number of letters, digits. So that is become a finding of a hidden files. And type F means you find a regular file. You could have given directory. Directory can also be hidden. So that way you can use different format of find to do different tasks. Thank you all for watching this video, and I will have some more videos with respect to find. I hope you will enjoy all this video. You have a nice time. Bye. Hello and welcome friend. In this tutorial we will try to look at some of the other options with respect to find. In the past we have seen how to find a file with respect to name or extension. Now we will try to look for file with some particular permissions. Now let's suppose we want to find a file which doesn't have all the read, write and execute permissions being set. Now if you are unsure about how to set up permissions, I would request you to go and look at the chapter called chmod and chown and permissions in my tutorial before you proceed with this permissions thing. So let's see, in the current working directory I want to find a file of type F, which is a regular file as we know from the last tutorial, and whose permissions are not 0777. For this tutorial you assume that this 0 doesn't exist, so it's a read, write, execute for user, group and others. Now this 0 is also needed. This 0 means a permissions with respect to sticky bit. When you are setting up the sticky bit, this is with respect to that permissions. If you don't give, so it means just a regular permissions. There is no concept of sticky bit in this. So this is user, group, others. But when you put 0 or maybe 1, so the sticky bit permission is 1, 0, 2 or 4. So we can either set a sticky bit with this first field, or we can set some of the fields like resident set size memory. We can set a program in such a way that if the bit is set, that program will always stay in memory. It will not be swapped out to the disk. Okay, so that's a different story, but we'll look at the find. So what we are saying is find a file which is a regular file, which means it's not a directory and the permission is not 777. So we have so many files. Now if I say okay, don't give the permissions 777, what if the permissions actually 77? We have only few files which has a permissions of 777. Let's see whatever it has given. Let's try to verify so that we are sure that we are looking at the right data. This will give us a confidence that okay, we are running the right command. So you see here, this is the right command. It has all the permissions as we were listing. However, if you look at this file, which was a result of the previous command, not 777. So if you look at dot file name, it should not have all the permissions. If you see here, it's not 7. So this is read and write, which is 4 plus 2 is 6, and this is 4 4. So this is 6 4 4, not 777. So that's why it was giving not permissions, was output was this. So it was giving this. When we say permissions 777, I have only few of this. Now when you give a permission 777, which means you're making read, write and executable for everyone. So you should be knowing what you are doing. It might become a security issue if you blindly just give 777. So make sure you understand what you are trying to do. So that's a permission. Now there is a shorthand notations that if I want to find out files which has a sticky bit set, so I could say minus perm and /u equals to s. What this means is find a file in root directory, which is not just my local directory but in the entire root, whose permissions user has a sticky bit set. /u stands for user. Now since I will be running in the /root command, so it needs access. It will be denied access to many of the files and folders with lots of errors. So I will give a sudo. Sudo is a special program which makes my program to run as a super user. Now I'll give a password So if you see here, some of the programs has a sticky bit set. Now let's see what is that. If I see here ping, you see here it has a sticky bit set. So that's about sticky bits permissions, finding the sticky bits permissions. Now let's suppose I want to find all the files which has a read only permissions for the user. I could have given like this, find all files which has only read only permissions, and if you see here, all those files are read only permissions. By the way, proc file system, you might have seen a lot of contents with respect to proc. Proc is the kernel data structure mounted in so that you can look at all the different kinds of variables, debug informations, devices, PIDs from the kernel. It is just a user space mapped as a user space so that a user can access, of course based on some permissions, user can access the informations from the Linux kernel. Okay, so we were looking at find all files in root which has the permissions for user read only. So if you see here, just to verify, and we can see here ls-l. So you see here it has only a read and write permissions. So user has a read permissions, others don't have the permissions. So /u means user has a read permissions. Now if I want to find all files for everyone, it should be execute permissions. So /a means all, /u means user. So if I say here, then you see these files everyone should have a execute permission. So let's see this one L, and then if you look here, you see everyone has execute permission. So one more thing, if there is a directory, you should see that if there is a directory and if you say ls-l on a directory, it will actually show the contents, ls-l contents of that directory. It will not show you the property of the directory itself. So if you say ls-ld, it will show you the property of this directory itself. So in the past, in previous example, when we were saying ls-l, it was actually showing me the contents inside that directory, but it will not show about this directory itself. So if I use ls-ld, it will show me this directory itself. So that's a very important point to note, that when you want to look at the property of a directory itself rather than inside the contents, then you use ls-ld. Now if you see here, this property for the read, write, execute permissions we were trying to look. So you see that this is a directory, it has a read, write, execute for the users, and for others it's not here. So that's what it was saying, for /a for all users it has execute permissions. So it will try to find out files like that. Now if I want to find a file for some particular user, like let's suppose there is a user called John and I want to see all the files which belongs to John. So what I will give find the path where I want to find out with the minus username John, and it will try to find all the files which belongs to user John. So the command is like this. I am giving sudo because I might not have the access to run my command under entire /home. So that's the reason I use super user. So whenever you don't have an access, and if you have the rights for super user, try to run it as a super user, but always ensure when you are running the command, what kind of command you are running, whether it's a destructive command, that rm or something like that. So you have to be very careful while executing those commands. Now let's suppose I want to find a file belonging to user Shakil and the name has the extension cpp. So I could say find dot or any path name. Let's suppose that my path is Shakil bssg, and then I would say minus user Shakil and minus iname or name, and I could say star.cpp. So now if I give here, all these files belongs to Shakil and this is a cpp file. So this is like this user. So whenever you want to find a file belonging to any particular user, you would say -user. So thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye. Hello and welcome friends. In this tutorial we will try to look at some of the more options with respect to find. So let's suppose we want to find a file which have been modified in the last 10 days. So the command to do that is find followed by some options with respect to path. So we will try to find in the entire root file system the file which were modified in the last 10 days. Now since I'm running it as a user Shakil, I will have to put a sudo because otherwise it will fail for some of the directories while navigating due to permissions. So if you see here, all these files was modified in the last 10 days. Now how do we verify that? Let me terminate this because it will take some time to execute this command. So I already have some output which I can verify. Now this is the date, and if I look at the date for these files, so this was modified on February 16th 1653, and this is February 27th 145. So this was modified in the last 10 days back. Same thing, I can look for some other files. Maybe I can look for this file. This was, so this is a directory, so I would say ls1sld. This was modified on February 16th. Today's date is February 27th. Now if I want to find a file which was accessed in the last 10 days, so m time is modified time. Now access times a time in the last 10 days, I would give /. So similarly you can check the timestamp for the file which was accessed in the last 10 days. Now if you see here, for this particular file, it still says the date. This is the created or the modified time. It is not the access time. Access time by default you will not be able to see like that. You will have to write some of your more commands with respect to access. So the system maintains the access time in the file system itself. So if you see here, this file was created on June, modified 29. However, this file was accessed in the last 10 days. So this access time we can gauge with the option -a time, access time. Now how if I want to find all files which were modified in the last 10 to 100 days, between 10 to 100 days, so then we could give in a command like find /-m time, and we will give now +10 instead of 10. When we say +10, so greater than equals to 10, and -m time less than 100. So I would give like this. If you see here, all those files, they were of age between 10 to 100 days. Now find, if I want to find the file whose status has been changed maybe 10 minutes back, there is an option called cmin. So c is change of status, so we could say like this, sudo find /-c minute and 10. Now c is a change of status, and in minutes, 10 minutes back file whose status got changed. So proc is of course will be changing because it represents the kernel data structure, but we will look for file which is present in the disk. So this is varlock kernel is present on the disk. So let's see, ls-l and this file. Now date is February 27th 138 148. You see, this has been changed exactly 10 minutes back. Now if I want to see, instead of change of status, if I want to see files which were modified maybe 20 minutes back, I could have given 20, and less than 20 I could give minus. So file which was modified 20 minutes back, I could give like this. Now for access it is a minute, so I could give -20 -60. File which was accessed in the last 20 minutes is a minute. So a is for access, m is for modified, and c is for change of status. Now let's suppose if I want to find all files in the system which is of size 50 meg, I would say sudo find, then followed by path, and then minus size is an option, and I could give 50M. So all these files would be of 50 meg. So if I see here ls-l, so you see this is 50 meg. So ls-l will give you in terms of byte, and it's hard to read, so you could say ls-lh. H is a human readable format, and it will tell you the exact size 50 meg. This is of size 50 meg. Now remember, this will not be exactly, if you take 50 megs, so 50 megs is usually like 50 into 1024 into 1024. It will not be exactly this many bytes. There might be slightly difference with respect to bytes, but see, if you see here ls-l, so this is 519 and 50 meg is 5242. So the file size is still slightly few kbs less than 50 meg, but it will round up and show you files which are around 50 meg. So it does a rounding up also. There's an algorithm for rounding up how much it can round. So you have to read the manual of find command, or read the info, or maybe just read the source code. You'll see that. Okay, so this is about find file which are of 50 meg size. Now what if we say file should be greater than 50 meg and minus size less than 100 meg, or maybe 200 meg, whatever, 100 meg. So these are the size of files which are more than 50 meg but less than 100 meg. Now sometimes we get a query or something like remove all the empty files or find all the empty files, or you have a problem in the system and there are a lot of empty files, and it will slow down the performance because the file system has to navigate to find certain files. It has to look for all the matching files. So you can see all these files. So these files would be empty files. So if I ls-l and look at the size, if you see the size, the file is 0 size. So to find the empty file, you say minus type f, which is the regular file, and it is empty. Now the other way to find a empty size is also with the size. Empty means the size is 0. You could also give like this. Now if you want to find an empty directory instead of file, you can say d and you can say empty. So these are all empty directories. So if you look here, actually this is a directory. So if you look with ls-ld, it will tell you that this is a directory, not a file. And then if you go inside this, you will see that there is nothing listed. ls-la, nothing. So this is empty. Now suppose you want to find a file and do some other kind of operations, like your own script, running some of your own script. So you could say something like find dot minus exec, which means execute. So find everything, which is find dot means find all files and folders. Then minus exec means execute ls-ld, and then you have to give a bracket like this, brace backslash dot. This you have to remember that you have to give like this, and this is your command you want to execute. So it will tell you. So if you see here, by default whenever you say find dot, it will not tell you the read write permissions and the various fields of the ls the way ls represents or shows. It just tells you the file name. So but if you want to see the permissions and everything with respect to ls, the way ls shows, modified date, permissions, how many bytes are there, date and timestamp, so you could run ls-ld and say minus exec. It will show you like this. If you want to delete those files, you could say rm-fr, but be careful before running this command. It will delete the file. Be careful, very careful. Don't run that command rm-fr without knowing what you are doing. Okay, now let's suppose I want to find all the file with the name star.cpp, which has extension star.cpp. I could say cpp and first run like this, so it will display. Now there is this sarg command. What xarg will do is take all the output of this command and pipe it to xarg. Xarg will take one argument at a time, one file name at a time, and it will display ls-l or any command you can type here. but I would say ls minus l. I don't want to type a rm or something because people might mistakenly run it, so that's why I'm just running ls minus l. So what this command will do is find dot, which means find all files and folders in the current directory, minus iname, which means whose name has start.cpp, which means whose extension has cpp, which has any name. Find all those kind of files and then pipe to xarg. And what xarg will do is take, like, suppose first file name and display ls minus l, then it will take second file name, display ls minus l, third file name, displays ls minus l, and this is the fixed format which you have to give. So this is the way you will run through find. So we have find all the files, so this way you will run find and see the size, permissions, the owner, modified date, and everything, whatever. So thank you all for watching this video, and I hope to see you in my next video. You have a nice day. Bye. Hello and welcome, friend. In this tutorial we will try to look at grep command. Grep stands for global regular expression and printing. So this command is one of the most important command. The reason being, you can do any kind of expression search, regular expression search for any files and folders. So sometimes, being a developer or a programmer, you need to search for certain codes in certain directories, and you might not be aware where exactly those code lies. So if you remember some of the keywords, like let's suppose there is a wait for single object in Windows API, so you want to see where exactly that has been used. You can say grep minus ri wait for single object, and in all the paths you can try to search. So it's a very powerful command and particularly helpful for the programmers. Nevertheless, it's also helpful for the system administrator and all kind of folks. Now, grep is useful, and at the same time it has lot of variants, so it makes it slightly complicated because most of the people, they don't understand the difference between egrep, fgrep, and rgrep. So the grep is just a regular grep, the first command which I have mentioned, and then there are variants for the grep, which is egrep, which is also equivalent to grep minus e. Egrep is regular expressions grep, it's an extended grep. Fgrep is same as grep minus f, it's a fixed string grep, fixed string. And rgrep is for reverse grep, it's search in the reverse order. So same thing I have explained in this slide. Now if you see egrep and fgrep, they were used earlier as a separate binary, but nowadays it's always advisable to use grep minus e for egrep and grep minus f for fgrep rather than using a separate binary. So that's the right way to use grep. So you should use just the grep command, and when you want to use extended grep, you give pass the option minus e, and when you use the fixed string grep, you pass the option minus f, as in here. So this is the right way to use. Don't use this and this. These are deprecated and they are only present for backward compatibility. Now some of the common grep commands. So typically when you want to search something, so what you would say is grep the search string. Depending upon the context which we will cover, you can give this in double quotes or you cannot give in double quotes. So let's suppose this is just a one fixed string with no space, you can omit this double quote. But suppose this string has a space or something special which needs to be expanded by the shell, it's advisable to give the double quotes. And this is the file name or the path where exactly you want to search. So this, you could have given file1 slash test.txt here. So the syntax is grep, then the search pattern, and the file where you want to find, search. Now this is just for searching one file. Suppose you have folders, subfolders, and you want to search anywhere and you don't know the name of the file. So then in that case you give a star. Star means search everywhere, and minus r means you do it recursive search. In the sense, it will descend to a folder, then subfolder and subsequent subfolders, and it will try to find in all the places. So grep minus r. So remember, this is minus r. This is not the reverse r. So the other one which we saw here is r grep. So this is not the same as r. So it's recursive grep. So grep minus r, Shakil, and followed by star. Now let's suppose I want to grep everything except Shakil, which is the reverse operation I want to do. Then it's a V. V means exclude Shakil. So it will show me all the lines not containing Shakil. But there is another option I. I is case insensitive. So it will not show me Shakil, or it will not show me maybe S capital and then Shakil, or maybe any of these letters in capital letter, or a mixture of capital and small, and it will show me, not show me. So grep minus r means show me all the files having the string Shakil. Grep minus r, V means exclude, show me all the files not having Shakil. So this is the reverse. This and these are the reverse. Here I have also added I, case insensitive operation. Now in a file, if you want to count how many match you have, like let's suppose you have taken a PID file in, maybe you have run a script, and as part of a script you ran ps-ef, got all the PIDs, and you want to know with the same PID how many processes are running with the same PID, to know the number of instances of something. So in those cases, you can do something like grep minus c. So you will say the count, and what this will do is, okay, if a process is already running, then there is at least one count, and then you will not spawn another process. So in those circumstances, you will use this. So basically count the number of occurrence of the pattern Shakil in the file1.txt. Now if I want to do extended grep, which is egrep or grep minus e, which is the right options to pass, and you would say, okay, grep search for the keyword Shakil or Adele in the file1.txt. So it will find either Shakil or Adele or both of them occurring in the file1.txt, and this is a regular expression. E is for regular expression. So thank you all for watching this video, and I will go through the practical details of these commands and many other commands in the subsequent video. I hope you enjoyed this video and you have a nice day. Bye.
Hello and welcome friend. In this tutorial we will try to look at some of the examples which we have discussed in our last grep tutorial. So the general sequence for writing a grep command is like grep followed by any of your search patterns. So let's suppose I want to search Shakil and a file name. So this is the generic syntax. So I will try to get Shakil wherever is present in the file test.txt. So if you see here, I have 3 matching lines and each of the line has a keyword Shakil. By default it matches the case sensitive way, in the sense the case of Shakil here and here in the search pattern should match. If I want to ignore the case, which means I can have a S with a capital or any K or any of the combinations in this capital and small, which is case insensitive, I have to give the keyword I. So now if I run here, you see I have some extra contents. This ranch belongs to Shakil. Here S is capital. This now displays with the minus I option. But if we look here, it has not displayed that line because it was searching in a case sensitive way. So to make it case insensitive, it's minus I. Now if you follow one more thing, it tells me which all are the matching patterns in a file. It doesn't tells me the file name, because by default when you say file name, this means these patterns are belonging to this file test.txt. However, let's suppose if I want to search grep minus I Shakil in all files and folders, I will have to give the keyword star. Now when I give the keyword star, if you see here, when it found some pattern,
it has also given me the corresponding file name. The reason for this corresponding file name is, if they don't give a file name, how do I know this pattern is coming from which file? So if it is a multiple files or a wildcard, it will give you the file name. If it is just a single file name, it will ignore the file name. That is the default behavior of grep, because a single file name doesn't make sense, because that pattern is found in that file only. Now if I want to find all files and folders in a recursive way, in the sense you descend to a directory and go further into the subdirectory and keep on doing until you have done all the path, then the option is -r, which is recursive option. So you search for the keyword. So here you search for the keyword Shakil in all files and folders. You do it in a recursive way and case insensitive. So this is the way it works, and it will tell you all the file name, where it matches along with the path, and what is the matching content, matching line. So this line has the keyword Shakil, so that's the way it matches. Now if I want a reverse operation, in the sense, give me all the contents which doesn't match Shakil, so I can give V and I can see like this, but there are a lot of contents, so let me just try this with one file, because there are so many files, it's difficult to go through that. So let me do this for one file. So now what I'm saying is, search for everything in a file test.txt, but don't search the keyword Shakil. So don't give me the pattern Shakil, but give me everything. This is the reverse of what we were doing now. So you see here, hi there, what's up dude, these are the contents. These contents doesn't have Shakil. So if I look at my file test.txt, it has some of the contents. So this line doesn't have the keyword Shakil, this doesn't have Shakil, this has a Shakil. So this line would get printed, this line would get printed, this will not print, this will not print, then this line would get printed, this will not print, this will be printed, and this will not print. So that's the reason we got like this. So when we say okay, in this file try to search everything which doesn't have Shakil. So -v is the reverse of the normal operation of grep. There is this utility called as nm. Now this nm is for looking at the symbols for a particular executable file. So I have a executable file a.out, which is just kind of a hello world, just prints some statements, that's all. Now if I want to look at all the symbols, now what are symbols in executable? Symbols are those data structures which are part of a function or a variables or static variables, those kind of things. Those are part of a P file or a executable file which gets loaded at runtime. So those are symbols. There are a lot other definitions and details about symbols which we will not cover, but I just wanted to demonstrate, so I'm just trying to tell you about symbols. So nm will list out all the symbols present in this file a.out, which is a binary file which after running produces this binary file I just got by having a small cpp file, just a small cpp file, nothing else, hello world cpp file kind of thing. Now if you see here nm a.out, if I say nm followed by binary name, it will list out all the symbols. Now in this all the symbols, there are some symbols which are undefined. That means this needs to be fulfilled. So either someone has to provide the definition for this, or you have to write your own definition for this, otherwise this binary will not run. So undefined might come at runtime from some other DLLs, but many times your own symbol is undefined, and in a executable you want to find out what all the symbols are undefined or how many symbols are present, something like that you can do. So let me try to do something like this. I would like to find all the symbols which are present but ignore anything which is undefined. So what I will do is I will say u. So nm out will list out all the symbols like this, whatever I got,
and then it will say okay, grep minus v, ignore this kind of signal. So I did a ignore. So now you remember, you see minus u, all the symbols which are undefined is not present anymore. Now inside the symbols, I don't care about this loading address. This is the address, relative address, where my program would load all these symbols. So I want to ignore this. So if you see here, it is in a tabular format. So address, the type of a symbol, and then the actual symbol name. So I want to extract the actual symbol name. So what I will do is I will pass to awk, and in the awk I have to give a option, or you can just directly print the column, third column. So let me just print the third column only. So I would say print $3, and this will print me all the symbols. Now in all the symbols, what I want to do is, some of the symbols might be repeated. So what I will do is I will first sort it. So it will sort in a default dictionary way. So they will sort it, and then I will say pipe to unique. So it will just list me the unique symbol. So these are the symbols present in my system. So if I run a command like this, I can extract all the symbols present in my executable. So this is the kind of useful thing you will do in grep. So there are so many usefulness, but kind of it will be useful. So you can just take out any output, do some massaging on that output, and run grep, and then do some further processing, and you make it some logical conclusion. You can reach to some logical conclusion, or output would be some good thing. So these are the kind of examples you will do in real life. Now let's suppose, so I will try to give you one more example with respect to the grep. Suppose you want to grep for the speed of your Ethernet. So you need to have a tool called eth tool, and to run this tool you need to have a sudo. If you don't have eth tool on Ubuntu, just running eth tool, it will tell you the apt-get command to install. So most probably it will be apt-get install or sudo apt-get install eth tool. So it will give you the options. You can search also online or Google how to install eth tool, and in eth tool you will give your interface name. So interface name is your network card interface name. Network card, when it gets detected, there is a logical name, and that logical name needs to be given. By default Ubuntu right now it gives ENS33. Older systems and CentOS and those kind of things, they gives ETH0, some gives ETH1 also. So for ENS33 it will list out the details, and I have to give the password because when I'm running in a sudo. Now there is this field called speed, so I wanted to get that, so I would say pipe to grep speed. So now if you see here, earlier what we were doing is we used to run the grep command with some such pattern in some file, right? Now this time what I am doing is, this is a stream of data, this is not file. So when you run sudo eth tool, it outputs a bunch of data onto a screen. So when it outputs a bunch of data onto a screen, that's basically a stream of data. That's not part of any file. So those kind of contents also you can pipe to a grep, and grep will try to do some operations based on whatever syntax you have provided, whatever options you have provided. So here if I just say grep, it will tell me the speed. Now if you see here, it has not given me the speed. The reason S is capital. So what I will do is I will search for -i, which is search in a case insensitive way for the keyword speed in the string this. Now if I search here, it will tell me my Ethernet speed is 1000 MB, so which is basically gigabit Ethernet. I have a gigabit Ethernet card. So each tool is the tool to look for the network informations with respect to physical device information of your network card. And how do you get ENS33? That's a simple thing. You can run with ifconfig. When you run with ifconfig will tell you the device name, the virtual device name for your Ethernet card. There are other ways to do that, but that's the easy way. If you see here ETH0, so you run your command against ETH0 rather than ENS33.
So these are some of the practical examples of grep. So grep can not only find in a file, but you can pass a stream of data, pipe a stream of data to grep, and it can still find out. Thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye. Hello and welcome, friend. In the last tutorial we have looked at some of the grep example. So in this tutorial also we will try to cover some of the examples. So let me repeat the last tutorial example again. So if I want to search the keyword Shakil in all the files, I will give like this. And we mentioned that when there are no file name present, like it's a wildcard, so for the users to see clearly which file has the matching pattern, it outputs the file name followed by colon and then your matching content. Now suppose because of any reason, you being a user, you don't want this file name, suppose, then the option is H, and H will hide the file name from the matching line. Let's suppose you're trying to find the keyword Shakil in a file called test.txt, and whether you give H or not for a single file, it doesn't matter, so we'll not give. So you'll see there is a keyword Shakil A, and that also matches because it just matched Shakil. What if I want that it should match exact word, not like Shakil A? So Shakil A is not an exact match, so I want those kind of things. So what I will give is the option W, and W will match an exact word. Now if you see here, it has not matched Shakil A, Shakila. So how does it consider something as a word? What if there is Shakil followed by some special character? So by default the definition of the word is characters followed by some of the numeric digits. So you have to look into the grep man page to get the exact information about what a word is. But by default, if you can consider from a layman's perspective, word is something like considering like letters and digits and some characters, some extra characters. So now let's suppose if I want to find two strings and either first string is present or second string is present or both of them is present, then display me something. It's display the search pattern. So for that we will use extended grep, and we have shown you in the previous slide, in the previous video, that for extended grep you use an option -e. Alternatively you can use -egrep, but egrep is like no more used because it's only present for backward compatibility. So the right thing is to use -e option with the grep. And let's suppose you want to find the keyword Shakil or Adil in a file called file.txt or test.txt. So if you see here, it doesn't found anything. Now let me try to find it in file test.txt, suppose. So if you see here, it has found this. Now see here, the keyword Shakil is matched in this line, Shakil is matched, in this line Adil is matched, and here Shakila is matched. So if you want to have either Shakil or Adil or both, you can have this. Let's suppose we modify the file test.txt and we have another line called hi, hello, okay, hello Shakil and Adil, and if I have both of these, that will also match. So hello Shakil and Adil, so it will match either the keyword Shakil or Adil or both of them being present. So that is what extended grep is. If you don't give this option as extended grep, what will happen is it will not take pipeline as a search pattern, as a form of manipulating as a OR group, but it will take this entire thing as a search pattern. So let's try to do that. Let's suppose you are not using extended grep, a regular grep. What will happen? In regular grep, it has not found anything. The reason, now it will take this entire thing as one single search pattern, and of course there is no such pattern as this, so it will fail. So that's why we use the extended grep. So the other example I wanted to show you for extended grep is when you're looking at the CPU information. So there's a file system called proc file system. So if you want to see some CPU information, you can say proc CPU info. So you will cat proc CPU info. Proc is a file system from the kernel. Kernel mounts this file system as a read-only file system, and it displays all the data structures with respect to kernel. So it will tell you the CPU information. You see I have processor 0, which is my first processor. It will tell you the processor details, how many megahertz the processor has, and what all the instruction sets it supports, kind of instruction sets. And if you have more than one processor, it will list out your processor 0, then followed by 1 and 2 and whatnot. So for a VM, a virtual machine to run, there is a flag called VMX, and VMX stands for virtual machine extension, which needs to be set in the BIOS. So let's suppose I want to search that flag as an instruction set here. This is my instruction set which this processor supports. So what I have to do is I will say grep -e, which is a extended grep, which means it supports the regular expression, and then within the bracket I would say search for VMX or SVM. SVM is for secure virtual machine. That is again another form of instructions, and I would say make it color. So I will give an option minus color equals to always, and I will search in proc CPU info file system. So basically what does it means is that search for VMX or SVM, and you say color equals to always, minus color equals to always, and here you will see this. Now if you see here, VMX is colored here slightly. You might not be able to see it very clearly, but if you compare from this text to this text, you will see there is a slight color. So depending upon your terminal color, right now I am using blue color, so it's not very much prominent, but in some other terminal it will be very much better. So if you see here in my Mac, from the Mac, if I go to my Ubuntu device and if I run the same command, so it will be very much prominent. So I would say grep -e and then VMX pipe to SVM minus color equals to always proc CPU info. So I missed something, I think, here. So let me check. Grep -e and then VMX and then okay, so this is always. So if you see here, it has not found any such a string VMX because I am not searching case insensitive, so this instruction set is in small letter. Now if you see here, it is very clearly marked in red. So whatever the color informations you give, it depends upon your terminal color also, so ignore for that, but this is the colored content. So this way you can search for any instruction sets in a CPU info, that whether this instruction sets is there or not. So you can search for VMX, SVM. So this the reason I am showing you with this example is these are kind of practical example which you will come across in your company. Your manager will say, okay, tell me whether your processor supports VMX instruction sets for virtual machine or not. So how will you do that? So how will you say VMX is supported or SVM is supported, or maybe a combination of 3, 4 or AES is supported? You'll have to run scripts like this, make a scripts based on commands like that. Now let's see, let's try to run the basic command again. So we were searching for, like, let's say Shakil, and in the test.txt, let's run it again because I wanted to show you another example. Now there are 4 lines which got mashed and there are 4 Shakil. So 1, 2, 3, 4 Shakil, not this one Shakil. So let's suppose if I want to just see the count of how many Shakil is present rather than all the other informations, so I would say C,
and C will give you a count of how many it's present. What if I want to see it in a case insensitive way? Minus I, and it will give you one more option because there is one shekel with capital S. Now what if I want to see the line number? So if I see the line number of where exactly it matches, it will tell you the line number also like this. So by default, if you don't give an option N, which is for line number, it will just tell you where exactly what is the matching content. But since this is a single file, it doesn't display you the file name, because you know everything is part of test.txt. This string which is found is in test.txt. So but which line number, I don't know. So you have to give the option N and it will tell you which line number it belongs to. So it belongs to line 3, line 9, line 11. So that way you can find out line number. So thank you all for watching this video, and I have some more examples, and I hope to see you in my next video. You have a nice time. Bye. Hello and welcome, friend. In this tutorial we will try to look at some more examples of grep. Now let's suppose I want to search for the keyword int in all my CPP files. I would say search int star.cpp. Mind it, I'm not giving star because I don't want to search in something like text file or maybe some bin file or something like that. So what I'm saying is just search in star.cpp. So you can give a wildcard like this for a search pattern. So you see here it will tell me the file name followed by the search pattern. Now what if I just want a file name? So I don't want what exactly matches, just all the file name which matches. So you will see here that I get a list of file name. Now what if I want to ignore all the duplicate files? So there might be something which is duplicate. So what I will do is I will sort it so that it's arranged in a dictionary format, and then I could say unique, and I can find all the file of type CPP which has the keyword int inside that. So these are the kind of things you can do. Now let's suppose I want to search some word, like let's suppose I want to search proxy and doxy in my file password.txt. So what this will do is it will search either PRDOXY, so it can search PRDOXY or DOXY. So it will take any combination of this 3 letter and then this letter OXY. So you see here what it will do is it will search the keyword proxy. So proxy is present, so it will give me this line also, and then there is another user called deoxy and it will list out deoxy also. So this is the way you can do. So this is again kind of a regular expression which you can give in search for the grep. Now let's suppose if I want to grep, like there should be 4 letters in somewhere as a username in my file password.txt, then I can give my pattern search as like 0 to 9. So I would say any letter, any digit between 0 to 9, and then same thing 0 to 9. So that means 2 digit, the at least has to be 2 digit. Now if I give third one, then there has to be at least 3 digits 0 to 9, and then I can say fourth. So it's a 4 digit letter in a file password.txt. Now let's try to look at the output. So see, this is definitely 4 digit, so it will search for 4 digit, and if it is more than 4 digit it doesn't matter, but at least 4 digits, so it will show me this. It will again same here it matches this guy, not this guy, so it matches this. So now if I look at my password.txt file, it has many other contents. Like let's suppose if you look at UUCP, this doesn't have any 4-digit number, it has just a 2-digit number, so this will not come in my search pattern. So if I look at the output here, there's no UUCP. So this is the way you can search if you want to have some kind of digits and you want to say okay, there has to be 4 digits,
then you can do like this. And mind it, all the pattern searching, whatever you are doing, you can pass it to a stream also. What I meant by that is, instead of searching grep like this, let's suppose you have a stream of data. So when you say cat, so cat will do a cat of this file, which means it will through a stream, pipe it, and then you can pass it to grep. So you can alternatively do like this also. So you see, you will get the same search pattern. So you get a stream of data, pipe it to grep, and whatever pattern you want. Now when you pipe it to the grep, you don't give a file name or where exactly you want to search, because by default when you pipe it, the data is coming as a stream of strings of data to the grep command. So that's the way it works. Excuse me. Now let's suppose if I say cat password.txt and do a grep of keyword Shakil, it will grep and it will give me all the contents which is matching Shakil. Good. Now what if sometimes it happens that I would like to see the context when Shakil was appearing, what happened before that. So I wanted to see something before that, or maybe something after that. So grep has this option called -a. A means after, and you give 3 or something, 3 4. So what it means is, after the keyword Shakil, display 3 more lines. Whether it matches or doesn't matches, it doesn't matter. I wanted to see the context. So you see here, when Shakil appeared here for the first time, there is 3 more lines which got displayed, which has nothing to do with Shakil. Just whatever matches, after that display 3 more line. So this is A means after. Same thing here. This is the second match, and then 3 lines after. Similarly, if I want to see a before, I can say B and I can give 2, 3, 1, whatever. So what this means is, when Shakil is match, before that give 2 lines. So when Shakil is match, give 2 lines. So this is line 1, line 2. So line 1, line 2, and then this Shakil is match, it will trail like this and then this. You can use any combination. You can say B2, and you can always write B2 like this also. So a typical standard Unix way of doing things, you can say A3 or A3, whatever. So what this will do is, whenever the keyword Shakil is match, before that give 2 lines, and after that give 3 lines. So it will be like this. Now if you see here, whenever the keyword Shakil is match, before that give these 2 lines, and after this match give 3 more lines, 1, 2, 3. And so this is one search. Whenever the keyword Shakil is match, before that give 2 lines. So this is line 1, line 2, and then after the match give me 3 more lines. So this is now 3 more lines. So this is what it is doing. Now I have one more example for you guys. I have this file called user.txt, and it has 3 username. And then I have my usual group file in my system, which is etc group, and it has a lot of users which are present in the system, some created by me and some created by default when we install the system. So in grep there is an option called -f. Mind it, this is not capital F. Capital F is for fixed strings, and then this small f is for file. So if I want to search a pattern from a file, so this is a different one. So till now what we were doing is grep, the name of a pattern, and then file name. What if this pattern itself is coming from a file, because I might have more than one pattern? So that in that case, what I give is an option -f, and the pattern file name is this, and then from where I want to see this etc group. So what it will try to do is, it will try to go to the etc group and look in the user.txt. So whatever is present in the user.txt, it will try to match all of them. So in user.txt, if you look at my user.txt, has 3 users. So any of them, if it matches in this file, it will try to print that. So Shakil is matching in my user.txt, so it prints Shakil.
Again, this circle matches in user.txt, this matches in user.txt, this matches, this matches, this matches, this matches. So all of them matches, so it will show me user.txt in second. Same thing I can try to run against etc password file also, and it will try to say me like this. Now if you see here in etc password file, when I run against etc password file, there's no match for Shakil here, but there's a match for admin, so that's why it shows admin also. So what it means is grep for all the patterns present in this file, so the pattern will be taken from this, but search in this file. So this is the search file, but this is the pattern file, so where exactly you extract the pattern, so there should be no confusion. Thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye.
Hello and welcome, friend. In this tutorial we will try to look at what is a shell script, different part of a shell script, and how to debug a shell script. Apart from that, we will look at some of the other syntax with respect to shell script. So before I go ahead with my more generic form and different components, I wanted to show you one very basic shell script. So what is the shell script? First, shell scripts are interpreted language, in the sense it's not compiled like C or maybe other programming language like Fortran or Java. It's an interpreted language. There's no binary output. So when you write the shell script, the script is taken as it is in the shell and it's interpreted on the fly. So debugging is easier, in the sense you don't need to go through the process of compilation, but it will be slightly slower as compared to your programming language like C, wherein you have an executable getting created when you compile a program. The first line, it says bin bash. It tells me exactly which shell I need to execute, and bin is the path where bash lies. Instead of bin bash, I could have given bin ksh. It would have executed in k shell, or maybe I could have given csh. And make sure that the path is right. If your csh is in /user, then you have to give /user bin csh, not bin esh. So wherever your shell lies. And how do you know where your shell lies? You could just say which shell and it would tell you the shell. So if you can say which and say bash, so it will tell you where your bash lies. So this will be interpreted and set up as your shell variable. When you say okay bin bash, then you are telling to the system use your shell as a bash. So this entire program will execute in the context of bash shell rather than some other shell. Then this is a command ls-l, and then this is echo. This is all you need, or maybe you don't need anything. You can just have a blank. So this is the simplest shell script you can have. Just one line echo something. You could just comment out with the hash. Hash is used for comment, and this becomes a very small shell script. Now we will look at different parts of shell script. So of course in shell script you have different features, conditional statements, for loops, while loops, if conditions, text expressions, comparisons. So we will look into details. So first thing is same thing, bin bash. It will tell you shell. Now if you give a hash, it will tell you this is a comment and this line will not execute, so no execution. So same thing, if it's a hash or starting with multiple hash, it doesn't matter. Wherever the hash starts, after that everything becomes a comment. The way you write a function is you give a name of a function and then opening and closing bracket, and then you starting and closing brace. You don't give a return type for a function, and you don't give an input parameter to a function, and inside the function you can do anything. Also to remember, in shell script the variables are all falling in a global scope, everything. So even if you write something inside this function, some variable you declare, some variable num equals to 23, suppose equals to 35 or 34, this will be global variable, so you can access it from here also as well. Then if you want to know the name of a script, by default $0 will be the name of the script name. So script name is whatever you take it as a script, like you could say script name 1, or it's not necessary to say script name. And the first command line argument which you provide will be taken as $1. The next command line argument would be taken as $2, and so on and so forth. When you call a function, you just tell the function name and it will call the function. If you want to provide some parameter to a function name, you can give the param1, param2 like this. To whatever you want to give. So this is a way you can give a parameter, and then inside the function you will have $1, $2 as the function name. So now I'm echoing the name of the script. So this particular script, whichever the name I have given is generic shell script.sh1, it will tell you this name. Now I can output the same thing, $script, but there is a brace here. So what is the use of this brace? So when you use dollar, what it will do is it will take the name of a variable and interpret it. It says, okay, interpret this variable, and it will substitute the value of the variable. So it will does the variable. Now let's suppose if you are saying like this, you don't give a brace in this case. How does this dollar knows that this is a variable or a script name up to name is a variable? It has no way to know whether this entire word is a variable. So if you want to put some characters immediately after dollar, after your variable name, then you have to enclose your variable name with a brace. Then dollar knows that starting brace and ending brace is the name of your variable. Here there is no characters after the end of the variable name. It's just a double quote which echoes no, so you don't need to give brace, but otherwise you have to give brace. And then here the first argument, command line argument, which I have taken as $1, this comes from the system, and this is my variable name. I could name it as any variable, so this will come as command line argument variable 1, and I could have made this as variable 2, another variable 2. Now I declare one local variable num equals to 23, and I compare. This is if statement. Don't worry about the if statement and how it works. We will cover this in the if section, or you can directly go to the if section and read about if statement in shell script. So it compares if $number, the value of this number equals to 22, then it will print echo this is a match. And if it works fine, then we exit the script with exit value 0, and exit value 0 means success. Usually that's the nomenclature, that's the way you should do that. Everyone follows the same rule, and anything apart from 0 is error or some kind of erroneous conditions. So this is the generic script which you write. So let's quickly run this script. If I run this shell script, you see here first argument is nothing, and second argument is also nothing, and 23 matches. The number we were doing the match for num equals to 23, that says a match, and it tells you the name of the script. And here you see that it tells you the name of the script up to sh, and then immediately after my variable name, after my script name, I used brace use. Had I not given the brace here, this entire thing would have been treated as the variable name, and then this variable doesn't exist. It would have given me an error. So that's why you use brace. Now first argument is nothing. Second, let's try to give the argument. I say arg1 is my first argument, arg2 is my first argument, second argument. So now this time see, for earlier it was there was blank. Now this time it says arg1 is my first argument, arg2 is my second argument. Good. Let's suppose I want to debug this shell script. So there's an option called -x, and if you run the shell script in -x bin bash x, it will debug. So what I mean by that is if you run it, you see it will tell you each operation the shell script is trying to do. Even when it was trying to do a numeric comparison for 23 equals to 23, it will show you what exactly it was doing. And sometimes it might be very useful in taking out, oh, what might be the error. Something like you might be comparing 35 with 23 or some kind of things, and you were expecting some different result, so you might very well see using this. So -x option is very helpful in debugging. Now there is another options. Let's suppose I have an error in my shell script. Suppose I don't give this, and now this is a syntax error. So this is a syntax error in shell script. If I run this shell script, what will happen is it will try to run, because shell script are interpreted language, so it will try execution, and whenever it sees a error, it will just says okay error, and it might do something bad. So if you want to verify that your script is not having error, you can put an option -n, and what -n will do is it will tell you okay your script has a syntax error, it will run it. So you might do a dry run, so before you can put it here, or you might say just like this, you can execute your script using bash command also without saying anything. Like earlier we were just running the script name, so that is one way of running the script. The other way you can run is you can say bash, it will shell -n, which means check what is the error. So it will tell you you have a syntax error, so -n is like a dry run, so that will also be helpful. So you can use -n or -x, -n for dry run, -x for making and debugging and running a script. It will tell you all the options, all the commands, all the conditional statements it is executing. So that's all for this video, and I would like to see you in the next video. I hope you like this video. Thanks. Hello and welcome, friend. In this tutorial we will try to look at providing command line arguments to bash shell script, and we will also look at how to write a function in shell script. Now there are certain nomenclatures and things which I would like to tell you. First thing is there is a keyword called $hash. This $hash gives you the total number of arguments which is being passed. So by default, if you don't know how many arguments, like there are 3 arguments passed to your script or 4 arguments, you can use this $hash to gauge exactly how many arguments were passed. This is similar to argc, which you might have done in C programming. Many of you might have done in C programming like this, int main, and then you might have said int argc comma char star argv. So this argc is like $hash. So this is same as $hash has total number of arguments. And then $0 by default is the name of the script itself which gets passed. Then this is the same thing, $0, but there is a binary called base name, and what base name will do is it will remove the leading path and gives you just the name of the script. So I'm just running to make it more beautiful. I will show you. Then the first argument which you want to process would be in a variable called $1, then second would be in $2, third would be in $3. And then when you want to take the total number of arguments altogether, it would be $* and $@. So this is $* $@. There is a slight difference between $* and $@, which we will cover in this video, but in the next example. But for the time being, you can say that this is almost similar or they are same, but in fact there is a small difference. So let's run this program and see. So if I run this program, command line arguments.sh, and let's suppose I give the argument, first argument as arg1, then second is arg2, third is arg3, and I could give more, but if I'm not processing more, it will not do anything with those arguments. So now see how many total number of arguments I have given. The total number of argument is 4, and mind it, this total number of argument is just the number of arguments. It doesn't count the name of the script as a count for the total number of arguments. Even though $0 will give me this, but total number of argument is whatever I provided. So this is 1 2 3 4, so total 4. And then the script name is this, which is of course this is the way I'm running the script. Now if you see here, this is $0. So now if you see $0, it gives the path also. This is the way I'm running, so it's giving me the relative path also along with the script name $0. So when I pass the base name, I will get rid of this, and I have given the base name, so it gives me a clean file name like this, which is my script name. And then first argument is arg1, which is this. Okay, of course I think I wrote the wrong statement. It should be second argument, so let me modify this quickly. So first argument is this, then this is a second argument, and of course this is a third argument. Okay, So second argument is arg2, which we have given. Third argument is arg3. Fourth, it has not displayed because we are not displaying anything with respect to fourth argument. And if you see here, total number of arguments which we have given as dollar at the rate, it gives arg1, arg2, arg3, which is the total number of arguments. And total number of arguments together, it again gives the same thing. So dollar at the rate and dollar star gives the same thing in this example, but there's a difference which we will look. So let me go through the program again so that you can correlate and you can understand. So dollar hash is total number of arguments, just the arguments 1 2 3 4 whatever. $0 will be the script name. Base name $0 will remove the leading path and it will just give you the script name without any path name. The first argument which you want to process is $1, which you might be interested in most of the time in your script. Second is $2, $3, so on and so forth. If you want to take all the arguments all together, then that will be represented as either dollar at the rate or dollar star, even though there is a difference between them. So far so good. Let us run a second program. So this is my second program, and in the second program I wanted to show you the difference between dollar star and dollar at the rate. So like I said, normally there's no difference, but if you put it inside the double quotes, then there's a difference between these. So I will say like this. So let me write a statement: dollar at the rate is equals to dollar hash. I'm sorry, it's is equals to dollar star, but dollar at the rate is not equals to dollar star, like this. So they are not equal. Now we will see why. So what happens is, when you take a dollar star within a double quote, what it will do is it will take the entire argument and just make it as one argument. And what I meant by that is I will display with the help of this program. And when I take dollar at the rate and I provide multiple arguments like arg1, arg2, arg3, it will treat each of them as multiple items. So which means if I give 4 arguments, I will iterate 4 times. So first time I will say argument 1, then argument 2, then argument 3, then argument 4. Same argument, if I pass it here in this case, dollar star, it will take arg1, arg2, arg3 as just one argument, and I will just in one single shot it will give me all the arguments. So let's run this program and give the argument arg1, arg2, arg3. Now if you see here, the first program just gave me arg1, arg2, arg3. It has treated this entire thing as one single argument. Now if I want to do some processing with each individual arguments, I might not be able to do that because this is treated as one argument. So I might have to again split it based on the space. I might have to split this to generate individual arguments. But in case of dollar at the rate, it will always give me individual arguments. So here I iterated 3 times. Here I iterated only once and it just gave me all the arguments lumped together, separated by space. So that is the difference between arg1 and a dollar star and dollar at the rate. So I wanted to show you the program once again. It's a simple for loop. You iterate dollar star and dollar star is whatever arguments you provide. And mind it, this difference comes only when you enclose in double quotes. If you don't enclose in double quotes, they will be same. Now let's try to look at how we write function in shell script. The way to write a function in a shell script is a function name followed by bracket. In bracket, you don't need to pass any argument, so no parameters allowed here. So no parameters. You don't need to pass any parameters. And how we pass the parameters we will look. And no return type. So you don't give any return type. So it's very simple. Just opening and closing brace, name of the function, and then bracket. So and then whatever you want to do that. So when the shell script gets processed, it will process the function, but it will not do anything. It will just see the function is there, but it will not call. So to call the function, you have to call it explicitly. So the shell script starts processing line 1, line 2, line 3, line 4, 5, 6. It doesn't do anything. At line 9, it sees the echo and it will print this line echo. Now at line 10, it sees the function df_func and it knows that this is a function, not a command. So it goes and calls this function. Now this way, when you call dev_sda, this is the parameter which we can pass to the function. If you don't pass this parameter, it doesn't matter, right? You can have a function without any argument. So this is an argument parameter you can pass to the function, and whatever argument you pass to the function, that is again received as $1. The first one is $1, the second one is $2, the third one is $3, so on. So the way shell script takes argument, the function also takes the argument as $1, $2, $3 in the same way. So now if I pass dev sda1 here, it will receive sda. So if I pass this entire shell script as some argument as maybe PID number or something, that PID number will not go as $1 here. It might be reflected as $1 here, but here this $1 would be dev sda. This is my argument. So let's run this. So this program will call a function, pass the disk name which is dev sda, and that will be hold down into a variable disk drive, and then it will say df minus cache. Df is for disk free, and it will print in a human readable format, and it will show me what is my disk usage. So let's run this. So see, this program displays the free disk space, and it runs df minus cache, and it tells me how much my free disk space is available. Simple. So that's the way to write a function. Now I have one more program to demonstrate to you guys. Let's suppose I want to pass two arguments. So same thing, everything remains the same, slightly different, but remains the same. So this is a function. So the shell script comes, it tries to interpret everything. It will not do anything till line 12. Then it will print line 14, which is free disk space. Then it will see that, okay, this time I'm passing from command line also two arguments. Those two arguments goes in disk1, disk2, and those arguments in turn I am passing to a function. I could have passed any other variable also here. In this disk1 and disk2, instead of that, I could pass any functions, I mean to say any argument, not necessarily that the one I received from command line I need to pass. I could have passed some calculations which has been done as part of this script, or maybe some expressions, or maybe some integer variable I could pass to diff functions. Now it passed to a diff functions. The bottom line is this is the name of a function, and this is the two parameters. When it receives here, the first parameter I declare one variable, and I took the first argument as $1, which will go here. So this, when this is passed, it will be passed as $1. When this is passed, it will be passed as $2. And then I print one echo statement, and I say df minus cache my first disk dev sda1 or sda2 or sda3, whatever stb, and then I do the same thing with second disk. So when I run this program, so if you see here, if I run my second program and I give two parameters that I have to find out the free space for dev sda. Sda is one disk, and then dev sdb would be secondary. I don't have a secondary disk, but let's run. So when I gave with two parameters, it will try to find the disk with first disk, which is dev sda, and it gave me some data. For second disk, it couldn't find the dev sdb device because I don't have that device. If someone is having that device, it will display the data. Or if someone has plugged in the USB device and they have only one hard disk and USB is detected as dev sdb, in that case it will tell you the data about the USB device. So let me show you the program again. I will give all this program for download. So this is very simple, and this is the way you write functions in shell. Thank you for watching my video, and I hope to see you in next video. You have a nice time. Bye. Hello and welcome, friend. In this tutorial we will try to look at while loop. So as you all know, while loop is a control flow statement which allows the code to be executed as long as some given condition is true or satisfied. This while loop is similar to other programming language like you might have seen in C, C++, Pascal or anything, but the syntax is slightly different. So we'll look at a very generic while loop conditions. So in general, in shell script, particularly in bash, the syntax for a while loop would look like this. It's a while, then there is a space, and then there is a bracket, and inside the bracket you can put some conditions. Make sure when you put a bracket there should be a space here and there should be a space here. So if there is no space at the starting and the bracket and some conditions, it will give you a syntax error. That's the syntax bash follows. So you have to give space inside the bracket. Now you have followed by do and done. So this do and done is like opening brace and closing brace in other language. In bash it's do and done. And then you have a list of commands or statements or expressions you want to evaluate, n number of things. You can have some if condition also here. So since I am demonstrating only while loop, so I am just not making it too complex for things to be understandable. So let's try to look at one of the example for while loop. So we will go through this. So I have a script already written, which is a very simple script. So bin bash, which will tell it execute in bash shell, and I have a variable count equals to 0, and I would say something like while, and then there is a space here, and you see there is a space here, it is must. So I would say count less than 5, so it will be true because the value of count is 0 initially, so count is less than 5, so this is true. So this expression is true, which means this condition becomes true. It will go inside the while loop, execute hello there, then it will sleep for 1 second, and then it will increment the count by 1. So now the count becomes 1. Now next time it comes here and it checks 1, the value of count becomes 1, dollar count is 1, so 1 less than 5, which is again true. It will execute this statement again, sleep for 1 second, and then this becomes 2. This will go on and do it for 5 times. So let's run this program. So if I run this now, you see it will print hello there, pausing for 1 second each time for 5 times, and it exited. So after 5 times the statement is no more true. So that's very simple. Now there's another shortcut, like sometimes you want to do some infinite loop. I don't know in which conditions, but maybe you might need to run some infinite loop, run some monitoring script continuously. In that case, instead of giving some conditions, you could have given some number like 1. This is very similar again to C. Like in C also you can say while and in bracket. So there it's a different bracket, not this angle bracket but a curved bracket. Here it's just angle bracket, and say 1 and some commands. So we'll look for the example of the second form. It will be like this. So here you can say instead of while, and you could have said like 1, like this, and it will print always forever hello there and sleep on, because this conditions 1 is always true, so it will never fall off, so it will always print. So let's run this while t2, and then you see 1 time, 2 time, 3, 4, 5, 6, and it will continuously do that. So one more thing, the reason I am giving here sleep is because if you don't give sleep, it will execute very fast and probably it will consume too much CPU. So whenever you have some kind of a statement and you want to do it infinite or something, probably it's a good idea to give some amount of sleep. If you don't give sleep, it's very fast, but it will exhaust your CPU, and maybe other processes will be starved of CPU resources. So let's see, without sleep, see it's printing very fast. And if you want to see how much count, you can also see the count also. So this is one form of while loop wherein it is always true. Now there's one more form of while loop, which is a shorthand notation, which is while and colon. This is also true, so you can say this also, but I will put a sleep because it will make my PC slow and my recording would be bad, so I will say while true. Now if I run this, it will be still the same, so it will keep on printing every 1 second infinitely. It keeps on printing hello there, it will never stop. So this is another short form, which is while and question. And in bash there is one more called as there is one more which is called as true. So there is a shorthand notation called as true. You can run that way also. So when you run again, it's the same thing, and it will keep on continuously printing. So we have seen several forms. So this is the general form here, like while and conditions, do, some commands. So it could be commands and expressions, arithmetic calculations, or it could even be a if statement or maybe some kind of a break. Then this is which is one, which is always true. So this is condition is always true for infinite loop. Same thing you can do with another notation which is while true, and then you can also this with while colon. So one more thing I would like to see, it's not only necessary to write a shell script in a bash file, right? You have a file like here, bash shell script file I have written. I could have done literally the same thing from the command prompt. So you could say something like while true, then say do ls minus l sleep 1 done. So every 1 second it will come and it will print out the contents of ls, it will execute ls and it will do. And same thing. So, and if you want to repeat the previous command, you have to just go and with up and down arrow you can select the previous command, and instead of do ls minus l, you could have sent something like do pwd, which is present working directory, and every 1 second it would print your working directory. So when you are like good in shell script and more proficient, probably for small work you might not want to do it into a script file, rather you can do run the entire thing from a command prompt. So mind it, if you run it from a command prompt, the entire script looks like in one single line, which is okay. And the other thing which you follow is automatically when you run, this is preceded by each command, each operator kind of things is preceded by a semicolon. So which is end of a statement, not exactly operator. Each end of a statement is preceded by a semicolon automatically. And if you see here corresponding, this is the same thing here. So while condition, and then this is one statement, and this do will be preceded by a semicolon and then followed by n number of commands, which each of them will be followed by one semicolon and then done at the end. So you will see like this. So don't worry about that. You can just write also while true do, and then say ps minus ef pipe to grep some abc. Whether those processes are found or not found, it doesn't matter, it's just a demonstration. Sleep 1 or 2, and then you can say done, and it will keep on printing. This is an infinite loop, so I will terminate with control C. Now if I want to repeat the same command with some other conditions, I can do with up and down arrow. So I could select my previous commands, and instead of grep abc, I could have said grep abc1, and it would run, the condition would become true. So that's all for while loop, and I will see you in the next conditional statement. Thank you very much for watching this video. Hello and welcome friend. In this tutorial we will try to look at another conditional statement which is called until. So until is very similar to while, but in while loop what we were doing is we were putting conditions and it used to execute when the condition is true. Until does the reverse of while. In this sense, until will execute as long as the condition is false. So until some conditions, which is if it is false, then it will go inside this loop and execute command 1, 2 and maybe a number of commands. If this condition is true, it will not execute any of this and it comes false out of the loop. This do and done is again similar to flower brace, open flower brace and end flower brace in some other programming language. Now let's quickly look into example for this until loop. So I have this example code until t1, and here I by default there is a keyword in bash shell false. So until false, false is a keyword which is always false, so it will always execute because until executes when the condition is false, and it prints hi there, sleep for 1 second and keep on doing. So let's run this code. If I run this code, this will keep on executing as long as the conditions becomes true, but it will never becomes true because we have hard coded the value as false. So this will fall into an infinite loop. Now I have another example called as t2. Now if you see in T2 I'm not giving extension. You don't need to have extension in shell script. We only give extensions for our benefit to identify what all scripts we have to differentiate between script and executable and other files, but otherwise it's not needed. Now let's open another program until T2. Here I have put one condition. So like you have a count variable which is set to 3 and you have until and some dollar count less than equals to 0. So LE is less than and equal to. So if you say 3 is less than equals to 0, which is false because 3 is greater than 0. So less than equals to 0 is false. So if this is false, it will go and execute this statement. So it will print hi there and it will decrement the value of count by 1. So 3 becomes 2. The value of count becomes 2. It will print that value and it will sleep for 1 second. And then again go and check the conditions. Now the count value becomes 2, so it will say 2 less than 0 less than equals to 0, and which is false, so it will execute this. Then it becomes 1 less than equals to 0, which is again false, again execute, and this count value becomes 0. Once it becomes 0 and it sleeps and comes back and checks the conditions, its count is 0, so 0 is less than and equals to 0, which is true. So in case of true, it will not execute, so it bails out and just done. So if I run this program, so it will print 3 times. So hi there, and then the value of count. Hi there, the value of count is 2. After from 3 decreased to 2, and then again it print hi there 1. Hi there, the value of count becomes 0, and then once the condition becomes true, 0 less than equals to 0, so it will not execute because until follows the reverse of while and it bails out. So in the similar way you can do until from the command prompt, as we have seen. For the while loop you could have said until maybe false and say do ls minus l, or maybe pwd, because ls will just cover my entire screen, you will not be able to see anything, and say done. Now see, every 1 second it will keep on printing in an infinite loop because I have put until false. In case of while loop, it should be until true. So until true, until executes only when the condition is false. So that's all for this video, and I hope to see you in another video. Thank you very much for watching this video. You have a nice time. Hello and welcome, friend. In this lecture we will try to look at for loop. So as the name suggests, for is used for looping and based on certain initial conditions and then based on certain end conditions. So initially it will be initialized to some value and then there will be some end conditions and followed by incremental values. So that's the generic way we use for loop in other language like C and Pascal. Now in bash also we use the same construct for loop, but we also have several other shorthand notations for doing some other stuff in bash. So I will guide you through one of the examples for each of them, and you should be able to remember at least some of them and use it in your programming construct. So let's go through the first example. Let's suppose if we have a known list of items through which we want to iterate, we can give like this: for var is a variable here, local variable. So and then list of item is this. So each time it will, first var will have a value of 1, then next time it will get a value of 2, 3, and it will echo each time. So for loop also starts with do and ends with done, and within this do and done you can write any statements. So there might be multiple lines of statements or some binaries you want to run. So do and done is like flower base, if you can take it as analogous to flower base in other language like C. So you can iterate. Now let's run this program and see the output. So you see it gets the value 1 2 3 4 5 and ABCD. So you can have the string and numbers together, it really doesn't differentiate. Then we have another program for the for loop, and in this case suppose I want to iterate from number 1 to 25. I can do it like this. I can give it in flower brace with a dot dot. Make sure there is no space here. This will if you give a space here, sorry I modified wrongly. So what I mean to say is There should not be any space here. This is wrong. So now if you run this, it will iterate 25 times, and each time it will say welcome one time, welcome two times, three times. So each time the value of I will get one of the values excuse me, as part of the for loop. So let's run this second example, for loop test 2, and you see here it starts with welcome one times, two times, three times, goes up to 25. So this is our second example. Now let's go to the third example. In third example, we do the same thing, but it goes from 0 to 10, which is similar to our previous example. But this time, instead of increment by 1, which is default, we increment by 2. So it will be printing like 0, then 2, then 4, 6, and so on up to 10. So let's run this program. If I run this, so it says 0, 2, 4, 6 up to 10. So this is our third construct for loop. Then let's go for our fourth one. The fourth one is similar, but instead of using flower brace, there's a dollar sign, and then there's a keyword. There's a bash shell word keywords, SEQ, sequence. So it's read as for I in dollar sequence, and it goes like this. It goes from 0 to 20. Remember, this is not 0 to 2 and increment by 20. This is reverse. It is for sequence from 0 to 20, and each time it increments by 2. So this will again say the same thing, welcome 0 times, 2 times, 4 times, 6 times. So this is another construct which we will use. So let's run this. So it's like this, 0, 2, 4, 6. That is another way. Then we have another way. After this we will go for the fifth one, and in the fifth one is more generic. So this is how you see it in C, another programming language, but the only thing is you have to give it in double bracket like this, and then there should be a space here. Mind it, if there is no space here, Bash might complain. Bash is little finicky about space, so at least this space and this space should be there. So you should remember about that. So for C equals to 1, C less than equals to 5, C++. What it means is the initial value C can be any variable. You don't need to declare a variable in Bash, as we already know and we have seen, and it will less than 5. So from 1 to 5, so it will 1, 2, 3, 4, 5. It will print welcome that many times. So welcome 1 times, welcome 2 times, and like that. So 1, 2, 3, 4, 5. So good. Now this is the most generic one, so I would like you to see it again and remember it. Probably make a note. So whenever you write a for loop, you can write like this. If you don't remember everything, at least you can use one construct to write a for loop always, and then later on you can learn something more and try to remember the other construct shorthand notation. But if you don't remember anything, there are so many things, you can just remember at least this one, which will help. Now we go to the next example, 6. 6 is just a generic form, I mean to say, sorry, a special form for infinite loop. So if you remove the conditions, and if you remove the initialize value and increment, it will become an infinite loop. So it's no brainer. 6 is same as 5, but it's just an infinite loop. So I don't know when you will need this, but in case if you need it, so it will run. I'll say Control C just to stop it. So this is 6. Now there is one more form like this. So this is again a sequence, but in backtick. The earlier one was we used to have a dollar in front and the bracket, but this is again for I in sequence. So it will say start from sequence 1, goes up to sequence 10. By default it's an increment of 1 and print $I. So if you run this, it will again do a for loop and it will print from 1 to 10. So this is really comes handy. This for loop will come handy because if you remember many of these things, you should be able to reproduce files very quickly. I will give you one quick example which you can run from the shell. Let's suppose I have a file test.txt and it has a content. This is my file, suppose. Now this is a test.txt file and you are writing some automated test cases and you are trying to do some performance testing and you want to duplicate this file maybe 100 of times. you can just quickly say for I in backtick sequence 1 to 100, and then say do copy this text file to text underscore code $i .txt, and probably you can just enclose in double quotes in case if there is file name contains any space or something like that, and then done. And once you look, you will have this test file duplicated, and each one has a number in after the file name before the extension, and you have duplicated. Now you can submit this test file from 1 to 100 in your automations for some performance testing. So if you remember this for loop, it will come handy. So this is also one of the handy way of writing for loop, and you might be needing it. So try to practice some of these for loops, and if you don't remember or forgot, it looks like mind-boggling, but at least try to learn one generic form which is very similar to C format, so you can try to memorize that one. Thank you all for watching this video, and I hope to see you in the next video. Hello and welcome, friend. In this tutorial we will try to look at if statement. If statements are statements, conditional statements, which evaluates certain conditions, and if those conditions are true, it will execute some statements. So if you look here, it's a generic form if, and then followed by space, and then there is a bracket, and inside the bracket you can give some expressions which will evaluate. Make sure after bracket you have a space at the beginning, and before you close the bracket, there is a space at the end, and then followed by statements. The same thing can be written in a slightly compact way if conditional expression, and instead of then being in a new line here, you could write in a same line, but you have to terminate with semicolon before you go ahead and write then it would complete. So if conditional expression semicolon then, and then statement 1 statement 2, so this first form and the second form are equivalent. It's just two different notations. Then there are other things like if you have a conditions, you can execute some statement, and then if those conditions are false, in case of false, you can execute some other statement. And then this is another form in which you have some expressions which will be evaluated. Based on the evaluations, whether it's true or false, it will execute this. Now let's suppose if this is false, then it will go ahead and try to execute this condition and see whether evaluate this condition and see whether it is true or not. If this condition is true, then it will execute this, otherwise it will come back. And this is more generic form which has all the things. So if statement, it will evaluate expressions, and if it is true, then it will execute statement 1 2 3 up to n number of times. If this expression is false, it will not go here, it will jump to elif condition. So mind it, this is like else if, but in bash it's used as a shorthand notation called elif, but exactly the usage is of else if in other programming language. So this is like else if, but you cannot write else if, you have to write elif. Now elif conditions, and if this condition is true, it will go here and execute this statement. If this condition is false, then it will go to the else statement and execute the else statement. Also you will notice that if is followed by then, which is like opening brace, and then if is closed by 5. So if is always closed by 5 in all the statements. You will see if is closed by 5, even in our basic generic form, if then and then 5. So you have to remember this. Now here if you see here, after elif there is a then, but in else there is no then, so you have to make a note of that. So let's quickly go through some of the example for this, and then we'll come back and do some more. So this is my generic form. I have a variable count which is set to value 32, and here I have put one expression which is count greater than 0. So if you see here 32, this dollar count will evaluate to 32. So 32 is greater than 0, which is true. If this is true, it will print count is positive, and it will print my working directory and pwd. So here for printing I'm using echo, and then there is another statement called printf. Printf was not available in earlier bash shell, it was added very recently, but now it is there, so you can use it. It is much better than echo in the sense that in between the statement like this string literals you can put \n, very similar to what you do in C printf. In echo you cannot write \n inside this, you have to have split it into multiple echo statement. In printf you can write it in one statement. So that's about printf, but we are doing about if statement. So if this is true, so this is true and it will print count is positive. Let's run this. So here it is saying count is positive, and it's also printing my working directory which we have given as a statement. So we have given count is positive and we are printing $pwd. Pwd is an environment variable and it picks the value from environment variable pwd, present working directory, and whatever my present working directory is, it displays. So far so good. Let's look at another example. This example is same as what we saw in the previous. The only thing is there is else part here. Now earlier we were evaluating this as true. Now this time let's make it as a false. So count I set it to -3. So -3 is greater than 0. It's not true. -3 is less than 0. So this statement expression is false. So it will say count is negative. So let's run this. T2 count is negative. So good. Now let's run another example, go through another example and see. So this is my another example. Here I have count equals to 3 and the condition I have is $count greater than 0. -3 greater than 0, then count is positive. So this is false because -3 is not greater than 0, it's less than 0. So it will come back and evaluate the elif part. Now in elif part it evaluates that $count which is -3. -3 is less than -2. Of course -3 is less than -2, so it would print count is less than -2. So if we run this program, it will say count is less than -2. We have already run by mistake in the previously, so it's giving that. Now let's look at one more example. Now let's suppose we are demonstrating all the three parts here: if, elif and else part. So now I set the value of count to -1. So -1 is greater than 0. Wrong. So it will not evaluate and it will not go here. Now -1 is less than -2, which is again false because -1 is greater than -2. So it will not go here. So then what will happen is it will fall back and execute this statement. So it says count lies between 0 and -1. So let's run this program and it says there is another statement here which we will do, and this is OR conditions. If we want to add multiple conditions together, then we can do OR statements. So if we have expression 1 and we want to say whether expression 1 or expression 2, if one of them is true, then evaluate the statement. So we have this OR statement or conditions, and then similarly we have AND conditions. So let's try to go through the examples between those two quickly. So we have this T5. Now I have a vegetation name fruit. Now this time I am using strings rather than numbers, just for the sake of doing. There's no reason, but I'm just to be different. Now fruit name is orange, so I have two variable, vegetation and fruit name. Now I'm checking $vegetation name. So if you see in my previous example, when we were doing a comparison for numbers in shell script, you have to do comparison with less than, equals to, greater than, those kind of things. But in string you have to say equals to. So mind it, it's equal to, not equals to equals to. So actually this is a comparison. This equals I have put here is actually like equals to equals to. So it's not an assignment operator, it's a comparison operator. So in shell script, equals to means comparison operator inside the if statement, conditional expression, not anywhere else. So even Equals to will work as part of backward compatibility, but this is more generic. So if when you do a comparison, you have to say equals to rather than equals to, but equals to will also work. So what it means here is it will say dollar vegetation, which is a name fruit. So if fruit equals to fruit, which is true, so this will evaluate to true. So there is no point in going to OR statement, because whether this is false or true, it will still execute. And so this is true, so it will skip the remaining part and we will say it is fruit. So let's run this program. So this is conditions T5 and this is a fruit. Now let's go to another example, and this time we are using AND. So same thing, everything remains the same. We just say AND fruit name equals to banana. So let's see, vegetation name fruit is true, but fruit name whatever is there, this will evaluate to orange. So it will say orange equals to banana. So when it is AND, it will evaluate expression 1 as well as expression 2, but here expression 1 is true, which is okay, and then expression 2 becomes false because fruit name is orange. Orange equals to banana is false. So if this is true and this is false, this is false, so it will not go here, it will print this statement, it's something else. So if we run this program, it will print me it's something else. So that's how you combine multiple expressions to make it. And just to demonstrate that you can use equals to, you can run the same program and you will have the same output. You will have the same output. So you can use either equals to or equals to. So shell knows that inside the shell, if you have if conditions, and as part of if conditions you have some expressions, that expressions equals to is actually equals to, it's not an assignment. So that's all for this video. In the next video we will try to look at some of the file handling operations with respect to if conditions, like we have to check if a file is a block device, character device, a special device, and whether it's a regular file or it's not a regular file. We will try to handle some of those expressions with respect to if statement. So thank you for watching this video, and I hope to see you in the next video. You have a nice day. Bye bye. Hello and welcome, friend. In this tutorial we will try to look at some of the if conditions with respect to finding if a file is a block device, character device, is it a regular file, or if it exists. So there are different ways you can do that, and I will show you one of the ways. So if you see here, the syntax is like this. If you say -p and then followed by a file name, and it will return you true if it's a block file. So B is for block file. Then similarly there is a character file C, and then D is for directory. We have already gone through directory, and block file and character file I will cover very shortly in this tutorial. Then E is for file exist. When we say file exist, then it means just its existence, whether it's a block file. So -e will return true for a block file or a character file as well. So and -e will return true for directory as well. So if you say -e, that means it just exists. It doesn't give you a granularity whether it's a block file, directory file, or if it's a regular file. -f is for regular file, or maybe -r is for read file. So you can go through all the options by looking at the man test. So let's quickly run through some of the example which I have created for you guys to look into this block file and character file. So we will look for example 1. I have this test file, test1.sh, and before I go ahead and explain you, I have created some file here. So if you look here, I have created one file which is called sdcd1, and it is B, which is a block device. Then sdcdp1, which is a character file, and I will show you how to create those two. And then it's a regular file, messages.log, and if you see here hyphen, which means it's just a regular file. You could create one file with touch 123 or something, and it will be created as a regular file. And then this zebra underscore log is a directory you could create with mkdir. We have already seen those things. Now let me demonstrate this program to you guys. So I have a variable file name, and in this file name I have put the first string as messages, and I check if minus e file name. So minus e means the file exists. It doesn't care what kind of file is it. So it will say echo file exist, which is true. It will say like that. And then it's a minus f file name. So same variable I will use with minus f. Minus f means it's a regular file, and of course my messages.log is a regular file, so it will say dollar file exist and is a regular file. Now let's suppose if instead of dollar file name, if I could have used block device file name, then it would have not fall into this category. It would have not said it's a regular file. It would have just come out of this conditions, because this condition would not have been true. And similarly, I have reset this file name variable to another variable sdcd1, which is my block device. And if I run through this and say if this is a block device file name, it will say file is a block device name. And then I have similarly done for character device, which is at line number 21. So all these are my line numbers, so don't worry, in the VI editor I have set the line number. So at line 21 it says I set to a character device and check if it's a character device. So actually this should be RC character device, and says it's a character device file. And then lastly I have this zebra underscore log, which is my directory, and if I test with minus t, and it will tell you it's a directory. Mind it, even if for a directory, if I test with minus e, it will return that it's still a file, because directories are also treated as a file. So let me quickly run this program and see the output. So if you see here, messages.log exist, of course it exists. So it could have said this existing thing for zebra.log. You could have used any combination, but I'm just using one of them. And then messages.log exist and is a regular file. So if you see here messages.log, it's a regular file. You could create this file with the cat command, touch command, or maybe with a VI editor, or maybe any editor. Then file name is a block device name. So I have not given a dollar. So let's quickly modify this so it could print the right thing. So it should be here dollar. So it should give the variable name correctly. And here dollar, and this is also dollar. Okay, so let's run this program once again. So first I will do ls minus l, so that I have the listing of all the files and folders, and run this. So now if you see here, it says sdcd1 is a block device file. So if you see here sdcd1, it is followed by it is having starting with b, which is a block device file. It's a special file. And then this is a character file sdcdp1, this is a character file c, and then zebralog is a directory, which we have seen, zebralog. So this is the way you can test whether a file is present or not. So where exactly you will use this kind of things? Let's suppose you are trying to upgrade from MySQL to MariaDB, and this upgrade will happen only once. Each time you update the system, you might not be doing that. So how do you know whether you have already upgraded from MySQL to MariaDB? So first time when you do upgrade, you might test for a file in some temporary folder, or maybe in some predefined location, and if those file doesn't exist, then you can go ahead and do the upgrade. Next time when there is a subsequent upgrade for a new software, you will test for that file. If that file exists, you will not do that. So that file could be regular file, or depending upon the use case, you could have different kind of files. The other block device and character device you could use to test for presence of some device, like if you insert your USB device, that will be treated as a block device. So you can test whether your USB device is inserted or not. What is the kind of device it is present. Now a quick overview, even though block device and character device should not be a part of bash shell scripting, because it requires some other knowledge with respect to kernel file system, but I will quickly try to guide you guys. In Linux and Unix kind of operating system, everything is a device and everything is a file. So they do all kind of operations treating everything as a file. So if you have a pen drive, and pen drive like a USB stick or maybe a hard drive, they're treated as a block device. So when we say block device, a block device reads from the kernel in terms of blocks, certain number of bytes at a time. It will not read one character at a time. It will treat maybe 512 character as a block or 1024 as a block, and it will try to read as many blocks as possible in subsequent chunks. The other advantage of block device is, in block device, when you read the data, you can go back and forth and you can peek into the data. The opposite is character device. If you take mouse and keyboard which are connected to the system, those are treated as a character device. In case of character device, you cannot peek inside the data. Whatever data you have received, you have received. You can receive one character at a time, but you cannot go ahead and peek inside the data. Okay, you cannot go back. What was my last data? You might have to do some kind of a buffering. So block device are faster and character device are slower because it's received character by character. In block device, you can go back and forth in the data. In character device, you cannot. You can just receive serial data one byte at a time. So let's quickly go through how you can create a block device and a character device. So I will demonstrate, and I already have a PPT for that. So this is my PPT. So this is a command called mknode and followed by node name. So you will give any node name. Most of the time the device files are present in /dev folder, but you could give any name anywhere. And then followed by B stands for block device, and then major number and minor number. Major number and minor number are a device identifier, and there has to be a combination of major number and minor number has to be unique. So what it means is that there might be conflict if you assign, like in my example 4,3, but since it's your system and it's no one else might be using it, you can use it. But if you want to allocate major number, minor number, you have to look into kernel documentation, or you might have to allocate dynamically by querying if the device doesn't exist. For me, I know for sure it doesn't exist. Probably it might be okay for you guys also. And then the command, similar command is for character device. The only thing is B is replaced by C, and it means it's a character device. So let's try to quickly go through this example and create this. So I have this SDCDP1, so I could say mknode, and then I could say maybe my node block underscore block. I will just to identify it's a block device, nothing else. And I could say 5,6. So 5 space 6, not comma. And mind it, when you create mknode, you need to do sudo. If you are not a root user, you have to do sudo because it requires a special privilege. And if you see here, my block device is created and there is the letter B here. It's not like hyphen, it's a B, block device. And you see for block device there is no size. For regular file you will see the size, the number of bytes it's present in a file. For block device it's a major number and the minor number, same major number minor number which we have given here, 5,6. Now with a similar command, let's create a character file, and this is, I will just say char, and you could give anything, 5,7. Now if you see here my char character device here, it's a C, and the device major number minor number is 5,C. So this is the way you can create major number and minor number for any character device or block device, and you can create that. For knowing this major number minor number, because now I cannot create another block device with the same 5,6, I might have to have a combination, and I cannot exhaust that combination. So if you look, there are tons of block device and character device in /dev. So let's quickly go through and I will show you. And if you say ls-l, you will see there are tons of character device. Your terminal type are also character device, if you can notice. And then if you scroll up, you will have other block devices, lot of devices. You see, this is a loopback device which is used for mounting some disk and ISO files. And you see huge page size is a directory, and there is a character device. So you will see a lot of block device and character device. You see lots of block devices here. And there might be dev SDA, which is your hard drive, and there might be secondary disk, dev SDB. Those also might be treated as block device. So this is about block device. Now let's look into the test condition. In the test condition, we have checked about the file, block device, regular file. Now what if there is an output from a command and we are taking into a variable and check whether that we receive some commands or not. So there are two things which you can do. One is -n with string, whatever the string you got, and it will return true if the string is non-zero, and -z means if the string is 0. In fact, you could have done with just -n to say if it is non-zero, then that means it's a 0, something like that, if else conditions. But then there is two test statements which you can use. So let's quickly go through that example. So I have another example, test2, and here I have one string called hi there, which is non-empty, means it has some data, and then other string2, which is blank. Now if I run with -n, the first string, so remember n is true if the length of the string is non-zero. So of course this is non-zero, so it will say the length of the string is non-zero, it will not fall here. Now z means comparison if the string is 0. So if I say z with string 2, which is of course length 0, it will tell me the string length is 0. So if you run this program test2, you see in the first case it says the string of the length is non-zero because it's non-zero, and the second case the string length is 0. Now this we were testing with string 2, which is length 0. Now what if I make this to string 1? So if I say string 1 here, now you see here string 1 is non-zero, so right, so it will fall here, it will not say the length of the string is 0. So you see length of the string is non-zero because string 1 is non-zero. So this is the way you can do comparison with respect to string. And remember, when you are doing string handling, it's always better to do a quote within a double quote, and you put your conditions like this. So there are many other options like -n, -z, and with respect to file also, like we have looked like -b for block device. So if you want to refer to the complete man page, you can say man test, and you will have those kind of test expressions. So you will have, you see I was demonstrating this -z if the length of the string is 0, if the length of the string is non-zero. So you can have all kind of things, -b if it's a block file, character file. So you can say man test and you can refer to all the manuals. One more example lastly I would like to show before I close this session. Just one example, nothing else. So there is a command called id, and id will give you an identifier. Each user in the system has a unique identifier. There might be same identifier for two different users, but it's generally not recommended, but you can do that. But usually all users will have a unique identifier. Now with identifier, if you run this command id, it will give you certain details like your uid, group id, and groups, which groups you belongs to, blah blah blah. If you just want to do know your id number, there is an option called -u, and it will return you certain integer number. So there is this syntax, and in this syntax I will run if loop, if statement is a conditional statement, and what I do is id -u I will run, which will return 1000 or whatever the number I have, and I will take it as a value. So I will put a dollar, and there is a syntax that if you put it within this bracket, it will evaluate and put it as a comparison statement for the another statement. So it will evaluate and put it as a normal some variable, and you compare with the 0. So in system, 0 is always assigned to the root user. So if this matches 0, and you remember for shell script, equals to is actually like equals to equals to. So for comparison in shell script, the right way to do is equals to, not equals to equals to. In fact, you can do equals to, but that is not POSIX compliant. This is not POSIX compliant. Equals to is a POSIX compliant. So that's the way they made it. So if you are a super user, which means your ID is root 0, so it will say you are super user, otherwise it will say you are not a super user. This kind of script you will need, suppose you are running some script and you want to do some system changes. Maybe you are automatically partitioning some disk or finding some free space in some sensitive locations in your disk, or somewhere you don't have permissions. You can run this kind of test to check whether you have the permissions, whether you are a super user or not. You can bail out very early rather than failing at later stage. So you can check, okay, this script needs to run as a super user, so check it. So let's run this script, and if I run this script, it will say, okay, you're not a super user, your ID is 1000. Of course, that is what I'm not. Now if I run this same script with sudo, which means I will become a super user, it will say super user. So when I am super user with sudo or su, if I run su, and if I give my password, and if I run the ID, sorry, I think my super user password is not right here, but anyway, so if I say sudo id, so it will give me root. So that's all for this video, and I hope to see you in the next video. Thank you for watching. Hello and welcome, friend. In this tutorial we will try to look how we can get user input from the command line. So sometimes you might need user input. Let's suppose you're writing a script, and that script takes a backup of some data into external drive or over a network or maybe SSD drive, and you want from the user where exactly to get the backup done. So you need user input as interactive thing. So whenever you are writing some interactive shell or shell script, you need user input. So there's a command called read, and read will read any user input into some variable. I am saying num. It does not necessarily means number, it could be anything. So like we don't differentiate in shell script between numbers and strings. Depending upon the context, it will take automatically. So whatever number we have read from the input, we will just display the same number. So very simple script. Let's run this. So if I run this, it will block for the user input. You see that I'm not getting my prompt dollar back. So it blocked for the user input, and I say 1, 2, 3, or maybe 8, 9, and then I press enter. As soon as I press enter, the input is complete. So read blocks until you press the enter, and it says me that this is the input I have given. Read is a shell inbuilt command in this sense. If you say which read, it's not found. Read is nowhere present in the system. It's part of the core shell. Shell has two parts. One is a core shell, a functionality of the shell, and on top of that, we put some extra binaries like ls, awk, those kind of things are extra binary which supplements the usefulness of the shell. So if you run which awk, you'll see there is a awk present in this command. If you run ls, there is a ls present in this command, in this path. But for read, it's not there. But read is present, because if you run the command read, it will block for the user input. So it's a part of a shell inbuilt core part. Good. Let's go to the another example. If I want my shell or my read command to read only two characters, so there is an option called n minus n. You can write it either way, with n2 or -2, both ways are okay, and number. So even if you try to input more than two characters or two digits, it will unblock. So I typed 2 now, it's okay. As soon as I type 3, see, it came out. I have not pressed the enter keyword, enter from the keyboard, and still it came out, because it's already satisfied the conditions that it will read to, and it says the user input is 23. Then there is one more form, and then you can read like this. When I want to get something into an array, and if you don't know about the array, you can go ahead and read about the array, my sections about array, and then come back and read this. But for now I will explain. This is very simple. This is a variable, we read it in the same way. The only thing we say is it's an array, so we give a option -a, and whatever you type and write, it will be part of the array. And array in shell script we can access like this. This is a syntax. So you can iterate over the array using for loop, and then you can also access by index, but you have to read my array part. And then in for loop you say my array at the rate. This at the rate means you iterate over all the elements, one element at a time, and it will say the user input is $i, which would be first element, then the number input is $i, second element, third element, and so on. So let's run this program. If I run this and I input 1, 2, 5, 6, 8, 7, see, it has iterated over n number of elements whatever I have inputted. So the first input I have given is 1, second input is 2, the third is 5, the fourth is 6th, and the fifth is 7th. So this is the way you can give a user input from the command line and take it into an array as well. So if you want, you can read man bash and go to the sections, or you can search for read, keep going for the read options, and you can see that how does read performs, or is there is more options with respect to read. But I think these three options like normal read, minus n, and minus a for array, this should be sufficient for most of the work for doing or writing shell script. Thank you all for watching this video, and I hope to see you in the next one. You have a nice time. Bye bye. Hello and welcome, friend. In this tutorial we will try to look at case statement, which are similar to switch statement in programming language like C. So the syntax is very simple and very similar to other programming language. So I will quickly explain what I am doing here. So if you look into the case statement part, this is the case statement, which is a switch statement code here. So this is the only part from line number 8 to 22, and then the remaining stuff I will explain what I'm doing here. So it reads like this: case, which is a keyword, and then some variable which will be evaluated and checked as one of the conditions, as one of the case statement, and then in is a keyword, so you have to type in. Now if this my num evaluates to 1, it will fall here and it will say it's a 1. If this evaluates to 4, it will say it's a 4. And if this evaluates to some string like quit or something, it will say here. And if it evaluates to none of those, it will go to the default star and it will just say oops, it's not allowed. And the way you close this is case, and then this is ESAC. So if you read this backward, this is case. So that's the way they write a syntax. What I'm doing in this program is I'm printing a line saying echo and then enter a number between 1 to 4, and if you want to quit, type quit to exit. And then I have an infinite while loop which will never break until and unless there is some conditions or break to come out of this while loop. So this is infinite, and then I read some number from the keyboard. So read is used for reading some user input from stdin. So whatever value you put from stdin, it will go in the variable mynum, and that variable will be evaluated using case statement. It will say okay, this is 1, user has entered 1, it will go to this case. Once it goes to this case, then again it goes back in the while loop, comes again, it will repeat, and it will say okay, user inputs another, it will evaluate to suppose 4, it comes here and then it goes back because it's in infinite while loop. And then suppose the user types quit, it will fall back here and it will say break. Now when we do a break here, break will come out of the loop, while loop, so it will no more go into the while loop, it will come out of the program. Had there been some other statements after this while loop, it would have executed here. So I could have said here echo after the while loop, so it will break here and then comes back and says after the while loop. So let's quickly run this program. It says enter a number between 1 to 4. I say 1 and it prints it's a 1. I say 2 or maybe 3, it says it's a 3. I say 4, 4. If I say 100, it says oops, it's not allowed. And if I want to come out, I will say quit. And you want to quit and it comes out and it executes after my while loop. There's a statement after the while loop which we have put, so to demonstrate that okay, when it comes out of the break, it will just break the while loop, and then it will go at the bottom of the program, execute whatever statements you have, and that's the way it executed this after the while loop. So let's look at it once again. The while loop is done once the break is there for the quit, and it prints this, which means it will execute another some statements if it is there, some commands or something, and it comes out. So guys, this is very simple. Just you have to remember the keyword is case, and you enclose with ESAC, which is a reverse of case. You can read it reverse way, and minus dollar some variable in, and then you have. Also, you have to remember that when you are breaking out of the case statement, which is not a normal break but a case statement break, you have to give double semicolon. It's not one semicolon, you have to give double semicolon. That's the syntax bash follows. So hope you like this video, and I hope to see you in some other video. Thank you and for watching my bash shell scripting guide. You have a nice time. Hello and welcome, friend. In this tutorial we will try to look at some of the file handling. So file handling is one of the basic operations in any programming language where you need to have the capability to open a file and probably read line by line and maybe do some parsing with respect to splitting it into words, counting, doing any operation. So it's a very basic operation. You will find this in all kind of programming language. So we will try to do and look into some of the concepts and syntax, how to open file and parse line by line. And once you know the basic structure, you can build on top of that, adding more exotic features like replacing a line with certain things or counting certain characters or more maybe manipulating or replacing something. You can do a number of things. So but let's go through the basics first. So I have this file handling operation. So before I go ahead and open my script, I have a file called filename.txt, and it has 10 lines, and it is like this. This is line number 1. Just for the sake of displaying that it is the line number 1 2 3 4, I just mentioned those in individual lines. Now I have this first program, file handling 1. So what I'm doing is I am passing a file name. So this is one. Consider this as a command, cat file name. So what exactly cat file name will do? It will cat and show the contents of the file. But that's not what we want. We don't want to see the entire file together. What we want is take a line by line and see the file, not just one dump, one big string outputted onto std out. So first we do a cat, and then we will do a pipe. So pipe has a feature of passing the output of one command to another command. We have already seen in pipes and redirections. So it will pipe and it will pass to while loop. And this is a syntax for while loop and read and line. This is some variable. You could have something like instead of line, you could say pine or line number or whatever. And then when it passed to a while, and this while loop will read line by line. So read, you remember we have seen the command read. Read reads a user input from a terminal stdin, and it will read by default as long as it receives a new line. If it doesn't receive a new line, it will keep on reading. There's an option in read wherein you can give n number, like maybe 20 character, 30 character. By default reads from the stdin as long as there is a new line. So each line in this file will be ended by a new line, and so when read tries to read, it will read till the new line and then echo this, and then it will keep on doing this. So if you look for my file name, you will see that this is a line number 1, and after this there is a new line which is not visible in the normal text editor, but it has to be a new line. If there is no new line, it would have continued in here. So this line would have printed here, this is line number 2, instead of going to a new line. So there is a new line which you cannot see. So that's what read does. It will read a line as long as there is a new line, and then echo that, and then go back and read again. So let's run this program and you will see file handling 1. So far so good. It is printing line by line. After each line you could do some operation here. You can do some operations. Maybe after printing a line I will say echo this is my line or something like that, some new line, or maybe some commands, anything you wish you can do that. So this is line number 1, and then this is my line. This is line number 2, this is my line. So you can do an operation. So this is one way, and I would suggest you guys, because many times you will need it. So even if you have not understand fully, you can just try to memorize at least certain parts. You can just say memorize cat file name, pipe to while read line, do echo dollar line, and then you can do some operation. It will come, trust me, it will come very handy when you try to do many kind of coding. Even if you can do this in a shell prompt rather than writing to a file, you can quickly try to see your contents. You can say cat file name pipe to while read, and instead of line I could say pine, so it doesn't matter. And while has a do and done, so do, and then you have to say echo, and you have to give this variable whatever you have given, and then done. So you're done, it will read. Now let's look into the second program which I have. So the other way to do the same thing but in a slightly different way. So first we used to do cat, but here we are not doing a cat, here we are doing a while read line. So it will try to read from std in and then echo, and this std in data will not be there because see by default there's no std in, we are not typing. So when you say less than, that means the data which we are supposed to read from std in, the way read reads, it will actually come from a file. So file name goes to the stdin, which is in turn is read by the read command. So let's execute this second program and it will have the same output, but there is a difference between program file handling 1 and file handling 2. So right now it gives the same output, but there is a difference and I will explain you in subsequent example. But for generic reading of file it will give you the same output, so it's okay. Now let's go to example 3. This is one more syntax, and here what you can do is you can say while some input file, you could give this any name, a b c input file whatever, and then equals to, you have to give a space here and some read line. So basically this guy is also doing the read line what we have seen in example 2 instead of 3, and then echo that line, and that read line instead of reading from std in, it comes from the file. So if we run this program it will be same output. So it will give the file, this is line number 1, line number 2, line number 3, and then line number 10. It displays the contents of the file name which we have, file name.txt. So we have seen these 3 examples. They are almost similar, but they are same, almost same, but they are not same. So I could say they are similar but not same. Now let's look at another example called file number 4. Now here what I'm trying to do is I'm reading a file, that's good, but at the same time what I'm trying to do is I'm trying to count how many lines are there in the file. So I will have a variable called counter, and I will say cat my file, and I will say while read line, good, and each time I read my line I will say counter, and I will say okay, counter increased by 1, and then this is done, and then I would finally print file, my file, whatever my file name has, how many lines. So I will print how many lines I have. Now let's try to run and see what is the output. So you will be surprised by seeing the output, and then I will tell you why. If I run this program, you see this says file name has 0 lines. So let's see if it says file, is it not processing this? We will try to debug this. So now if you see here, it will actually processing this line, so it will display all the lines, and this variable is also set, but at the end it says 0 line, and I will very soon demonstrate to you why it is like this. So if you see, wow, it is displaying file 1 2 3 and after 10, but it says has 0 lines instead of 10 lines. Now to debug further, let's try to print this variable counter and see what it is. So echo $counter. Now if you run this, you will see that the first, for line number 1, the counter variable does prints 1, for 2 it does prints 2, but at the end if you see here it is 10, and after that when it comes out it is 0. So it seems like the variable got reset, but it's not actually reset. So if you remember in shell script, whenever you declare any variable, that is always in a global scope. So it is not possible that it is treating here as some other variable. So there is a problem happening, and the problem what is happening is whenever a command pipes to another command, a new shell gets spawned. So this is running in two shell. First shell is this, and then new shell gets spawned, and when a new shell gets spawned, the variable gets reset. So in this program, if it runs in this shell only, this value would have been retained. But since what we are doing, we are piping to another shell, another command, and that spawns a new shell. That means this counter variable each time is no more this counter variable. each time it gets reset. That's the reason this is local variable in that perspective, in that particular shell, and it keeps on increment in the secondary cell, in the second cell which got spawned, and at the end when we come back here, which is in shell number 1. So till here what happens is like this. We will write here, so it executes till here in shell 1. So till here it is shell 1. I'm just writing, this is not some syntax or something, but just to explain you guys. So this is shell 1, and then this is all part is executing in shell 2, and then when it comes back, this is the end of the shell, and then it falls back to shell 1. So what is happening is it will treat count 2 in shell 2 as a new variable, and it will increment, but when it comes out of this, it falls back to shell 1, and this variable is lost. So that's what is happening. So how to overcome this, how to read this? So we have the other syntax for the for loop. So if you remember, always remember, whenever there is a pipe, a new shell gets spawned, and when new shell gets spawned, the variable inside that might be lost. You might try to keep it into a file to circumvent this kind of operations, but it's up to you. You can do anything. So how you solve it, it's up to you, but I will teach you the technique. Now if you see here, I have another program 6, 6.sh. Now here I'm using the other syntax. Here what I'm doing is I'm saying read line. So infinite loop, while loop, as long as there is a read line, and then it reads from stdin. So it is not spawning a new shell, it is just everything is happening within the shell, and this stdin in fact becoming file name, because the output from the file name goes to the stdin, which in turn is read line by line from a while shell. So here it's not spawning a new shell. So whatever count variable I give here, this variable will still remain intact. So it will be all executing in one shell only. So if I run file handling 6, so you will see that file handling 6 will give you 10 lines, and it will tell this is my line number 10. So I'm just opening this file again for you guys to remember and check. So this looks like a slightly better syntax than the other one, but it's up to you. When not necessary, probably you can use either of them, but if you have a problem like this, just remember it might be spawning a new shell, and that's the reason your variable is getting lost. So thank you all for watching this video, and we have seen several techniques, several ways to open a file, read line by line, and maybe after that you can do any operation. So whatever you have learned, suppose you have learned sed and awk and everything, you can apply those things into each of these lines and come out with some output, some requirement, whatever you need to accomplish. So thanks once again, and I hope to see you in the next. Hello and welcome, friend. In this tutorial we will look at the exit value which we get from shell. So first we will define what is an exit value. Exit values are a value which is written by a shell script or a executable, which can be a binary, it could be a.out kind of ELF file, or it could be any other programming language scripts like Python, or it could be TCL/TK or Perl. So in a way, exit values are a notification to the system, to the shell, that whether it has executed properly or not. So let us go through some of the example code, and then things will be clear to you. So before I go ahead and run this example, I would give you a little more background. So let me go about that. Let's see, if I run the command ls-l, it will list out all the files in this particular folder, which is good. So to check whether this command executed successfully or not, immediately after running that command, I have to give echo $?. So $? Is a way you can know the exit status, the just previous exit status. If you run some other commands and then you type echo $, that will be the exit status of that particular command, immediate command. So if you want to know the exit status of ls-l command, you have to immediately give $, and of course echo means display. You cannot give anything else, any other command, and then you want to get the value of this, otherwise you have to keep it in a variable. So let's go. This has successfully executed. Of course there was a file here and it executed. Now let's suppose I run ls with finding some particular file. So I'm expecting some file called maybe test.sh, and we know test.sh doesn't exist. So what it will say, ls minus l will say cannot access test.sh, no such file or directory. This is an error. Now if I do a echo dollar question mark, will it still be 0? Let's see. Now this is 2. So whenever there is an error, the exit status from a shell would be some value, and each value will have some kind of an indication. In this case 2 might be no such file or directory, 3 might be no read permission, something like that. So each of the exit status will tell something, but only 0 will say it is successful. So exit status 0 means successful. That is what we should follow, and anything apart from 0 is error, and that error might fall into one or the various conditions: file not found, permissions not present, path doesn't exist, user doesn't have sufficient permissions, only sudo users allowed, things like that. So there might be anything. So that's the way you can catch, and any command which is written in a proper way should always handle exit status. So in a similar way, when we are writing a shell script, we should always give a exit status. So what will happen is, when this shell executes, it will tell us whether it is executing properly or not. So if some other shell is executing this, like in a way, ls minus l, this is my shell in a terminal, and I'm executing ls minus l command, which is a binary. So this shell is catching the exit status of ls minus l command. In a similar way, this shell should catch the exit status of my shell script. So it's almost always advisable to write a shell script. Here I am doing something like ls minus l abc.txt. Now by default abc.txt is not present for the first time. If it is not present, then this will give an error. An error would be exit status apart from 0. So this exit status will not be equals to 0, right? When this is not equals to 0, this might have given exit status 0, it doesn't matter. But when I say that this does not exist and it's not equals to 0, then I say exit my program, this program with us code 4, and the way you exit is like this: exit 4. So exit and followed by code number. So that means my shell script here, this script would exit with a value 4, which is an error, and it will not proceed any further, it will not execute any of this. Now let's suppose if this file exists, then that means it's a successful case. Then dollar question mark would be 0. So 0 not equals to 0 is a false, so it will not go here. Then what it will do is, it will execute one more shell script, and that shell script will also give me some return value. And I would say if that return value not equals to 0, then I would say 5. But I know this gives me always return value 0. This is just a small shell script. I will show you this. Now when this is 0, so 0 not equals to 0 is false, it will not come here, and then it will print this. This is a normal termination, and it will exit with 0. So let's run this program first. Now if I run this program, you see here it gives me an output abc doesn't exist, because when it tries to do a ls minus l for abc.txt, it doesn't find. And if I see the output of my shell script, because I ran my script now, so output of exit status underscore t1 would be 4. This 4, my friend, has come from here, it has exited from here, because this is not found. So this gives exit value 0, 0 not equals to 0, because this is some other exit value, and my script exited with 4. Now let's suppose I create this file touchabc.txt. I created that file, and if I run my program again, so it has given a normal termination. And if I look for the exit value, so I have to say echo dollar question mark. Now this time it is 0, my script has given. So this is the normal termination, and after that my script exited with a value 0. So if you see here, this given and this has exited with 0. So this is the way you signify whether something has terminated properly or not. So within a script, you could call another script and get the exit value from that script as well, not only from the shell but from other script also. That's the reason I want to demonstrate that you can get the exit value from other shell. So this script is a small script, no brainer. It just prints echo and gives the exit value 0. So this is my secondary script which gives exit value. Now let's go back here. So simple. So this is the way you can handle exit value, and exit value should always be in a range of 0 to 225. So exit value should be in the range of 0 to 225, and exit value should not be negative. Exit value should not be negative, never. If it is negative, it can have, it will just wrap around and give some other wrong numbers. So you might have said -3, it might wrap around and maybe give 252, 253 or 3, whatever. So you should not use negative value, and it should be in the range 0 to 255. And by default the nomenclature is 0 is success. So 0 is success, but you could give anything. In case of success also you can say failure, it's up to you. But when other people are reading your script and then they see exit value status, they will think it's a successful. So if they see exit 0, they assume that it is success. Now let's suppose you make it in such a way that this you make it as 4 or maybe 3 or 2, and then this you make it as 0, which is an error. So here it's a case of error, but you are saying 0. Then some other guy who is invoking your script, he will be confused and he might take the wrong value. He might read it as wrong thing and interpret it that, oh, this is a success case, but it's a case of failure actually. So that's why it's very important that you stick to the nomenclature that 0 is success, anything apart from 0 is failure. And then how to choose a value, it's up to you. You can just declare some variable, a macro, and you can say like this: exit underscore epum, permission not allowed. You could say maybe 2, exit underscore access, e-access, and you can say 3, and this name should not be exit underscore. You could say anything, and here you could say exit dollar. In case of error you give this, and in case of success you can say exit underscore success equals to 0, and you could exit here as dollar exit underscore success. So you have to build your program in such a professional way that it looks really beautiful, understandable, and it has to be done in a right way. So this way when you try to code your program, here also you can modify. This way if you try to code a program, people will say, okay, this is a case of success, and in case of success you are using the return value from the cell as 0, which gives a right indication. Thank you all for watching this video, and I hope to see you in the next video. You have a nice day. Bye. Hello and welcome friend. In this tutorial we will look at random numbers. So random numbers are something which you will use while creating many of the shell script. Random numbers are generated by the system using a device called DevURandom, and we don't need to understand or learn how it is getting created, because there is a kernel program, kernel modules for generating the random number. It is quite complex and it involves some mathematical challenges, and this is beyond the scope of this tutorial, but at least we can demonstrate the use of the random number. So by default, if you want to generate one random number, maybe because of you want to sleep for random amount of time, or maybe you want to rename a file with some random digits, so there is a variable called random, and this is environment variable. By default it keeps generating the random number and pushing to this variable, and it should be all in capital. It's a capitalized, you cannot have random like this, so it should be all capital. So if you run here you will see a random number. So if you see here, first 23721 was generated, next time 2294, and then again you will generate it as many times you wish to, as long as there are sufficient randomness in the system. So we will generate one random number. Now let's suppose given a requirement that you need to generate a random number which is between 1 to 1000. Now if you run here, if you see here, if we generate echo dollar random, it is like 20,000 something, 23,000, probably it could be larger than this, but we want to have between 1 to 1000. So what I do is I create a for loop and I will do it 20 times. I could do it 5 times or 10 times, depends upon your use case, but I am doing 20 times. And then I'm echoing the random number, and what I have to do is to generate the random number between 1 to 1000. What I do is I do a modulo operation with 1000. So that means anything more than 1000 would be just chopped off, so it will not get created. So I will run this. Now let's try to run this program and see the output. So if you see here, all the outputs I get is less than 1000. The highest I got is probably 999, but it's less than 1000. I never get more than 1000. If I run it again it will same thing. Now if I modify it, and suppose you have a requirement in your program to sleep for a random amount of time, but that time should not be very large. It should be around 10 seconds approximately. So you cannot have a random number around 999. You cannot sleep for 999 seconds, which would be too large. So you can run like this. So sometimes you can sleep for 2 seconds, sometimes 5, sometimes 9, sometimes 8, something. And of course, when you have less than 10, so random number 10, and you generating 20 times, there will be collision, that's for sure. So you will have the same random number generated again and again if the limit is very less. Now let's suppose 100 is reasonably okay. I generated 100 less than 100 random numbers and 20 times. Now I am creating a file. Suppose I have a file, this may be fruit list, and I want to create 20 of them. So I would say for I in sequence 1 to 20, and then I say copy fruit list to fruit list underscore dollar random. So whatever random number we were having, we can substitute there. So we go there in the random region and just substitute that. And here what I would say is copy fruit list to this. I can keep it as a variable var equals to something, and I would substitute here underscore dollar var. Now what it will do, it will generate a random number, and it will then create a file, copy this file and just create a new file with that random number. So I can have a file name with random number. It should not be sequential. Now it's done, and you see here I have a fruit list 84, fruit list 62, fruit list 34. So many times if you are doing some kind of automation testing or maybe performance testing and you want to generate a file of random type, random size, those kind of things, you can use random number generator and probably use just echo random dollar, make it into different construct and serve your purpose. So this script I'm just showing that you can utilize random number in some of your programming concept. Thank you all for watching this video, and I hope to see you in the next video. You have a nice time. Bye bye. Hello and welcome, friend. So in this tutorial we will try to look at a concept called arrays. You might already be aware of the concept of arrays in other programming language. Arrays are like a variable of similar kind in which you can enter some n amount of data depending upon the size of an array. So remember, like in C or other programming language which is strictly typed, you have arrays of the similar kind of data. In shell script you can have dissimilar kind of data, in the sense like in the same array you can have numbers or strings. So depending upon the context it will interpret appropriately. So let's try to look at some of the generic ways in which arrays can be declared and how it can be accessed and manipulated. So I have a short program here. So in general, if you want to declare an array, what you have to say is declare followed by -a and then the name of an array. It could be any variable. I am putting var, you could say mvar, no var, or maybe list item, whatever you want to do. Now this declare is generally good, but it's not mandatory. The reason it is not mandatory is because as soon as you put into an index of that array any element, when you try to do that, if it is not created, it will automatically create. So let's suppose if I don't have this will still work, run and function properly, because the moment I try to put into certain index an element, this will automatically get generated. So this is not needed, but it's the right way to do that. So let's do that in a right way. Now once this variable is declared, it means at index 0 we put an element called hello, at index 1 we put an element called red, at index 2 we put an element called apple. Now I just print that. So it's a very simple way, just you access by the index, and in that index you can put any element and you can use that element. So let's run this program, simple program. Good. So see, index 0 gave hello, 1 gave red and 2 gave apple. Now let's look at another example. So the other way to declare is you just have any variable declared, and that variable is an array, and what you have to say is equals to, and in the bracket you just give the list of items which is separated by some space, one or more space. Now here note that the item need not be only string, like if it is a string it's in double quotes like this, it not be in string, this is a number. So this is my first element in the index, then this should be my second element in the array, then this would be my third, and this number would be my fourth, and then this is the fifth. If you have a space between that, you have to put it in a double quote. Otherwise, if you just don't put double quote, then you can it will be taken as two different element. So 0 1 2 3 4, when we print this array, and the way you print an array element is you have to say dollar. That is needed because whenever you are dereferencing kind of thing, it's not exactly dereferencing, but whenever you're trying to get the value, you have to put an dollar. And there is a mandatory brace for accessing the value in array. So you have to give this opening brace and closing brace, then followed by the name of the element array and whatever index element you want to get. So you can get that. So now if I print that, this 0 will print this will print rate, this will print is, this will print me 45, and this will print me per kg, one word. So let's run this. So the rate is 45 per kg. So this is a simple example. So this is another way we can declare. Then we will look at one more way. So there is yet another way. It's similar to the last example which we have seen, but here what happened is, instead of directly giving the name of the item, you can also specify at index 0 you put this item. So at index 0 in the array underscore var, it will put the item first item. At index 1 it will put second item, and by default whatever the next index is, it will put this item into that consecutive. So of course this will be 0th index, this will be 1th, first index, first in the sense second index, so it is index number 1, and then this is index number 2, it will put the last item. So if I print this using echo, so it will print first item, this will print first item, this will print me second item, this will print me last item. So let's run this. Very good. So I have another way to declare and use index and arrays. Let's look into another way. Now this time I am doing slightly different. I am taking this array opportunity to find out a list of IPs there, whether those IPs alive or not. So to make it more interesting. So what I do is I read an IP address separated by space from the command line. So I will echo the word okay, please enter the IP address, and what user will do is user will give the IP address separated by space. So he will enter the first IP as suppose 192.168.0.10, and probably second is 192.168.0.11, blah blah blah. n number of IP address. So I will read that from the, we have already seen that read will take the user input from std in, but when we do a read with -a, what it means is treat it as an array. So read with, you will read it as an array, split it and keep it as individual items. So once this has been read, now we can use a for loop to iterate over this list. So how do we iterate? So this is my array name, ip underscore list. Now you have seen that to access an element of an array, what we have to, we used to give in the previous example, dollar, this opening brace and closing brace, then inside that the name of the array, and we used to give index like 0 1 2 3, right? Now this time I'm giving at the rate. So what it means is, at the rate means this will take the entire list as one element and split it as needed. So this for loop, it will give me throw one at a time. So it will take the entire array as one element, and when we iterate, it will give one element out of that one element, first element, second element, third element. So what it means is, if we have entered, like here we have given 10 IP address, so each time we do forward for I in, it will give, first time it will give me the first IP address, then next time it will show me the second IP address, third IP address, fourth IP address. Very simple. Then I have just beautifications, so it's just one line echo to look beautiful. And then what I do is I run a command called ping, and in ping I give an option excuse me, in ping I give an option -c, and what -c1 means, you send just one packet, and -w is a timeout for 3 seconds. Don't wait more than that. You could use more number of packets and more number of timeouts to better gauge whether the host is alive or not, but this is just a demo, so I'm using some good numbers which I know is good for my network. You might use some other number. Then this is the host name which I will get as an IP address. So host name is an IP address here. And 2 greater than &1, it means is whatever there is an error in the std out, just I mean to say stderr, whatever error is there in the stderr, just redirect everything to std out. So 2 is stderr, 1 is std out. So redirect all the error to std out, which means everything would be visible in console. And in the next statement, I'm saying whatever comes to the console, just throw it to the dev null, which means nothing should be visible on the console. So when the ping command runs, you might be aware that it gives you that TTL or time to leave and those kind of things. I don't want to see those kind of things from the ping, because my screen would look cluttered without that. So I don't want to see those statements. So I just want to see my own statement, whether the host is alive or host is down. I don't want to see extra information. If you wish, you could not just do this and you could see entire information, but then it will look cluttered, like this message is coming and then this is also saying host is alive, down, whatever. Now we are already covered that if ping is successful, it will return the value 0. If it is not successful, it will return anything but 0. So here, if you see here, ping, if it is successful, it will return 0. So we are comparing. If my last return, which is given by $? equals to 0, I would say host, whatever $I is there, is alive. Otherwise, I say host $Y is down. So let's quickly run this program. This is a very simple program, but it can come handy to some of you who is working as a system administrator or wanted to be a system administrator, and you can manipulate this program to take the input from a file, or maybe generate a list of IP address dynamically and put it into array and do this kind of operations. So let's run this and see. Please enter the IP address separated by space. So I give the IP address as 192.168.0.1, which is my router. I know for sure this will be pingable. Then 192.168.0.100, it's my another IP in my network, and 192.168.0.101. I'm not sure whether 101 exists. Let's see. Let's run this. So if you see here, host 192.168.0.1 is alive, and then this and this is down. So this server right now is down. So that's the reason it says down, and this is also down. So it will give you in a very clean way it's alive or down. Very easy to read. Now let's suppose the same example if we do here and we don't do the redirections as we are doing it now, how it will look like and why I did that. It will make you understand in a better way. So 192.168.0.1, then 192.168.0.100, 192.168.0.101. Now if you see here, this does says host is alive 0.1, host is alive. Now but what you see is there are certain other information and the screen looks cluttered. So that's the reason I was not trying to do this way. I just redirect entire std out to some other file. So that's it for this example. Now let me go through one more example and we will. So the next example we will cover is, again it is a interesting example, and what I meant by that is, let's suppose you are given a task as part of your assignment that you take all the username and you modified it. So like let's suppose this is my system and in this system etc password has this username. The first field is username. We have already covered all these concepts, but each of the users needs to be part of a domain, or there needs to be excuse me, there needs to be a domain name appended to the username. So what we should do, so this is our problem statement. So we will do this now. So there is a small script which I have written, and this is like this, goes like this. So what I do is I will do a cat of etc password, which is my file, and then I go through the awk and awk minus f. So let's take this program one step at a time, how it is going to work for me. So let's do like this so that it is more understandable. So first I will do cat etc password, and this shows me entire password file. Good. Now in this password file I just need the first field. So when I need the first field, by default awk does a split based on the space. So there is no space, there is a colon. So if I want to split based on the colon, I have to pass an option called -f in awk, and within a single quote I can give on what basis I want to split. So I want to split on the basis of this, and this is my first column, this is my second column, this is my third column, fourth column, so on and so forth. So what I need is the username, which is my first column. So I will say print the first column. So print $1. This is the syntax for awk, and see, it has given me just the username. It has not given me anything else. So if you look here, this is the command which we are using. So let's copy this and go at our example. So this is the exact command which we are running. If you see here, the only thing is we are putting a dollar in the front. So when we are running, we put it into a bracket like this, and then we put it into a front, we put a dollar, and then they become identical. That's the way you have to run a command in a small way, identify that everything is working fine, then make it a bigger command, take it into a variable, then you know for sure your command works and debugging becomes easier for you. So when I have taken this entire thing, I will put a dollar and this bracket. What it means is evaluate this command and put it as an array in this variable called output. So output automatically becomes array. Now once this becomes array, I can iterate over this array. So I have to give an index number. So we have already seen that we don't know the index number, first index, second index. We cannot write like over 100 or thousands of index, right? So what we do is we take it $@ and what it will do is automatically iterate over 1 0 1 2 3. So I first time will become index 0, then I will become next time index 1 and index 2. So when we print, we will add BSS, which is my domain name, or underscore, and then my whatever the user ID. So my user ID would reflect like domain name underscore user ID, and then I can redirect this depending upon my use case, redirect this to some file or something. So that's the way I can just create a list of user IDs appended with a domain name. So all the users now will be in the domain BSS underscore some name, some username I can identify. This is the way you can make it useful and tweak it according to your need. Now another example I have is T6. Now let's suppose I have a variable, and we have seen that to declare an array you can just say array name and list of elements in the array. You could also give index, but here just this will be at index 0, this will be at index 1, this will be at index 2. Now if I want to know the length of this array, so what we have to do is, this is the syntax you have to remember. What you have to say is array name at the rate, and then in front of that you give hash and then bracket and then you evaluate. So that becomes the length of the array. Then we can echo this total number of DNS is length, and if we want to iterate like we used to do for loop and array name bracket at the rate, you can just iterate over the length and say index I. So from index 0 it goes up to length, and you could just fetch the element based on the index using the for loop. So if you go here like this and do, and it will tell you all the elements. So let's run this and see the output. So you see it says total number of DNS server is 3, and then the first is cp1.google.net, next is Mountain View, and then third is google.us. So this is the way you iterate over the list. And mind it, this semicolon, it's not necessary. You can do it without semicolon. It's not like C that it will take it as a next statement. You could put semicolon or you don't put semicolon. Like if you put a semicolon in a for loop in C, that is like end of a statement, and then it will not evaluate these statements in C. But in shell script it's not like that. So this semicolon you can put or you cannot put, it depends. If you're putting a semicolon, usually what happens is, to make it better, people do it like this, semicolon do, and then they remove do from here. That's the way they write shell script. But whatever way you choose, you just standardize your way and try to stick to it, or maybe stick to your company's coding standard, how they do shell scripting coding, what is their way of doing, and you try to follow that. So but I usually do this way. I also don't put semicolon at the end, but it's up to you. So that's all for this video, and I hope you like my video. Let me know if you want to give me some feedback about anything, and I hope to see you soon in next video. Hello and welcome friend. In this tutorial we will try to look at a concept called as here document, here HERE, here document. So this has certain usefulness in the sense like this here document can be used for multi-line comments, and it can be used for automating the things. Now we have seen that any line which starts with hash in shell script, that is a comment, so which means it will not execute. But there are scenarios wherein you want to comment out multiple lines and you don't want to go and type hash in front of each of these lines like this. That would be painful. And there might be situations where you want to comment out a portion of the code, and maybe just for debugging or things like that, and you want to have a quick way so that you can just comment out certain portions. So like I said, doing a hash like this and commenting a line is not very much feasible when there are a lot of lines. So there is a concept called here document, and the syntax goes like this. You have a less than symbol followed by any kind of token. This token is your name. You could have put any token. In my case I'm putting cough, or I could have done EOF, whatever token you want. And whichever token you put, you have to write the same token here. So this token and this token should match, and this token should only be at the beginning of the line. If you have this token moved one character, you see it changes the color. My terminal is detecting the shell script, so it changes the color saying this is a wrong syntax. So it has to start with the starting of the line. So that is very important. Starting of this symbol, it can move in number of characters, it doesn't matter, but the end termination should be here. Now let's see, if I run this script, I will get this printed because this is not commented out. However, I will not get any of this printed. This line would not execute, will not print because it is part of comment. So it's a multi-line comment using here document. This concept using less than and some token and ending with a token is called as here document. So let me write this also. This concept is called as here document in shell script. So now let's try to execute this program. If I execute this program, you see the first line, this line would execute and the end line gets executed. So this line would execute and after the here document, this line would execute. Now if I just comment out this portion itself, like let's suppose I comment out my here document, then all of this, or maybe I will just remove it for clarity so that you guys don't get confused. So you will see that all this line, this line, this line, this line, and even the sleep, it would sleep for 10 seconds and it will execute. So you see it executed everything. Now it is sleeping for 10 seconds. Once it comes out, then it will execute, this line will execute again and it will terminate. So that's the way. So now if you see here, I don't want to put a comments like multiple lines. I don't want to put a hash in front of them. So I just put one token and I end with the same token, and this token has to start with the line. So this is one usefulness of here a document, that it can be used for commenting out multiple lines. Now there is one more use case where you would be using the here document. Let's suppose you want to automate something. You want to go to FTP site and download something. So for FTP, you go and say FTP server name, and then it will prompt you for the username and password. But how do you do that from a shell script? So you want to do something from a shell script wherein you can automatically provide FTP username and password. So let's do one example. I have one server, now I go here and I pass certain username. So you see it gets blocked at some username, and then when I provide the username, someone has to provide this. But when we are running the shell script, the script would not pause to provide the username. So how can we achieve that? So what you do is you will use the here document. So the way to write the script is like this. So before I go ahead with this script, I would like to read certain note about FTP. First thing is FTP is obsolete and it's very insecure. So don't use it in any programming code or wherever until and unless it's absolutely needed and you know what you are doing. FTP I am doing here just for the demonstration of here document. I'm not doing a FTP demonstration. This is a demonstration of here document, and one of the ways in the old days people used to do FTP. This is just for your learning. You could replace this with SSH or SCP or maybe disk partitions. You can do all kind of things with the here document. The concept is same, but since FTP is very trivial protocol and it's available at many of the places in the older system, so I'm displaying this. So I make certain variables instead of just hard coding all this. It's easy for me to put into variables. So I have a FTP server name, the server where you will log in. You have to change this with your IP address. Then the username of the FTP, you replace this with the appropriate username. Password, you replace with the appropriate password, and the directory where to get the file. So there might be a folder, my folder. I'm just saying my folder. I have in my FTP server, there's a folder called my folder. In your case, it might be your username, home, or maybe folder after folder, or maybe some folders like this, my folder, and then inside that there might be maybe another folder one, and so on. So you have to make appropriate changes. And then this is the file I wanted to get from my FTP server. So now let's put this everything together into a script. So like I said, here document, it starts with this in my previous example. So it starts here and it ends here. Now here it is something little bit different. When the here document starts, it needs input. So FTP is the binary which we are running. So FTP minus n and then this server name. So this is just a FTP command. Usually you do FTP server name. Now why this minus n? when you do a FTP and there is an option in FTP to save your username and password in FTP config file. So whenever you run FTP, it will try to log in automatically. We don't want to do that. In my case, I don't have my password saved anywhere, so it will not do that, but it's still better to put -n options. It's more generic. Now to provide the username, you have to say quote and then followed by the keyword user, which comes from the FTP, and your username, code, password, and then you go to the directory. So whatever you do manually, you are just automating everything. You go to the directory where my folder is present, and then you want to get the file in binary mode or ASCII mode. You have to give appropriately. You want to have a hash, which is a progress bar excuse me, and then you say get file or put file. After that you quit FTP command. It's a FTP command, and then this is this. So this is the way you can automate FTP. So I will run and demonstrate this. So since I have some dummy username and password, so I have replaced this with my actual username password just to run this. So if you see here, there's no file name called filename.txt here. Now I will run this program. It's the same program. This this program is the same program. FTP script 1 and FTP script are same. Just in FTP script 1 I have changed with my actual credentials to demonstrate. Now if I run this, you see here I got the progress bar. I got one hash, which means I got some data, and you see this filename.txt I got. There were no filename.txt earlier, so I received filename.txt from my FTP server. Let's remove it and run it again. So I removed this file, nothing is there. Now I run my FTP script and I receive the file. So this is the way you can use that. You can, this is a working example. You can just replace with your variables and everything, and it will work for you. Now, so we have seen that multi-line comments can be used with here documents, and you can automate. Similar, you can do disk partitioning using parted. Like there's a command called parted, GNU parted, and then inside the parted you can do make level. So you can run those commands using here documents. So one more quick example. So there is this switch example. This is my switch example, which we have seen in the switch case statement when we are running, and we used to prompt the user that type a number between 1 to 4 and it will say something. Now let's suppose there is some problem in this code and I'm not sure where the problem is, and I'm debugging. So I wanted to see that whether the problem lies in this part of the code or maybe below that. What should I do? So if I run this program here right now, it will just ask me and between number 1 2 4 whatever, and I'm not able to see what to do. Right now it's a working code, but let's suppose it is not working. So then there's a problem. So I want to comment out so that I can narrow down my problematic area. So I will just put UOF, and this entire thing of while loop will not execute for me. So when I run this, just runs and comes back. That's fine. So I know, okay, this part works fine. So which means that this part is not problematic, this part is not problematic, bottom part is not problematic, this is not problematic. So there might be some problem here. So then I can narrow down and put, maybe with each individual cases also I can put UOF. Of course you have to see that you are not writing UOF in such a way that there is a syntax error, but you can do multiple comments. If there would have been no UOF, then you would have end up doing like this, which would be really bad. You might be doing like this, and this file might be 200 lines, 300 lines, you never know. So that's all about this video, and you have seen that it's a very useful thing when you try to do automation. Even though this is not as good as some of the other automations tools, like if you talk about TCL TK, those are really very advanced, but it is not part of shell script. But if you want to do something rudimentary and really things which supports here documents like FTP, you can pass username and you can code something, some kind of a prompt system, then you can use here document. So thank you all for watching this video, and I hope to see you in the next video. You have a nice time. Bye.
Hello and welcome, friend. In this tutorial we will try to look at a concept called trap and signal handler in Linux. So signals are a way of communicating between two processes in Linux. This is true for many other operating systems like Windows, but we will concentrate about Linux. And signal is also one of the IPC mechanisms, inter-process communications in Linux. The way there is a signal IPC mechanisms like shared memory or pipes or mutexes and semaphores, even though mutexes and semaphores are used for locking, they can be used as a way for IPC for communication as well. And signals are one of them. Let's suppose you want to transfer bulk data. Signal handler are not good for that. The bulk data for shared memory is good or pipes are good. If you want to have some kind of messaging kind of thing, probably you can use signal handler. In some situations, you can also use mutex, even though mutexes are used to lock for some particular thread and you might be doing some critical task. So they have a well-defined way. So usually we try to use mutexes, semaphores, spin locks in the context of a thread or a kernel thread. Now coming back to signal handlers again, we will be covering signal handler and traps as part of this tutorial. So whenever a process wants to do something, or if some other thread wants to notify some other thread, they will issue a signal. Now depending upon the context and depending upon the priority, the signal may be received and responded or may not be received. So let's try to look first what all the systems are present, what all the signals are present in a system. So there is a command called kill, and when we say kill minus L, it will list out all the signals present in the system. So let me make it little bit better, and it will list you all the signals like this. So one is for sig hub, which is signal hang up. Two is for sig int, which is signal interrupt. Sig quit, signal quit. Sig ill, it's a kill, but there is a difference between kill and this. Sig kill and sig ill. This can be trappable, this cannot be trappable. That means you cannot trap this signal and do some processing. Then there is a sig trap. Sig trap is for producing the codum kind of things, like block or trap on particular signals so that you can do some kind of debugging features like GDB, run GDB on that, and then many other signals. So there are some signals also like sig user, sig RTMax, which are user defined. RTMax and RTmin are you can use most of the time in the system. Of course you can use all of them, but if you want to implement your own signal, you can use sig USR. So let's try to look at some of the functionality of the standard signals, because sig USR1 you will raise a signal only within the context of your program, so that no other programs use the same signals within the same processes. So those are the use cases. Now the general syntax for a trap command is trap followed by some command followed by name of a signal, and there could be more than one signal. So it should be signal, it could be signal 1, signal 2, signal 3, and so signal n. So it could be n number of signals. So it's a trap, and then based on the trap, whenever there is a trap, you want to run some command. This is the command. So you're trapping a signal, and this is. Don't worry about kill sign, like when you might have all gone through kill -9 and process ID and you're confused what is this kill -L. Kill -9 process ID is actually sending a signal and trap is receiving that signal. Now kill -9 unfortunately or fortunately cannot be trapped. That is the only signal which cannot be trapped. That means you cannot catch and do some processing. Whenever kill comes, the system terminates the process. And of course it has to be the right user, because you are running some process as a user, you are running some process as a root user, and maybe some ordinary user who doesn't have a permissions for that particular process will not be able to kill that process. So those policies and securities are always there, but apart from that we are talking in the context of killing. So let's try to demo a small program for this. So what I'll do is we write a small program called test.sh and we'll say hash not been bash, and we will write a infinite while loop. So I will say while true do and say echo hi there and say done. Now since it will be printing very fast, so I want to see the contents on the screen, so I will say this. So this is good. Now you say while do hello, it will just print hi there, sleep for 1 second and does this in loop. That's all. Very simple loop. So let's try to work on this now. So every 1 second it's printing hi there. Now if I want to terminate this process, I would send a signal control C. So control C is actually a signal. So you have to understand that control C is a signal. Now what kind of signal it is? It's a sig interrupt. So if you say kill minus L, so there is the interrupt sig interrupt. Sig int. This is the signal which you send when you press Ctrl C. So actually you are sending a signal. When you terminate a process, you are actually sending a signal to the process saying, okay, terminate this process. So that's the way it works. So we saw that when you press Ctrl C, this process got terminated. Now what would happen, like if you are running a very critical process and you really don't want a person to press Ctrl C to terminate this process. So you want some kind of a trap that when you press Ctrl C, that gets trapped, not process, that gets trapped, and you do some other task rather than terminating the process, right? So I don't want my process to be terminated by Ctrl C because it is doing some important task. So let's try to do that change. So what you do is at the start of a program, so always remember whenever you do a trap has to be done at that part of a code wherein you feel that someone can press some signal. So you have to take care. Usually it is at the top of the file or somewhere you start a loop. Before the loop you do that, but you have to ensure that wherever you're putting a trap, from then onwards the signals become active. Okay, so I say trap followed by some command. So I would say echo, my command is echo hey you trying to kill me, something interesting, and the message is sig int. So what I did is I said trap. So whenever this particular process, this entire process, when it is running in the system, someone press Ctrl C, the trap will trap that Ctrl C. It's like a hook for that Ctrl C, and it will, instead of killing the process, it will say print this line, and then what type of signal I am trying to trap? Sig int. So you have to remember sig int. You have to understand. You cannot say sig hub here. So I will try to explain that. But let me go through the example one by one. Then things would start becoming more clear. Now let's run this program. Now if I run this program this time, hi there. When I say Control C, you see it says, hey, you are trying to kill me, and it is still continuing. It's not terminating the process. Hey, you trying to kill me, still continuing. Now if you really want to kill this process, there are two ways. You get the PID of this process and say kill -9 particular PID, or you can say Control Z, and pressing Control Z will push that program into background. In that way you will have access to the terminal. See, right now, earlier there were no access to the terminal. Now I can access the terminal. I can say kill %1. If you are not aware of this background foreground process, Control Z, I would advise you to look at my other tutorial called FG background processing and handling in this bash shell scripting. So I have already covered this very extensively. Now let's see, let's terminate this process. So this process got terminated. If I say jobs, there is no more jobs running. Earlier it was running. So my process got terminated. So far so good. So let's suppose I wanted to experiment. Instead of sig int, I say sig hub, which is my other signal. Let's see what happens. So kill -L if you do, So there is this sig hub, the first signal kill minus int. So if I say test.sh and if I say control C, you see it got terminated because I am not handling sig interrupt at all. Sig interrupt is same as me. So same as like you writing a for loop without any signal handling or while loop without any signal handler, and you press control C, it goes to the process and there is no handler for that, it gets terminated. Now if you don't want to terminate, you trap it and do some work. Now I'm trapping it and doing some work, but the actual signal as part of control C is sig int, but in my code I have written sig hub. So sig int is no more trappable, right? So that way what's happening is when I say sig hub and I'm sending the signal sig int, so sig hub it's not there, so it's not getting trapped. This is not getting executed, not trapped. Hello and welcome friend. So we will look at some more examples in this tutorial with respect to signal handler. So in our last example we have seen that we have this file called test.sh and we used to have the sig hub. Now let's try to give some other signal to this program. So let's see, we are running this test.sh and right now we are trapping sig hub. So which means that whenever I send a signal sig hub, so which is 1, it will print me something. So ps minus ef, which something is the echo, whatever we are giving as part of the command. So the process ID for the test.sh is 16877, and if I say kill minus 1, which is my sig hub, which is what I am trapping, and if I say like this, so it says hey, you are trying to kill me. Now there is this signal called sig-ill, which will kill based on the illegal instructions. So if there is the illegal instructions, you are executing something and maybe somehow your assembly code got messed up or something, or maybe you are trying to run some of the ARM instruction sets on Intel CPU which is not supported, it might crash like this. So let's try to send this signal kill minus 4 to this process ID 16878. And look, it terminates here because it was not handling, so it will terminate. Now let's run this process again. Now let's try to find out the new process ID because the process got terminated, so there will be a new process ID now. So new process ID is this. Let's try to send this signal sig trap. Sig trap is for trapping when you are running in a debugging mode. JDB also uses this sig trap when it processes the code dump. So for a running process, this is a good thing. For a running process, you want to inspect the stack trace or anything. It's a hung process. You could send a signal like kill minus 5 to the process ID and it would terminate with a code dump. You see it has produced code dump if you have u limit set. I got the code dump. So that way you can handle the signal handler. Now let's try to modify this program slightly. So I have test. Now what if instead of writing some commands, I might want to do something which is complex. So I can put it as a function also. So I would say function, and my function is suppose cleanup. So remember, function keyword is not needed for writing a function, but I'm just giving, it's just another way. Now I say received signals and processing and cleanup files. So now what you do is, instead of this you could say cleanup, just a name. Right now let's give it like this, and also you can give a list of the signals. So I mentioned that not only sig hub, but you can say sig int, sig trap, sig ill, and let's see the other signals. So kill minus L. Now there is this guy. there is this guys seek kill. You cannot say seek kill. You cannot write this because you cannot trap. This is the only signal which cannot be trapped, because when if suppose if there is this some signal also getting trapped and you want to really kill a process, something went wrong and someone is trapping that, you will not be able to kill the process at all. So operating system has reserved this kill -9 for not trappable for that purpose, so that when everything is lost and you really want to kill a process and it's not getting killed somehow, you can use kill -9. So kill -9 is guaranteed to kill a process, but still there are situations in which kill -9 will also not work. There are some zombie process and child process concept when parent process is waiting for the child to complete and child has not yet completed. So in those scenarios, but under all other normal scenarios, you can issue kill -9. So let's see. So we said like this and we are running the signal handler. So one more thing you have to understand. Suppose this loop is working. So you have in this function will work only when we receive a signal, because that's what we are saying, trap this signal, these kind of signals, and whenever these signals are trapped, you execute this command or function. So instead of command, now this is a function. Functions are also treated as a command. So suppose this line is getting executed and you send a signal from the shell or from using kill or interrupt or whatever. As soon as it gets this signal, when it was executing this line, it will get trapped and then it will execute this function. Now once the signal handler has done processing, it will go back and it will continue, because that's how we see that whenever you have a echo hello printing on the screen, hi there printing on the screen, and when you send some signal, it prints the signal handler code and then it continues to print. Okay, so let's go about that. So test.sh, we modified it now and we say control C. You see it receives the signal and continues processing, receives the signals and continue processing, right? So is -if pipe to grep -I test. Okay, kill this for now, kill -9. So now you understood that kill is nothing but it's actually a signal, sending a signal to the process, and kill will not be -9 will never be trappable, which is kill. So now you have seen that this process, what if after receiving the signal I do some cleanup, like I do some work and I will do exit. So in that way, what happens when you receive a signal, you are not like a zombie process, you are not holding on to the loop or something again and again. What you actually do is you call exit function, and whenever you call an exit functions, exit is a termination of a process, so exit will exit that process right away. So you might need a situations wherein you are doing some critical task, you have created some temporary files, maybe 20 temporary files, and you receive a signal. You don't want to terminate right away, but what you will do is you will clean up those files, but you will terminate. So that way there are two use cases. One is you never terminate, so that's up to you, you never terminate, so you just write a signal handler without exit so that you never terminate. The other is you will terminate, but you will clean up your things. It's not like abrupt termination. You will clean up all your code, temporary files, you restore your code to a state so that next run would not be a problem, and then you exit. So here you can write all codes which you do as part of cleanup code, whatever you want to do here, and then you do exit. Now this time let's run this process. So if you run here and press Ctrl C, which is sig interrupt, you see it received the signals, it does the cleanup code, but it terminated. It's not continuing anymore. So if you say exit within that signal here, so it will terminate. Now this, instead of this exit, instead of giving it here, you could give it here. You could give it as exit 1. So you will see a very standard way of doing like this also. Many people does like this. So now let's try to run this again. So you are running this process. Now you say Control C, you see there is the same effect. So in the internet also, with respect to trap, you will see people using like this. Now what kind of signal within this function, I wanted to see what kind of signal I received. So remember, I mentioned you guys that in functions the argument which you received is again same as $0, 1, 2, 3. So I will say signal received is $1. Now let's see. So this time I am not doing an exit here, but I'm just saying here signals received. So remove this and let's run this code. So hi there, Control C. Now you see it says signal received. Sometimes I know that I am sending one of the signals here, but how does the cleanup code knows that out of these and maybe many other SIG_RT, SIG_min, SIG_user1, those things, which signal I received? Maybe I wanted to do something peculiar based on my signal. So in the cleanup I can say, okay, it's an interrupt code. Someone send me an interrupt code, I will do some extra cleanup. Someone has sent me a hang up, so I will restore my baud rate, something like that I wanted to do. So since cleanup is a function here, and in function you know you can pass an argument, right? So let's see, I would say something like this, SIG_int. I will pass an argument as SIG_int here. And so of course it doesn't make sense, because when I say it here SIG_int, so I can only say SIG_int. So you could say like this, SIG_int, and then maybe SIG_hub, and so in there say SIG_hub, and maybe SIG_il. Okay, so all those are trap signal. So SIG_int, when SIG_int is received, to the function I will send SIG_int. When SIG_hub is received, I will pass SIG_hub. When SIG_il is received, I will pass SIG_il. Now let's run this process. So I'm running this. Now if I say Control C, you see my signal received is SIG_int. It does tells me my signal received is SIG_int, which is coming from here. Similarly, if I send a SIG_hub signal or SIG_il, let's try to give a SIG_il, it would tell me my signal number. So if I say kill -l, SIG_il is 4, and then my process ID is ps-ef pipe to grep -i test, and I would say kill -4, sending signal 4 to the process ID 171888. You see, signal received SIG_il. So that way you can process the write the functions and do some signal handling. So this is also another way of writing the same thing. You will see many people do like this. So exit means that you run this function and after that you do a exit one, or instead of writing exit here, you could have done here the next line after this, you could have said exit 1, exit 2, whatever. So when you say exit, if you don't say exit, it will get the signal, do this work, and then continue doing what it was doing earlier. So signals are a way of interruption. When you send a signal, it got interrupted, and you have a signal handler, it will process the signal handler, and once the signal handler code is done, it will continue doing what it was doing. So if you really want to exit the process, in the signal handler you can say exit, or anywhere after calling the function you can say exit. So that way you can have a very fine-grained control over what you are trying to achieve with your signal handler and signal. That's all for this video, and I hope to see you in my next video. I have some more examples with respect to signal handlers, so stay tuned. Thank you. Hello and welcome, friend. In this tutorial we will try to look at one more construct for trap. So in trap, like we have seen that after trap you will give a command or a function name and followed by the signal, and if you are giving a function name, you can pass an argument like typically signal number or maybe anything as an argument you can pass. Now there is a keyword continue which we use for while loop or for loop or until loop. So sometimes what happens, like if you want to continue the loop, you can say continue, but mind it, whenever you say continue, that has to be in the context of for loop, while loop, or until loop. If it is some other place where you are putting continue, it might give a error. So your program might work under some conditions, and depending upon where the signal was trapped, it might give you error later on. So let's try to look for this. So this is what it will do is, in the infinite loop, it will print hello, sleep for 1 second, and keep on doing. And whenever there is a sig interrupt received, it will continue. So which means it will just ignore the signal. Whatever the signal comes, it gets trapped and it will continue from there. So let's try to run this program. Trap 3, and you see it says hello. If I say Control C, and then it continues, because I have said continue, so it will just say continue. Now let's kill this process forcefully. Now let me comment this out for the time being, and let's make an equivalent program. Now this is something wherein we will just sleep for 300 seconds. It's not in a loop. So what will happen when we trap? Let's see that. So if I run this process, this is just sleeping for 300 seconds. Now press Ctrl C. So if you press Ctrl C, and you see the message says continue only meaningful in a for, while, or until loop. So here it will not work. So you have to ensure that when you are putting a continue, where exactly you are putting, that makes meaning. Also, I would like to point out that when you are doing signal handling, most of the time use bin bash. Don't use sh, which is like bin sh, or if you don't give sh anything, it will be sh. So Bourne shell signal handling is different from bash shell. So we will use bash shell for signal handling. Okay, now let me run this again and show me the difference. So here, so let me run this. I need one more terminal, so exiting that. Okay, now this is running. Pressing Ctrl C will send a signal, so which I can see, and it will continue. Now let's check the PID. So the PID is demo grep. So this is this. Now as part of, instead of giving Ctrl C, we can also say kill -2. -2 is for interrupt, and if I say this, so it has received a signal. Because right now there is no echo, so it was not able to print anything, but it has received the signal and it is still continuing and printing. Otherwise it would have died. So if it is still receiving the signal. For the shortcut for 2 is also -int. You can also give -int. This will also send a signal. Okay, now let me run the same thing in shell. Bash, instead of bash shell, sh, Bourne shell. So Ctrl Z, now say kill %1. Let's suppose if I run this in a bash shell, and I don't give anything, so by default it will be bash shell. So you say demo trap 3 and you run this. Now let's try to check the PID. You see there is no PID for demo. How come? Process is still running, but the PID is not there for demo. But if you look, there is other stuff here. There is a sleep process running. Let me decrease the size. So you see there is a sleep running. So what Bourne shell does is, it will take your sleep conditions, whatever is there, and it will substitute it with a corresponding new process in such a way that the original process got killed. The sleep process is running, but the original process is blocked somewhere, and your sleep will keep on running, and whenever the sleep is done in how many seconds, it will just signal the original process. Original process is no more visible. It's kind of a zombie here. So this is the behavior for Bourne shell, which might not be very good or intuitive from what we are trying to do. So that's the reason I was saying that we should always do bash shell. So to ensure that you always run in a bash,
you should say hash not bin bash slash bin slash bash. That's a cbang for bash shell. So you should always specify which shell you are running when you are using a feature like share like signal handling or those kind of exotic features. So that's all for the video, and I hope to see you in my next video. You have a nice time. Bye. Hello and welcome, friend. In this tutorial we will try to look at some more concept for the signal handler. So as usual, I have another cleanup functions, and in this cleanup functions I just echo the keyword cleanup, and then I delete 3 temporary files which we create sometimes later in this program. Then I install 3 signal handler. One is for exit, which is a exit signal handler. When the shell script exits, it's a pseudo signals which gets generated by default whenever the program gets completed, just before the program gets completed. Then second is for interruptions, which we do by using control C or maybe by sending kill -2, and sig hang up by kill -1 we can send this signal. Then I have this main log file, and then what I do is I just echo the keyword start of the script into a file, temporary file called temp startup.log, hostname in a file called hostname.log, all in the temporary files, and I look for the size, how much free space is present for tempfs. You could have done for anything, but I just do it for tempfs. This is just a demo for trap, not for tempfs, so I'm just doing that. Now this command is very simple. What you do is you say df, so it will give you disk free. Then you can say df and then pipe to grep tempfs, so it will tell you all the tempfs size, and in that you can say tel -1. Suppose you want to just take the number 1, so tel -1. Within that you want to take first, second, third or fourth parameter, whichever parameter available or used. So let's suppose we want to take it available, sorry, then you can take the fourth one. So this is 1 2 3 fourth column. So in awk you can say awk print $4, and when you say print $4, what it will do is it will extract the fourth column for you, and it will be giving you the size for the fourth column. So you can do like this. So let's make this as a fourth column, that's better. Okay, now I will check if the size is greater than 20, then I will say disk has sufficient size, push it to a log file, disk free, otherwise disk is full, and again push it to the log file. And when everything is done, let me delete this for now. When everything is done, what I do is I take this log file, this log file, this log file, concatenate together and send to main.log. Now once this is done, when program is about to exit here, so this is program exit, what it will do is it will send a signal called exit, and it will be trapped here. When it is trapped, cleanup function is called, so which means this 3 file will get deleted. However, the file which we have main script log, this file will be still present in the temp folder. So let's run this program and check. So if I run this program, demo trap 4, this is done. If I look at ls-l/tmp, so you see here I just got the main script.log, other files are not present. So how do we know that whether it got generated or not? So let's modify this program slightly and we can see that. Let's suppose we put a sleep for 20 seconds, and when this program is running we could see that. So let's see, push it to background so that we can go to the temp folder, we will have the access to the terminal. Now ls-l/tmp, you see here df.log, hostname, startup logs, those files get created, and apart from main script.log. Now once the 20 seconds is elapsed, the shell script will invoke a signal which is exit, and the cleanup will be called. Now the cleanup is called and all the things are gone, and you see only main script.log. So this is the shell signal, exit signal. Now what will happen when there is a trap? So let's suppose instead of 20 to simulate, because we have to send a sig interrupt and we don't want the process to interrupt to exit very fast, so let's give a very large number, so which means this process is sleeping for quite a long time, and then we can see all the temporary files, and then we can send a signal for sig interrupt kill -2.
right? So let's try to run that. So I will run it here as temp4, and I will open one more terminal simultaneously, and let's go to the temp and see. So first let me get the PID for the process. The PID for the process is 3263. So I would say kill -2, and I wanted to show you that it will not work if I say kill -2 for this process, and I will say why. See, this doesn't get cleaned up. If I look at the temp file, demo process, temp, you see here I have the df log, hostname, main, everything. So when I send a signal for the process, this didn't work. It should have worked. So I will tell you why. Now let's go and look for the process at which stage this is now. This is sleep, because it is sleeping. So let's grep for sleep. Now this is what we gave, sleep 99. Let's try to send a signal to sleep process, kill -2 for this, and observe what will happen in this terminal here. It will say cleanup called. You see, cleanup called, because one signal we sent earlier which didn't do anything, and the another signal which we gave as part of kill, and then that's why the two signals got delivered. So what it means is when a process spawns a sleep. So let me open this and explain this little better so that there is no confusion. So this is my main process running, and when it encounters sleep, what shell does is it spawns a new process. In that new process, it puts a sleep function. So it will call the sleep in a new process. It will spawn a new shell, new process, and run sleep inside that. In the meantime, your parent process, this whole big process which was there in the system, that will be blocked for any signal. It will not receive signals. The signals will get queued up, but it will not process any signal. So the main parent process gets blocked. The child process, which is sleep, will be running, but child process can inherit all the signal handlers of the process of the main parent process. So parent process has all these traps. So when sleep is called, sleep process will also inherit all these signal handlers. So it can respond to these signals as well. So that's why when sleep was called, when sleep was sent a signal, sleep responded to the signal, and when sleep responded, sleep is done. Then the code of executions went back to the main process, main program, and main program also received a signal which we sent earlier, which we said it will not work now. That main process also, that signal got queued up, and that signal also got executed, and that is the reason we got the cleanup called twice. One when we send it main, when it didn't do anything that time because the parent was blocked and the child was processing. The child process was sleep. So you have to be very careful. There are a lot of differences with respect to how signal behaves within different operating systems like Linux or Unix, even maybe with different distros and different APIs. So you have to be careful whenever you are writing a code with respect to signal handler. You have to test it very, very thoroughly. Even though you might stick to all the well-defined APIs or anything, but who knows, there might be some change or something which you have forgot to follow, or maybe there are some undefined behavior and you were relying on undefined behavior for signal. You can also look at the man signal and you will see the behavior of signal varies across Unix variants and also varied historically across different versions of Linux. And because signals are also part of kernel, the way kernel changes, maybe signal handler also gets changed. So this is a C API, same thing we use from the bash, and with the C you can use the keyword signal or sig action, those kind of things. So thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye. Hello and welcome, friend. In this tutorial we will try to look at how we can restore the signal. So when I say restore the signal, what I mean exactly is how do we revert the behavior so that it is same as without trapping the signal. So let's suppose this is a typical program which we were going through in our example. I wanted to have a small program with very less complexity so that once you have a clear understanding of the concept, then you can build upon that. But if the example program, those which are meant to explain you itself is complex, you might be lost in the complexity of
learning, but you will not be able to understand the concept. So that's why I try to get the same example and a variance of the same example. So let's look at this. It's a simple loop. Each time it runs, it prints hello, sleep for 1 second. And I have a trap. So whenever there is a signal coming, SIGINT or kill -2, it will print some cleanup performed, or if you press Ctrl C, some cleanup performed. So what I mean is, restoring the signal is when this cleanup is performed, and after that I want to restore the signal back, so that next time I press Ctrl C, it will not call this function cleanup. It will just whatever the default behavior is. The default behavior is to terminate the process, right? Whenever you have a process running while loop and you press Ctrl C, it will terminate that process. That's the default behavior. So first time I want to call the cleanup function, but next time when I receive a signal, I will do a terminate. So let's see how we do that. So let us first run this program, demo 6, and see the original behavior. So I would say demo trap 6. So I press Ctrl C, Ctrl C, Ctrl C. I press as many times. Each time it calls a cleanup function, but it never terminates a process. Now let me kill this process forcefully, and this is done. So how do we restore the signal? Now this time what I do is I will say trap hyphen and then SIGINT. So whatever signal I want to restore back, I will say restore it to the original behavior. So from next time onwards, whenever there is a signal receiving, so first time the signal receives, it calls cleanup, it prints this and it restores the signal. Next time the signal is received, this is no more working. And when this is no more working, what does it mean by signal being received? It means it will terminate the process. If a process does not handle that signal, the process will get terminated. So let's look at this example now. Now this is running. I press Ctrl C, it says some cleanup performed, and it continue printing. Now if I press Ctrl C again, see, it got terminated. So it ran only once. First time it ran and next time it just terminated. And by the way, this is not Windows 98, this is my MacBook, and I was feeling nostalgic about Windows 98 and I just put the wallpaper for fun. So this is a way you can set up the signal so that it works only once. So let me show you one more example for this, something similar. Till now we were doing just one function. In this I have two functions. One is called as cleanup new and then the other is called as cleanup old. In cleanup new I will say SIGINT, trap hyphen SIGINT, that means this will restore the signal. And cleanup old, what it will do is it will set up cleanup new, and then I have the signal trap SIGINT. So here what I am doing is I am printing hello 1 second at a time, and initially I trapped SIGINT. So whenever someone presses Ctrl C, which is SIGINT, it will trap to cleanup old. So when it goes to cleanup old, it will say some cleanup performed, and what happens is this will install a new signal handler. So this is not like restoring a signal handler, but installing a new signal handler. And when it installs a new signal handler, that becomes cleanup new. So first time when I press Ctrl C, it will say cleanup performed, some cleanup performed, and it will install a new handler. Next time I press something, it will say some new extra cleanup performed, and it would say trap SIGINT. And if I press Ctrl C again, it would terminate the process, because then it has restored the signal back to the without any signal state. So first time when I press Ctrl C, this will print some cleanup performed. Second time I press Ctrl C, it will say some new extra cleanup performed. Third time I press Ctrl C, it will terminate the process. So let's run this. So this process is running. I press Ctrl C, it says some cleanup performed. I press Ctrl C, it says some new extra cleanup performed. I press Ctrl C, now it got terminated. So this is the way it works. So this is pretty simple, straightforward example, just a mixture of the same thing which we have been doing, but I'm just trying to show the concepts from different perspective. Okay, now let's try to demo one more program. I have one more program, and usually you might have seen this has some use case. Many places, whenever you want to terminate something, it tells you press Ctrl C within 1 second or within 2 seconds, then only it will terminate, otherwise it will not terminate. So I have written the same program. So what this program will do is it will run continuously, and if you press Ctrl C twice within 3-second gap, it will terminate your process, otherwise it will not. So let's see how it works. So at the bottom I have this small loop, some very generic loop, that's same thing, no brainer. Then I have the trap for the second, that's okay, and it will call the function cleanup. And in the top what I did is I have two variable, old time and new time. Initially they have nothing, but whenever the cleanup is called as part of Control C, so initially what it will do is it will take the time and date. So when I take a date equals to space percentages, what it will do is it will return me the date since epoch. So it will see, if I say date, it will say 23, next time after 3 seconds 26, after 2 seconds 28, 29. So see, it is increasing each seconds I press. So this is the date plus percentages. If you see, it will say the number of seconds elapsed since epoch. So then I can just compare the time elapsed since epoch for my first Control C and time elapsed since epoch for my second Control C, and I can calculate the time difference between those two, and I can say if it is more than 3 seconds, 2 seconds, whatever you wish to, you can do that. So first time I say new time, and I can take the time since epoch, and I will calculate the time difference, whatever the old time difference is there. Initially old time difference will have nothing, so it will be just a new time. Now if I see that time difference, whatever I got is greater than 0, of course it has to be greater than 0, and time difference is less than 3. So from first to second, if I press, it should be less than 3. So within 3 seconds if I press, then it will say exiting the program, exit 1, it will call exit 1. When we say exit 1, it will just terminate the process. Otherwise, whatever the old time is there, it will say set the old time to new time, and then it will continue. So let's run this program. So let's run this demo underscore trap 8, and if I say Control C, exiting the program, within 1 second I press. Now let's run this. Control C, some cleanup performed. Control C, some cleanup performed. So within 3 seconds I already press. Now if I press Control C, I wait 1, 2, 3, 4 seconds. Now press Control C, nothing happened. 1, 2, 3, 4, Control C, nothing happened. But if I press Control C, within 3 seconds or within 2 seconds, whatever the time conditions you give, it will terminate and it will return give you the prompt. So the program got terminated. I would just like to show you the entire program again. It is like this. This while loop is simple, no brainer, but just this cleanup function, this has the little code so that you can run and you can implement something similar, that if you want from the user that they press Control C very quickly, then only you can understand that it's a terminate, otherwise you don't terminate. Or maybe you can say press Control C 3 times. You can implement those kind of logic. So thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye. Hello guys, what's up? Today we will learn how to install Ubuntu on my Mac as a virtual machine, and we can follow the same steps to install Ubuntu onto some real hardware like x86 or whatever hardwares you have, 32-bit. So we go to ubuntu.com/download, and we can download a version of our OS which we want to install. I will install 64-bit, which is this one. 32-bit is for 32-bit machines, and 64-bit Mac is for machines, Mac machines wherein you can do it as a dual boot. Since I will not be doing dual boot because I try to toggle between my Mac OS X and my virtual machines, so I always keep running as a virtual machines inside a Mac because I can switch very quickly rather than have to reboot. So once you download and you have the image ready at some locations, you go to your VMware Fusion. So VMware Fusion is a program which you need in Mac to install any virtual machines, particularly Linux, Windows, and different versions of Linux like Mint OS X, Minix. So here I have bunch of them. So I will create a new one. So this is probably an older one. So I will just delete this one so that there's no confusion. I'll go to the file menu, and mind it, this is the new version 7.0 VMware Fusion. If you have an older version 6.0, the options are slightly different, the menu looks slightly different, but most of the options are same. It looks different. Okay, so I say new, and from new I will select more options. So there are different other things like import an existing image which you already have as a vmdk file or from a disk image, but I would like to do more customization. So I will say more options, create a custom virtual machine. Install from boot camp is what you do it as a dual boot, which we will not be doing because I wanted to always let it running. So I click on select create custom virtual machine. I will select Linux as my Ubuntu. If you don't have your, like, let's suppose if you're installing Mint and you don't have it entry here, so you can choose others or anything which reflects like 64-bit. So you can say 2.x.64, whatever matches closely to you. So I select Ubuntu 64-bit since it's already there, and I will say create new virtual disk, and I'll say continue. And next I will do a customizations of the hardware. This will tell me where exactly is the location I want to put. So this is the default location for me. This is good enough. Now this is ready. I'll do some more customizations in terms of processors and memory. So usually it gives 1 GB of memory. I will make it as 2 GB, and then I go back to the customizations, select hard drive, and 220 GB is the default. I'll give 100 GB. I like 100 GB. The other thing I have to do is select CD drive, and I say connect. So this Mac doesn't have a CD drive, so I would choose say connect CD drive, which means it will use my ISO image as a CD drive, and then say select disk image, and in the disk image wherever I have downloaded my Ubuntu from ubuntu.com/download, I will point to that ISO image and say open. And once it's done, then I'm ready to install. But before we go ahead, let's go to the hard disk options once again. There's an advanced options. In advanced options, you have pre-allocate disk space and split into multiple files. So if you select split into multiple files, you will have a tons of files like 2 GB files in your VMware folder wherever you have installed, and that looks a little bit dirty, but this is faster. But I don't prefer that. And pre-allocate disk space means, let's suppose if you have chosen 100 GB, if you say pre-allocate, entire 100 GB will be consumed right away. But if you don't do a pre-allocate, and so which means if you're using only 5 GB, so out of 100 GB your VMware will be using just the 5 GB of the space. Also there is a drawback with not choosing pre-allocate, is that okay, you are using less space, but recent version of VMware creates a snapshot automatically, and over a period of time that keeps on growing. So you can experiment with all those things. So let me close this and go with these options. Then select on start button, and from the view choose full screen and let the installations go. So till this point, there is a difference between how you install on VMware virtual machines as Fusion or real system. But once you burn your CD, you'll be using your favorite burner like Nero. I use Nero for burning all my ISO image. Then the installations for x86 and for your Mac as a virtual machines remains the same. So you'll get a screen like this, and it will give you two options, try or install. When you click on try, it will just do it as a live CD and you are ready to use your Ubuntu, but all the files and folders will not be saved until and unless you mount some of the drives externally. If you want to have a permanent installation, select install Ubuntu, so which I'm going to do now. Now it gives you certain options what to do. Third-party installations, if you want, you can select. If you have already a network capability, you can say download, install. I'll not say all those things, so I'll say just continue. Now here is the important part. It says how Ubuntu is going to be installed. So for a real disk, if you want all your data to be erased, then only you should select this. Otherwise you have to choose which disk you have to install. For virtual machines it doesn't matter because we are giving 100 GB just exclusively for this. So most probably that disk doesn't have anything, you have just allocated. So erase disk and install Ubuntu, which is the safest. You can go ahead and do, but I would like my partitions to be laid out in a slightly different way, so I will choose something else. And when I choose something else, so three things I have to necessarily do while creation of partition. I have to create a boot partition, I have to create a root partition, and swap is not necessary, but it's always advisable to have a swap. So I will create partitions now. So this is my device DevSTA. It doesn't have any file systems, not mounted, nothing is there. So I'll just say new partition table and I'll say continue, and it has created a free space which I don't want, so I will say revert, and here I will say this new partition table you selected. Okay, with the created partition table, know that you will be undo. Okay, I'll say continue. Then with this free space I will add a partition. So the first partition I will add is 2 GB of my boot partitions. Boot partition is where your grub and the Linux kernels and those things reside. So you have to select /boot. It can't be anything else. It should be primary. You can select beginning of this space. That is fine. That's good. Default is good. So my boot partition is created. Now click on free space again and then select swap. So for swap you don't need to select the file system. So what you have to see, you see there's no file system for swap. So what you say is mount point is, sorry, there is a file system for swap. It says swap, but there's no mount point. Swap usually you gives the double of your RAM. So let's suppose you have 2 GB of RAM, so you give like 4096 4 GB of space for swap, but I will not give that much. For me, like I know I have tons of memory, so I will just give 2048. I don't want to waste memory, but you have to see what you can do in your system. Then again, so my swap and boot is ready. Now entire space I can allocate to root, so 103278. So this entire space, ext4 is the file system which we will select, and I'll say root. There are other file systems like ext3 which is older, ext2 is even older, which doesn't have a journaling, so probably not safe. BTRFS is new, not much used as of now. It has promising features but not very well tested. And for Ubuntu you may not be able to use FAT32. FAT32 and FAT16s are like extra partitions which you want to use to share files between Windows and Mac and Linux. So I'll just create ext4 and I'm done with that. So once this is done, I can say install now and it will proceed with the installation. I can choose my locations. You can type anything, like if you say, if your location is there like San Jose, so then you can select and say continue. Here you have to select which keyboard type you want to use. I'll leave with default US. Now my name I can write anything. I will say Shack, my computer's name Shack virtual machine. Pick a username, any username you wish to, and any password you wish to. Once this is done, and you might want to choose encrypt my home folder. If you want the entire thing, your home folder, to be encrypted, you can use that, but I find it to be more inconvenient and slow, so I don't use encryptions. Now it start installing and you have to wait for probably 15-20 minutes, and once this is done we come for the next step. So we are back and it says that we have to restart the system, so it will automatically do that, or you can just say click on restart. So So I will click on restart. So sometimes even if your system hangs like this, your virtual machines hang, you can always go to the top, you select a virtual machine, and you can either say suspend or restart. In this case I would say restart. So probably all the installations has been done, but I don't know, for any reasons it got hanged at this point. So I'll say click restart, which is like powering off your machine physically, and let's see what comes up. So my Ubuntu looks to have been booted, and you can see my username is being displayed, and I can use my password which I have given at the time of installation to log in. So once I have given everything, it is coming up. So it will have the Unity interface, and you can see this is a new Unity interface. Earlier we used to have GNOME and KDE. I am actually a fan of KDE, so I don't like Unity much, but you can do your customizations and install KDE on this. And probably if you want to do some command line programs, you can type xterm. So they don't have a console by default ready, but xterm is a program you can use to do some installations, and you can use apt-get to update the software or to install something new. So let's see what is here. So it has a bunch of folders pre-created for you for different functions, for different reasons, like videos for any video files, pictures for picture files, music folders, and you can navigate your Ubuntu. So you have a Firefox also, you can go ahead and navigate and see what best you can do out of it. So that's it. It's very easy and simple to install. Now if you want to shut down your virtual machine, it's always advisable to shut down using a virtual machines menu, or you can do a shutdown from the command prompt. So you can say sudo shutdown, and you can say -h0, -h is for halt, and you can see that you by default the username which you have created has already been created as a sudo user in vsudo. So Ubuntu does it for you. Fedora doesn't do it, you have to do it explicitly, but Ubuntu does it for you. So you can shut down. And also once your installation is complete, you can install a virtual machine tool. So if you see right now, I don't have the entire screen being occupied by my Ubuntu. That's because resolution is not proper. So to have the graphics card and everything set up properly, you can go to virtual machine and you can say install VMware tools. So we'll quickly see what this guy is doing. So once you click on that, you will be pop up for a download, and you say download. Once the download is complete, you can untar that to a desktop and install from the command prompt, or you can double click as a autorun.sh I believe, and you can install. And in the next reboot you will get your screen as a full size, and you can set different kinds of resolutions. So this password is for my Mac. So that's it. So you can install it, you can navigate and do whatever you wish to. So thanks all for my video. If you like it, give a hands up.
Hello and welcome friend. In this tutorial we will try to look at dd command. dd command is basically used for creating empty files or files with respect to copying something. Those kind of utilities you can do with dd command. So You will find this handy at many times. Let's suppose I ask you to test your disk fill test case. Now you don't know how to fill your disk. You can create a sparse file. There are another commands with respect to QEMU and those kind of things. We will take that separately. But if I want you to fill up the disk, so that you want to check the behavior of certain software, how it behaves when the disk is filled, you can use dd command. The way to use it is you can say dd and then basically two important options: input file, and I can say by default input file would be my dev0, and this dev0 by default is provided by the system in all the Linux kind of operating system or POSIX compliant operating system, that you will have 0 bytes, so that means null, kind of a null. And then output file would be any name of the output file. I can say abc.txt, and then you have block size, and block size basically means each file will take how much minimum block size, and the count, the number of count, and I say count equals to 512, maybe mine. So the size of this file abc would be a multiplication of this and this, so 1024 into 512, that would be the size of this file. If you run this, you see here 524288 bytes get copied. If I say the size of this file abc.txt, you see 524822, and if you just multiply this 1024 with 512, you will get this. So this is the size of a file, this many size of file. If I want to increase, I can increase any of this, increase either this or maybe even a count, and I can see that I'll get a 52 meg file got created, and it will tell me the size, speed. So this will also be handy when if you are testing some of the disk IO with respect to SSD. Let's suppose I wanted to check what is the performance of my SSD compared to my hard drive. I can run this command against maybe 7 GB of data or 5 GB of data, and I can see the speed on SSD and I can see the speed on HDD, and I can make some kind of judgment that which is faster and how many times it's faster. So dd command can be useful like this. Similarly, dd commands can be used on your on your Mac also. The command remains exactly the same. There are some options with respect to disk, but if you're not using the disk, we are not using any direct disk, we are using a file. So if you run this, you see this is much faster because it is also doing caching. So this is my virtual machine inside this. This might not have that much caching, but this is a direct max. So it has a native access to my hard drive, to my SSD drive. So it will be working much faster, of course. And Mac, I have seen it does much more better caching than as compared to Linux. Someone might disagree, but my plain observation is that Mac does a lot of caching. So this is about dd command. And also if you want to file, like let's suppose you want to copy one file to another, you can use the same thing. Let's see, I have this file test.py and I want to copy it. So let me see test.py, how does it looks like, what is the content, a small test script. So usually when you copy, you say test.py, you copy test.py to test1.py. That's the way you use. What if we want to use dd to copy this? So I would say dd input file equals to test.py and output file of equals to my dd copy.py, and I would say block size equals to 1024. And one more thing, count is not necessary, you can or you cannot give. So when you don't give count, it will go to the end of the disk or end of the file and it will take everything. So it will keep on copying this to this as long as there is data. If the data is over, it just finishes. And if you see here, my dd.cp got created. So my dd.cp and my test.py, sorry, my ddcp.py and test.py, they are exactly the same. So I just now created a file, a copied a file, you can say, using a dd command rather than cp command. So you can use it for copying a file also. dd command can also be used for formatting your disk, but be aware, let me give you a big warning, be aware, if you do that you will lose data. So you have to understand what you are doing. Let's not run that dd command with respect to disk, because I don't want you to lose data, but I will just show you how it can work. Okay, so let's see, if I say fdisk dev sda, I know that I'll have to say sudo. So this is my 200 GB disk. If I want to nuke my disk, nuke means just clean up everything, I could say dd my input file equals to dev 0, and I can say output file equals to this dev sda, and then I can say block size equals to 16 meg. You can also give like this 16 meg, 32 meg, whatever, and I can give count or I can just leave it. And what this guy will do, and I can also write a time command, that how much time it takes to complete this entire. So once I give this command, what it will do is it will take dev 0, which means null bytes, nothing inside, absolutely nothing. It will write to this output file dev sda, which is my block device. Block device means it's a device, it's a physical hard drive, and it will take 16 megabytes of chunk size and try to keep on writing, and it will format my entire disk. And if I do that, my entire disk would be lost, my everything would be lost. So I don't want to run that command, so be careful. So dd command can be useful for that purpose. Also, I'd like to show you one small command which is called as od. It's a very native, very old command in the system for hex dump, ASCII dump. So like I have shown you that my test script test.sh has just echo hello, $hello, and I wanted to see the ASCII representations. I could say od for this, and I can see like this. Now this might not be very intuitive. What is this? I could pass an options minus avx minus cx, and so you can see it will show me like this. So what it basically does is it takes not and it gives a representation for a not, b representation for a not, I, so I is this, n is this, and it just shows me the ASCII representation. So this command od might also come very handy for you. Now what are all these options? So there are two things with respect to this. One is the representation, the binary representation of the string within the file, and the way these numeric digits are being shown, the way the offsets of different lines are shown. So if you don't give these first options, it will show you by default whatever it is in the hex, but otherwise you can make it into hex, octal, whatever. So you can go through this man od and you can go this. So it will say you specify the input base address, and ax might be in a hexadecimal or by default whatever it is, so equivalent to minus p. So ax would be hexadecimal, and then cvx, c would be output c style escape characters, and then v would be for verbose, and x would be again hexadecimal. So that's the way different options work for od. Okay, so now the question is, why did I show you the command od? Remember when I said that I copied this abc, I created this abc from my dd command. So let me go back to my dd command, and you see here, okay, not this one. So with dd command I created a abc, and I said this dev0 will give you nothing, absolutely nothing, it's a blank file. So this file, if you see here, this file is taking size, but there is no content inside that. How do I verify? If I just say abc.txt as a vi, it might take a long time if it's a big file, and it will not show me anything. So how do I do that? So since I opened with a vi, so it got stuck now. It will take some time for it to come out, or I might have to kill the process. So let's see. Okay, it came out now. So what if I do a cat? So don't do a vi for a very large file, it might hang your screen for considerable longer period of time, and the cat says nothing. So are we sure there is some content? So I can run the od command, od minus ax minus cvx, or maybe just od minus x might also work. I can say abc.txt, and you see what od will do is it will take the file, look for the entire thing, and it will say that okay, everything is 0 in this file, so there is no data, and then it will put a star. That means repeat this. It will not just keep on saying that okay, line number 2, line number 3, line number 4, everything has no data. So it will put a star. That means there is no data in this file. What if I don't give x? I can just do like this. It will say, what if I want to still show everything? od minus cvx, I will say, and then it will keep on displaying all the data. And since this is a very large file, so it will take quite time to complete, so I will interrupt it. So od command will come handy. Now if you run the same od command against this other file, my ddcp, let's see what it says. od minus ax minus cvx my ddcp. You see, it tells you the representations. It just doesn't gives you 0 by default. So that means the command is working fine. The command works perfectly. So od command will also come up handy to inspect the file, to check whether the file is empty or not, and to get the hex representation or octal representation of particular file. So thank you all for watching this video, and I hope to see you in my next video. You have a nice day. Bye. Hello and welcome friends. In this tutorial we will try to look at some of the commands with respect to disk usage. So as usual, I have my Linux on the right hand side and my Mac on the left hand side. So the first command which we are trying to see is df, and before we go ahead with doing anything, we just look at the man df, and df says display free disk space. So disk free, you can read this as disk free, and it will tell you how much you have free space in your system. So by default, if you say df, it will list you information in this format, and then this is Mac, and for Linux it would be in this format. So let's go through this. So it will tell you file system. So this file system, if you see udev, tempfs, these are all temporary file systems. So the main file system I have is this /boot, and this is my root file system, and it says how many blocks it uses. So typically 1k block means for even a single byte of data it will take a minimum of 1024 bytes. That's 1k block. So if it's 1023 bytes of data, it will still take 1024. If the block size is if the size of the data is 1024, then it will fit exactly. So typically this is to avoid very small size files, and if you have a very smaller blocks, you have a performance hit. So that's the reason. And then it will say how much it is used, how much is available, and then the percentage. This percentage is the most important one most of the time, because people will look at percentage. So if you see here, whatever my size, like the size of the disk is around 200 GB and it's 17% fill, and that's the way you extract informations. Okay, now if you see here, this information is in blocks and bytes. This might not be very much readable, so you can say in kilobytes, and the same information you will see here will reflect slightly differently. So here it's by default it's already reflecting in kilobytes, so it's not making much sense. At the same time, you can also add an option called human readable value, and H means it gives you in human readable. So human readable in the sense, instead of this 198 blah blah blah, it will give you 190 gig. So this is handy. Now I ask you to write a script and tell me how much is my disk free on my primary disk, and which is my primary disk would be dev SDA. So you can just write a small script to extract this information. So let's do this very quickly from the command line itself. So I say df minus kh, I get all the information, then I have to extract with SDA. So I could say pipe to grep SDA 6, something like this. I got this information, and within this information I want to extract this percentage one, this. So this is first column, second column, third column, fourth column, fifth column. I want to extract fifth column, so I would say pipe to awk and I will print the fifth column. And sorry, oops, I am writing something, print, okay, sorry. So it says 17%. Let me make it smaller so that it's more readable. Okay, so you just run this and it will tell you 17%. This is my disk which is free, sorry, which is being used. 17% is being used, so remainder is being unused. So this is the way you can run small scripts. Same thing you can do on Mac. You say df -kh and you just leave it. And also you can give a path. If you say just current directory, it will tell you whatever the current directory is there and whichever volume it is mounted on, it will show the information about that current directory volumes. It will not show about everything. Same on the Linux. If I say df -kh dot, if I give some path, it will give me the volumes of the current directory which is mounted on. So right now my home directory is /home Shakil, so I'm in this dev SDA, and that's the reason it is telling me about this. Let's suppose I move to some other folders like tempfs, dev shm, or maybe some dev. Let's see if I go to dev and if I run the same command, what does it says? You see, it tells me 568 MB. It no more says like 190 GB. So if you say the path, it will take the path. If you don't give a path, it will tell you about the entire system. This is valid for both Mac and Linux. Now let's see the other command. The other command is du, which is our disk usage. So let's go through the man du, and it's estimate file usage. And if you say du -kh, again the same options. K is for kilobytes, H is for human readable, and in fact K doesn't make much sense because human readable itself will give you everything. So this takes like /dev takes 208k bytes in terms of 208k bytes of data. If I go to my home directory, which is home Shakil, and if I run the same command, it takes like 7.1 gig. Same thing on the Mac, du -kh, and if I run with my home directory dot, it will tell me my total usage. My Mac is using much more, so it will take time. I wanted to interrupt that. So if you can give a path also, that will work. If you give a path, it will take the entire system, / means entire system, and it will give you the path of the entire system, disk usage of the entire system. If you say dot, it will take for that. If you give any specific folder, it will take the specific folder and give the disk usage for a specific folder. If you give /temp, it will give you the disk usage of that particular folder /temp. And mind it, when it gives the disk usage, it sums it up for you and gives you at the bottom. And again, using awk script, you can extract this information and use it for some particular purpose. So let's see, if I have a lot of user in my system, let me see how many users I have, and I wanted to find out which all users I have right now. One user. Okay, so if I wanted to run out all the users which is using more than certain threshold of files, I could trigger a script which will calculate everything and send a mail to the system admin. You could do something like that. So what you can do is, let's suppose du -h, and you try for home, and for each of the home you will have home Shakil, home John, home blah blah blah. You can extract this with the awk, take that and use a send mail command to send a mail. So you can construct a command like that. Okay, then let's look at the next useful thing. Next useful thing we would like to see is lsof. lsof means list of open files, and by that what it means is, when you open a file or when you use certain files, there is an open file descriptor associated with the kernel, and that gets created. That open file descriptor has a limit. It cannot be infinite. So let's see, if I say vi abc, when I do vi abc, there will be open file descriptor corresponding to this abc. Let's prove that. I am going to another terminal and then lsof will list out all the open file descriptor in my system. There are a lot of options with respect to lsof. You can explore that. It's not so important to know for all the options, but typically I use the generic lsof output, and I use my awk and sed and whatever to extract any information. So you can read through the man page. So we were talking about that this new file abc I have created, abc, and this is opened. So whether it will be reflected in lsof or not. So you say lsof pipe to grep, typically you will say okay. So you see here, when I grep with abc, there are other things also which is coming up here. My Dropbox is open, so it's not a very good options of greping. So let me change the file name little bit so that it's easy for us to grep. Now we could have done it with a better precise grep, so but for the timing I'll say 1 2 3 4 5. Okay, now say like this. So you see here there is a gvim. When it opens a file, it creates a swap file, and this swap file is opened. This is opened by the vi. Then the next option is these numbers. What are these numbers? So if you go at the top, or maybe you can do lsof pipe to more, you will see that what is the option. So first field is a command followed by PID. TID is the thread ID, which user is using, file descriptor type, device, and where is the node name, permission denied, blah blah blah. So in the same way, if you see here abc, it will tell you the process ID. So this is the process ID of my gvim. I can also say ps minus ef. ps will give me the process ID. So ps will list out all the process ID, and within that process ID I can list for the vi process ID. So ps minus ef grep for 31460, and I can see that 31460 is using vi. So this lsof comes very handy when you are inspecting lot of open files. You are writing a spurious file which just keeps on opening a file descriptor without closing it. Your system might get stuck, and it might get stuck in such a way that even fork will not work at after a certain point of time because of resource leakage. So how do you troubleshoot? So you use lsof, and let's suppose you have a process running, and that like we have seen here, that Dropbox, like if the Dropbox has infinite number of processes, it means Dropbox is leaking file descriptor, and it's a spurious process and I have to fix it or kill it. That's the way to troubleshoot. But if something is utilizing large number of file descriptors but it is not increasing, it still means that maybe the program is very heavy, it requires large number of file descriptors, but it should not keep on leaking continuously, which means it should not keep on increasing over a period of time without decreasing at all. So let's see this. If I count lsof pipe to grep Dropbox, let's see the count. So okay, I'll see the count. So I'll say wc minus l, pipe to wc minus l. Okay, Dropbox probably is small d. Okay, so if you see here, what I did is I took a lsof output, and in that I grepped for Dropbox. It gives me all the output, and then I piped it to another command which is called as word count minus l, and it tells you the total count. Now if I run it again, let's see whether it increases. See, it is continuous, so that means it's not leaking. But had the file descriptor leaking something, this would have increased. So even though this number is quite large, but it's not increasing. So this way you can troubleshoot. Now in terms of lsof, we were seeing that this abc123 was being used. So let's again go to that example and say grep abc12345, and we see that this is being reflected. Now what if we exit this vi? What will happen? Let's go back and look in the another terminal whether it exists. That is gone. So when you close the file, the file descriptor gets closed cleanly, and that is no more open in the system, and it's gone. Basically you have freed up the resources associated with that particular file, and that's the nice way to do. So let me do this. Let's suppose what will happen if I write a script which just keeps on opening the same file again and again. It will make my system very bad, and it will make it go crazy. So let's suppose if I write a while loop like this, vi and maybe abc 1 2 3 4 5 ampersand and done, or maybe I'll just sleep one and then I'll say done, because if I don't put a sleep, it will excuse me make my recording go bad, because it will just keep on resources. So you see here it keeps on spawning. Now let me go to the another terminal and see grep for abc excuse me. So it's actually getting stopped because vi will not open in interactive mode, but I could have opened it in interactive mode. So the point I'm trying to make is that if you open a file like this in some loop or something without actually closing it, the file descriptor associated with that command will keep on increasing, and that will cause a problem in the system. And this lsof command will help you in troubleshooting those kind of problems. Okay, so let's try to look at another example for netstat. So netstat is a command which helps in getting network informations, ports and sockets in the system. Again, this is a very helpful command. So if I say man netstat, you can see the man page. So network status on Linux, on Mac, and the same thing if I say on my Linux, it will say print network connections, routing tables, blah blah blah. Again, this netstat has lot of options you can explore, but one option which I use, which is handy for me always, is netstat -nap on Linux. And what nap means is, n means show the IP address as numeric, a means all, and p means show me the protocol. So if I run netstat -nap on Linux, it will show me information like this, and basically I'll say to more so that I can read the header what it says. So it will tell me the protocol, receive queue, send queue, the local address, foreign address, and listen. So let's suppose if I want to see what all my HTTPS session running, I can see, because I know HTTPS run by default on port 443. So I can see all this information that Dropbox is opening a connection in my system. So again, netstat might be handy when you're trying to debug some open socket kind of things. You'll see, oh, some of the sockets are getting opened without closing, and it's infinite number of sockets or maybe lot of sockets. Those socket resources are finite in system. You cannot just keep opening sockets without closing it, otherwise your system is doomed to die. So it will help you in troubleshooting that. So you can explore this option. This is a very handy option, netstat. Same command if I run on my Mac, so netstat -nap will not work exactly, because the -p options requires a protocol information. Here on Linux it will give me the protocol by default, so it will list me the UDP and TCP both, but what Mac requires is you have to say protocol, which protocol you want. So if I say TCP, it will almost list in the similar format all the TCP port, and in the Mac if I want UDP, I'll have to see -p UDP. So these are the small nitty-gritty difference of commands between Linux and Mac, but most of the basic tenets of POSIX programming remains the same. In terms of POSIX, they are same. The command behaves differently. So that way, if you are parsing the command, going through the grapes, extracting something, you might have to test it on different platform, on Mac, Linux, Unix, Solaris, whatever, blah blah blah. So that's the way netstat works. Now one more thing I wanted to bring to your notice is that by default many of the Linux command will not work on Mac. Now when I say many of the Linux command, that I don't mean the native Linux command. What I mean exactly by is some of the extra commands like maybe gvim as an editor, or maybe curl library and everything. So there is an open source project in Mac which is called as MacPort. There is another project called as Brew also. So you can use the MacPort. And how you can use the MacPort is go to this link macports.org/install.php, and depending upon your system you can download this dpkg file, or maybe dmg file, not sorry dpkg, that's for Ubuntu. You can download the dmg file and open it and install it. Now once this is installed, I already have it, so I don't want to mess around with my system. Then you can say sudo port update or self update, and you can give the password. So there is update. Right now my platform is not recognized because the platform is up to 16 is supported, because I have very recently updated my Mac, so I have to do a special process to update my port. But that's the way it will work. And you can also say sudo port self update. You can also say sudo port install gvim. So these are the commands you can work. So there are a lot of other options here in sudo in MacPort. You will have to install this and try some of the commands. So this MacPort is also very handy when you are doing different kinds of developments and you want to check something on Linux, check something on Mac. This will come as handy. Thank you all for watching this video, and I hope to see you in my next video. You have a nice day. Bye. Hello and welcome, friend. In this tutorial, let's try to look at some of the commands with respect to Linux. These commands are only provided by Linux, and that is the reason I'm not showing in Mac OS X. So this is just my Linux box, and let me run some command. Okay, so the first command which I would like to show you is called as lscpu, and if you remember, ls is the one which we used to have for file listing, ls-l, which is an option, or just ls. So they have created something similar name, but it's altogether a different command. So if you want to list out all the CPUs or the type of CPUs, you can use lscpu. And now if you check lscpu, it will tell you your CPU architecture, model, Indianness, exact model name, family, everything. This information can be extracted not only from CPU, also lscpu, but you can also get that information from proc CPU info, and that's just a different way to get the same information. However, with lscpu ls command, there is not just lscpu. If you want to list out the USB devices in the system, of course you can look at the proc file system also, sysfs, but with LSUSB you can see how many bus you have and different kinds of devices to that bus, and what is it a 2.0 bus, 1.1, 3.3, everything it will list. There is something similar command for lspci, and it will also list you all the PCIs. So now if you see, this is my virtual machine VMware. So if you see the bridge name, all the PCI bridge name starts with VMware. If you are working with this, or if you're looking into this with real hardware, it will have the name of the real hardware rather than the virtualized environment. So this will show you all the hardware statistics of the system. Now, other interesting thing with respect to hardware in statistics, there's a command called DMI decode. So I need to be sudo to run that, but let me just become sudo altogether so that I can run this command at different times. So now say DMI decode, and if you run DMI decode, it will give you all the BIOS information, system information. So BIOS or DMI informations. DMI is desktop management interface, which gets some of the informations from the BIOS, and then there is something called as SM BIOS. People say that SM BIOS and DMI are the same. So this SM BIOS or DMI get the information either from the sysfs, which is from your kernel sysfs, or it will get some of the informations exposed directly by the BIOS, the firmware from the BIOS. Okay, now let's look at some specific thing. If you want to look at the BIOS version itself or the BIOS details, you say DMI decode -t BIOS. So what it will give you is, it will tell you that this vendor is for Phoenix Technology. Because the Phoenix, why it says Phoenix is, even though it's from VMware, because VMware uses a emulated form of Phoenix firmware, because Phoenix was a very famous company at one point of time which used to make the BIOS. And then it will tell you some more details with respect to battery and everything. Many of the details might not be valid or applicable to the virtualized environment like VMware, but if you run the same command on real hardware, you will see all the details, real details. So means the details are good, but it's all virtualized. It's not that it's fake. Now if you want to look at the processor information, you have to say processor instead of BIOS, and you can see the processor information. Now if you see here, you can also see for the processor your L1 cache and L2 cache, how much cache memory you have. It will tell you that kind of details. And if your company, or if your company has created a BIOS with respect to asset tag, or they have put a serial number, you will get those informations also with respect to processors, the ID of the processors, all this kind of informations you can get. Then there is an option called as -s system version. If you say system hyphen version, it will list you the version. For it says none here because there is none of the versions listed out, but if you go to some real hardware, it will again tell you the system version. And then you can also list out the system serial number also. Now since this belongs to a VMware, so it will tell you the VMware serial number, because VMware puts this serial number to recognize between two different systems, so they have to use the serial number. Let's go to DMI decode and see what is there. Now if you go into DMI decode, that you will have the options like -t memory file, -t type. This is interesting. So it will basically tell you what type of information you need, and if you come below, it tells you all this. So if you see here, type 6 is your memory, type 5 is your memory controller, so you can give those options. So let's see. If I give DMI decode -t6 is my memory, so it will tell you my memory module. So it will tell you, okay, which DIMM is populated, what is the kind of socket, whether it's installed or not. So see, I have this DIMM size installed, not installed. That means this DIMM is not populated. Again, this DIMM is not populated. This DIMM is not populated. And then something which is populated would be on the top. You see, it is installed 8 MB single bank connection. So it will tell me the listing which is installed and something which is not installed. So I can just make out how many DIMMs I have in my system, and it will list you all the things with respect to DIMM. Same thing with DIMM controller, you will see the controller details also. So you can explore these commands like lscpu, lsusb, lspci, or DMI decode may not be useful all the time, but at the same time it needs to be good when you have these commands handy. Sometimes it is helpful. So I would not say spend too much time, but just keep it in mind that whenever you need this kind of informations, you can refer to these commands, and at that moment you can just either do a Google, or maybe just make a note of yourself, keep it somewhere, and just use it as a reference later on. So thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye. Hello and welcome, friend. In this tutorial we will try to see how we can format a disk or attach a new disk and format it. So again, this is a dangerous environment, dangerous exercise, and you exercise precautions when you're doing this. I would appreciate if you can do it on a test machine, in which if there is something which goes bad, you can still afford to lose that data. You can do an experiment in those kind of disk. Now typically you will do this experiment on a machine in which you can maybe attach a disk and do that. Now since I'm showing it in a virtual environment in my Mac, so I would do it in a VMware Fusion, and it will be the exact same thing except for few steps difference. So I will tell you what is the exact difference. Now this is my virtual machine where I want to attach a disk. So in real case you will attach one physical USB drive or whatever you have, but here I will attach one virtual disk to this. So what I will do is I will add one device, and this device would be of type hardware. So it's a new hard disk. I added new hardware and maybe 50 GB space. So I would say 50 GB, and I will not split this file. So this is the only step which would be different in real hardware. So in real hardware, you will attach a 50 GB disk physically, and in virtual machines, I am going through the menu and attaching it. Now let me boot this device. So once this device boots up, it will display my new device as DevSDC or SDB, whichever is the next compared to my previous device. So if my first hard drive was DevSDA, this new device would be DevSDB. And if I already have two devices, SDA and SDB, and if I add one more, it would be DevSDC. And within that device, I can do partitioning. So let me show you, then things would be a little bit more clear for you. Okay, it has booted up and I put the password. Okay, so looks good, everything looks good. Open the terminal. So let me become a sudo first, then because I'll type several commands. Now if I see here that what all the devices are present, then I can say fdisk dev sda, and I can say print. This is 200 GB, so this is my previous disk. You remember I have given a disk of, and -l will also list it, so you don't need to go to the prompt to display with p for fdisk. So fdisk command will accept prompt also, and it will accept -l for listing. So if I'm listing dev sdb, you see this is a 50 GB disk. This can also be confirmed with dmessage. So dmessage is the utility to look at the kernel ring buffer, and if you run dmessage, somewhere you will see pipe to grep sd, and you will see that there is a device sdb attached. So sd and sdb, two devices are attached. Cool. So we got the raw disk. Now this disk needs to be partitioned, formatted and mounted. Partitioned, formatted and mounted. So how do we do the first thing, partition? For partition, you will use fdisk. You can also use parted or maybe other utilities. It depends. But since we have a MBR based disk, we will use fdisk and dev sdb. This is the name of a raw disk. So whenever you are doing a partitioning, you have to do on a raw disk, not on. And once the partition becomes, then it might become automatically FDB. So if you look at dev SDB, there is no SDB1, just SDB, because there is no partition. So I go with a partition, and then I need some help here. I don't know what command to run. So for help, you see it says M, run the help. Now, if you want to create a partition, it tells you automatically that add a new partitions with option N. So what you do is N and then this. Then it will ask, is it a primary or extended? We'll say primary. You could have given extended. Choose all the defaults. So 1 to 4, default is 1, 1. First sector is 2048. Just enter, select all the default. Now press P to see what have you selected. See, now SDB1 got created. And then this is the starting sector and this is the end sector. And then this is the size 50 GB. Now, do you really want to commit this change? If you want to commit, you have to say W. If you don't press W and save, it will not save. So this is done. Now, if you check here ls-l dev sdb, you will see that there is SDB1 got created. That means a partition got created. So we did the first step, the partitioning is done. Now when you look at the partition, it might have chunk data, because when you take a disk and you can run through dev sdb1 to look at the data, it might have many chunks data. So it depends. Some of the disk which has been all zeroed out, it might have all zeros. It might have junk data if it's an old previous disk. So you have to format it. The next step is format. So depending upon the file system which you want to use, you can format it. Typically in Linux environment, people use ext4, so I will use ext4. and I will format this using dev sdb1. Then this is formatted, the disk is formatted. Now once the disk is formatted, you have to mount it. So before I'm mounting it, let me show you what is the available space on this disk. So if you see here, my existing disk is 200 GB. So if I say df minus kh dot, for the current this shows you 200 GB. So what I will do is I will create a mount point slash mnt slash my disk, something like this. And what I will say is mount minus t, and the file system type. The file system type for this extra 50 GB disk is ext4, which we have created. The name of the partition, is dev sdb1. Where exactly you want to mount? mnt my disk. So this is the options. Let me repeat: mount followed by minus t, and then the file system type, the name of the device which needs to be mounted, and where it needs to be mounted. This got mounted. Now if I go to the slash mnt my disk, and if I run this previous command which we have run, df minus kh, to know how much space available, it will give me 50 GB. You see, this is now giving me 50 GB. So we created a partition using fdisk, then we formatted using mkfs.ext4, and then we mounted the drive using the mount command, and it's complete. So this device, my virtual machine, has two disks. One is dev sda, which has got two partitions, which is separate, we don't care about that. But the new disk which I have created has got just one partitions. If we wanted to have multiple partitions, so when we were doing fdisk for dev sdb, and then we say partition p, and when we want to add a new partition, right now there is no space, but when we were adding with n new partitions, it was asking for the starting blocks. So starting blocks we can still give 2048, but ending blocks we should not leave it as default. If we leave it as default, it will take the entire disk as a partition. So we could have given half of the size, like instead of 10.04857.599, we could have given 584 whatever, blah blah blah. So depending upon the size, you have to calculate the size and give it. All these things can be automated using the fdisk command also. So this way we can just ensure that we can format a disk, mount it, and use it. And the file system depends upon usage. You might use ext4, some might use vfat, fat16, fat32, whatever. It depends. You may also use ntfs, and ntfs might be only used as read-only mode by default. But if you want, you can enable the kernel debug mode and write mode for ntfs, which is supported in Linux now. So thank you all for watching this video, and I hope to see you in my next video. You have a nice day. Bye. Hello and welcome, friend. In this tutorial we will try to look at a command called nmap. And if you look at the options for nmap, if you look at the man page for nmap, then it will take you that it's an exploration tool and security scanner, and also a port scanner. So what is its use? So nmap can be used for finding out open ports, or maybe some vulnerabilities, or maybe some of the protocols being used which is a vulnerable protocol or a weak protocol, weak cipher. Those kind of things you can use for nmap. Typically when we use the nmap, we can give nmap and followed by the IP address. Now by default nmap might not be installed in your Mac, and for Linux also it will not be installed, so you have to install. For me, what I will do is, this is my Mac as listed, and I will try to explore my Linux machine, which is a different host. So I have already installed nmap, and the way to install nmap is, if you already have a port installed, you could say sudo port install nmap. And if you have missed my previous sessions how to install this port, this is called as Mac port. This port has nothing to do, by the way, this port has nothing to do with the port of TCP IP, those kind of ports, but it just means a porting of the software. And you can say Mac port, and you can go and link for this Mac project. So this Mac project, what it exactly, you can go for the download somewhere here. Okay, so this port, what exactly it will do is it will take the open source software from Linux and they will try to compile it, make it Mac compatible so that it can compile and install on Mac. So that way you can install the port. So sudo port install nmap and nmap will be installed for you. Now by default, when you give nmap followed by IP address, that might be a little crude way of doing things. So we would like to be more precise, and by precise I means we can provide options. So there is an option called T4. T4 means it's a timing. So there is the timing between 0 to 5. The higher means make it more faster. You could have make it 0, which would be slower. So we make it faster. And faster means how intense your scan would be. So it depends upon the algorithm. And then -a, if you want to detect the OS type of the remote host also, then -v, which is a verbose. Now if I run this command, you see what's the output. See, it has tried to open, find out that in the remote host port 22 is open, and of course that is what I have shown in a previous video, that I was doing a SSH to my Ubuntu device, Linux device, using port 22. It says it's open, and it was fortunately able to also identify what is the remote host type. And if you see here, it tells you the operating system Linux followed by some time elapse. Let me try to run the same command against my router, home router 0.1. Let me see what it says. This router is from Netgear. So let's see. So for router, the OS might not be Linux. They might have some embedded OS. So it might say something differently, but it should still be able to find out some of the open ports. Like if your port 80 is opened, nmap will be able to scan and tell you, okay, port 80 is opened or some port is open. So let's see. So it is scanning 2 services, initiating scan. Okay, let me see how soon it completes. Otherwise I will have to terminate because I don't want to extend the video just waiting for this. So hopefully it finishes in time, but you guys can also try running this nmap command against different devices of yours, and you can find out vulnerabilities that way. I have a Windows machine also, by the way, so let me try this virtual machine Windows, and I can try on that. So the IP for this virtual machine is 240.139. so I will terminate this and run against 240.139 because I don't want it to wait. So this is here, host seems down if it is really up but blocking. So you see here, now this is very interesting. What it says is the host seems down if it is really blocking, but we have seen that this host is running, this Windows is running. So what it means is the firewall might be blocking the ping. Okay, so let's do that. Let's go to my Windows machines, go to the control panel and disable firewall for testing. So there is the Windows firewall, and then we will run. So this firewall I will disable for Windows. So I turn off. Okay, cool. Now let's run this same nmap command against my Windows machine. What does it says? It says host is down, read data files from user local but blocking our pin probes. So maybe Windows Defender might be playing the role of just blocking the IP address. So let me see, is there anything else we can do to enable this? Okay, let's see this Windows Defender, and excuse me. Okay, let me see this again, the IP address, to confirm that we are scanning the right host. So yeah, it's right, it's blocking. Let me try one more host, which is my device outside this network, so which is 0.200. So 0.200 is again another device of mine, which is Ubuntu and which is also detected. Then let me try one more device 100, which is again another Windows device, It's this guy is 100 is a Windows. Now let's see on the Windows on another system. I can see that it says that port 443 is open. So basically HTTPS or TLS sessions 135, 554, 912, and then it's still doing some more scanning. So you can try to list out all the open ports with respect to nmap by running the command against it. And on Windows, if you want to be more UI friendly, you can also search for nmap installations on Windows. So there is a nice GUI with respect to nmap. You can download and install. So you go to nmap.org and then you can download from nmap.org. Nice GUI. You have to explore this and just install one of the package from here. Same with the Linux, but if you want things to be automated, you can install the command line version and run as a script. If you have seen this Rapid7 and other folks of Metasploit for port scanning and vulnerabilities, mostly they will use TCP nmap, and within the nmap they will fine tune many of the options or try to do more intense checking, but the core is nmap. Thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye. Hello and welcome, friend. In this tutorial we will try to look at how we can do a SSH and STP to a remote terminal. This is my Mac OS X and I would like to SSH to my remote Linux machine. Now how do we run that command? So the command to run for SSH is SSH then followed by the port number. By default for SSH the port is 22. So if you don't give this port number, that would be fine if you are using the standard port 22. However, if suppose you are using a port like 4 times 2, then you have to specify the port. So to be more precise, just give a port number for now, and I give a username for the device where I want to connect, and what is the IP address. The IP address would be 192.168.240.130. This is my IP address, and at the same time I can give a capital Y or capital X options. What this signifies is that the display from that particular host would be exported. So which means if I open a GVim editor in my Linux, I can look in my Mac as a GVim editor. We can look into that, and then followed by provide a password. Now if you see here, this is my Linux machine. It is no more my Mac, which is a Darwin kernel. So it's my Linux. So I logged in from my Mac to my machine, Linux machine, through SSH. Now like I was said that when I run a gvim command, it would be exported. Now you see this is a Mac, but this Mac is actually on the Mac. The VI editor which we are seeing, this doesn't belongs here. This VI editor is actually coming from my Linux, so it's actually from here. But since the host is exported with -y options, and I have also set X host plus, that will give you the GVim console. So this is the way you will do a SSH. Now let's suppose I wanted to SCP the file. Let me open 2 tab and make you comfortable with this. So this is my Linux machine, and then this is my Mac machine. Now let's suppose from my Linux machine I want to copy this log file to my Mac desktop. In my desktop I don't have any file now, so there is no file called as log. So let me copy this. So the way to copy is SCP, and then again you can give a port, but this time for port it should be -p, which is in capital, not a small p. So this will not work, -p, and again depends. So now if you give the port as 22, which would be default, if you don't give, it will take automatically, you don't have to give. But if you are using non-standard port like 4 times 22, you have to specify the port, and then the username of the remote machine and the IP address of the remote machine. So the IP address is 192.168.240.130. So this command is for connection. Now once you connect, where exactly you get the file from? So the file I get it from home Shakil, which is my home directory, and inside that home directory I have this file called log.txt. So let's go through this command again. SCP, which is the command, then it specifies the port, which port the SCP will use. The SCP by default uses port 22. This can be omitted, but we have still given. Then the username to connect, followed by @ the IP address, and then from which directory you want to copy the file. Now where exactly you want to copy the file, I can say dot means in my current directory, and I can give the password of my remote host. Now if you see here, I got a file log.txt here coming here. I can open this and I can open the logs and I can see all the details for my log.txt. So this is the way using SCP you can open a terminal and you can log into a remote machines. Alternatively, if you're using a Windows machines like this, let's suppose, let me go to this Windows machine. If you're having a Windows machine, you can use just the PuTTY session, and in the PuTTY you can specify the IP address 192.168.240.130. then here you can specify the port. By default for SSH the port is 22, don't mind. And then the X11 forward also you can enable. The reason I was saying is that if you are using the GVM from the Linux on this, if you want to export the terminal, you will have to enable the X11 forward and say open, and then you provide the username and the password, and that's it. It works. Okay, cool. Now what if I want things to be handy? Let's suppose I want my things to be handy and I want to do a very quick login. Okay, so what I did in my system is I will just first run it. So if you see here again, I logged out. This is my Mac now, and I want to log into my virtual machine. So I have created one alias, and you see how fast I can do that. Now it's my alias, it's all logged in. Now if I see here, this is my virtual machine, which is Linux. So how did I do that? So sometimes it's very handy to be fast when you are logging to different systems. You can create some kind of a alias, so that if you run the alias, the command gets executed automatically and you're logged in. Okay, so let me show you the alias. The alias which I have created is like this, LU. Let me expand this and explain to you. Okay, let me decrease it. Okay, so what I did is, there is this binary called SSH pass, and SSH pass you can install on Mac, Linux also. I have installed on Mac. And if you're not able to get that, what you have to do, I have shown you the to install Mac port, right? So once you install the Mac port, so you can say sudo port install SSH pass. I have already done all these steps. I don't want to mess around again. So but you can do like this, it will install SSH pass. So the syntax for SSH pass is like this. Let me say, so you'll have to say SSH pass, which is your binary, then followed by the password. I have kept the password P only, just the password, whatever you can say. You could have said password is password or password one or whatever is your password. So I kept the password P for demo, then followed by which is the actual command. Your SSH is the actual command. Which port to connect, -P22, or you can give like this or you can give like this, both of them is fine. -O strict host key checking, again this is optional, you can give or you don't give, it doesn't matter. So what this implies is, sometimes you have a machine which has one IP address, it has one fingerprint. Now you take that IP and assign to some other device, the fingerprint got changed, so it will ask you and prompt you that there might be a man in the middle attack. Do you want to continue? Do you trust this certificate? Those kind of things. So it will check very strictly. If you don't want it to check very strictly, you say no, which is unsafe, because I know it's my home environment. I can look that. In development environment, or not, sorry, in the production environment, it's not advisable to do that, but still I'm doing it. I know it's secure for now. I know my environment, so I use that. Then followed by username and @ of the IP address. So this is the command. SSH command is this much, is the usual thing which we do, and then on top of that we say automatically SSH password and we give the password from the command name. Now it logged in. Now same thing, now what I have to do, it make it as alias. So I will say alias and give some name R, suppose remote system RS equals to, then in the single quote you give this. Now next time when I say RS, it will log into my virtual machine. So this is the way you can create a alias so that it will make you handy and it will make you fast, so that you can log to a remote system very fast, do your work, log out back. Because otherwise if you go to the putty, it's very tedious that open a terminal. So let's suppose I open the same terminal again. If I close it, then it's very hard for me. I'll have to save it. It's still okay, but it's hard for me. Like so many servers are there, I can create. I have some other alias also. Like I create an alias L, and then I automatically calculate the prefix of the IP address, and I can substitute the last digit. Those kind of things you can do very handy in Linux, but in Windows it becomes difficult. But it again depends upon your use case, your comfort level, whatever way your comfort. I am comfortable with SSH command line all the time. So thank you all for watching this video, and I hope to see you in my next video. You have a nice day. Bye. Hello and welcome, friend. In this tutorial we will try to look at a Linux command called tcpdump. Now I must not say Linux command because this is available in Windows and Mac OS and other places. So this is just a utility. That's the right word for that. And what tcpdump does is it takes a network statistics, a dump of a network traffic. The name says TCP, but it will work for UDP and other protocol like NetBIOS and all those things. It works for almost everything. It supports all kinds of protocols. If you take Wireshark, Wireshark internally uses this TCP dump engine only. So how do we use TCP dump typically? So typically the TCP dump command you run is TCP dump -i followed by your interface name, typically eth0, eth1, ENS, whatever. That's the way it works. So this is my Mac and this is my Linux. Now let's suppose I want to monitor my Linux from within my Mac. So how do I do that? So before I go about monitoring, let me tell you something. This is the virtual machine hosted here. It's a VMware workstation. If you see here, it's hosted in VMware workstation as a virtual device, virtual machine, VMware Fusion. Now this VMware Fusion device is connected to my bridge VMnet 8. This one is 8. I know because I connected it. So what I will do is I will say TCP dump followed by I, interface name, VMnet 8. And if I do that, what will happen is I will have to also do sudo. So I will, you see, I will get very frequent data like ARP request and those kind of things. So I can filter down further, but let me do one thing. Let me do a ping from here. I will do a ping to some IP address or host name. So if I do a ping, you will see there will be a corresponding acknowledgement for the ICMP packets, and this is hosted, this rediff.com is hosted in using Akamai infrastructure. So I will see that there is an ICMP response also. So you see there is an echo response, there is an IP response. So let me terminate this. Let me make it little bit better. So I will put some kind of a filter. So I would say -n, which is a network, and I would say destination. So let's suppose this machine tries to send a packet to rediff.com, and when the packet comes back from the rediff.com as a response, it will travel through my Mac and then it goes to the virtual machine. So when it travels through the Mac destination port, when it receives the packet, would be my virtual machine. So here I will give the name of IP address of my virtual machine as the destination. So 240.130. Now if I run here, I will not see much of the traffic. That looks clean. And then let me run the rediff.com ping. Now you see here for each of the packets which travels, which is this response we are getting from rediff.com using Akamai infrastructure, that comes to my Mac machine, and from the Mac it is traveling all the way to my VM. So this way we can filter the traffic. So you can filter the traffic based on the port also. Same thing, you can say port 22 something in single quote. That way you can filter that. Now for diagnostic purpose, sometimes it might be useful that not only you capture this packet, but you might want to send it for some analysis to your engineers or something. So what you do is you can say minus S0 and then say VVV. This V means verbose, and as many V you added. If V is verbose, then 2V means more verbose, 3 add means more verbose, and then you write to a file, and then you can say abc.some pcap file. Now when you run this, there will be a pcap file generated, and you can run some messages, some ping, and this would be taken in the pcap file. Now let's look at the pcap file. So if you look at our pcap file which we have generated as abc.pcap, it is having 8048 bytes. Let's try to do a cat of abc.pcap. It looks like binary data. You are not able to make any sense out of that. So how do we interpret that? So the way to interpret that is you can say tcp dump, and you can run through the options QNS 0 minus capital X minus R and the name of a pcap file. Now if you run these options, keep it as in handy, you can see all the details of a packet. This looks awesome. What are all the data is there, its ICMP request, length of the data. Now this might be overwhelming if you don't understand TCP IP or networking, but don't worry, many things we don't know we explore when the need comes. But at least it gives you an exposure that there is a command which exists, and you could do this kind of things, and you don't need to struggle hard to learn TCP dump now. But when there is a need, you can just follow up all the man pages or maybe other tutorials. So thank you all for looking through this video, and I hope to see you in my next video. You have a nice day. Bye.